Hi, everyone, and welcome back to Flower AI Summit 2026 Day 2. This is the unofficial industry day, so we have a very packed agenda coming up. You can find it on our website, which is flower.ai, if you're interested in knowing exactly who will speak and what about. But yeah, very excited to have everyone here. I see people are already posting in the live chat, so that's great. Keep asking questions and put your comments down there. We'll try to run any questions that you have by the speakers, if it's specifically for the speakers or if it's for us here at Flower Labs, just feel free to ask more questions. But yeah, we're getting started in a couple of minutes. It's Nick Lane, from one of the co-founders of Flower Labs. He will introduce Day 2 up on the main stage and also talk a bit about what we can expect from the rest of the day. But yeah, excited to be here again. You'll see Shong Shen, who you saw yesterday, research engineer here at Flower Labs. He will come down and talk a bit more with guests coming in throughout the day, and then I'll be back by the end of the day as well. So yeah, continue asking questions. We will be here the whole day and doing the live stream. So if you want to interact with anyone here, feel free to do so. And you can also join our Slack. This is on as well on flower.ai and then /join Slack. And you can join the channel Flower AI Summit 2026, where you can ask questions. The questions will be stored and the people can go to see them as references if there's anything people would like to take a look at. Yeah, so soon we will go up to the main stage. It's a couple of minutes left. People are coming in by the masses. We had a very big day here yesterday. We had a couple of fireside chats, bunch of speakers talking about very broad variety of topics when it comes to federated learning. So you can go to the live stream from yesterday. This is a recording that is already up on YouTube, and you can see what it was all about. So you can select, cherry pick the ones that you really want to listen into. And that is definitely, we'll keep it up there. We'll probably do some other sort of short form content when it comes to the speakers themselves, and also what you can, all the material will be made public, so you can take a look at it online. And if you're interested in reviewing any of the code that we have, you can also go to our GitHub. This is flowerlabs/flower. There you'll find all the code that we work on and post. And if you want to try out any of the examples, get started, we have some beginner-friendly material and also courses on deep learning AI that you can get started with. This is a 2-part course, so introduction to federated AI and then also how to fine-tune large language models. So 2-part course, it's for free. So if you want to get started, that's a great resource. And then you can also, as I said, go to our GitHub and just play around with different sort of examples, and you'll see how it works in practice, whether you just want to test it out in a sandbox environment on your own computer or actually deploy it on different sort of computers. You might rent instances in the cloud. You can do that as well, and just spin up a federation where you can run decentralized sort of workflows. This could be for large language model, computer vision, different sort of tasks. So take a look at that and continue asking questions. We love when questions come in, and we try to always take a look at the live chat to see what's going on. So keep asking your questions there. I see there's one. I would like to know whether Flower provides built-in support for decentralized serverless yeah. We'll probably talk a bit more about that. I'll try to get to it in the chat. I know that there is some material on this, so I'll get to that one. But continue asking questions. We'll be here all day, and we're going to the main stage right now. So yes, stay tuned for more. And Nick Lane is coming up. So yeah, it's exciting.
So welcome everyone to Day 2 of Flower AI Summit 2026. I think it's safe to say Day 1 probably has been the best day ever of the Flower AI Summit series. We had incredible launches. We had amazing talks from the community, from people we've been working with for many years, organizations like Red Hat, universities, had so much to offer. But what I can say is that day 2 is going to be even better, because today we're going to do deep dives into what federated and decentralized AI is doing in many different application domains. We've got even more announcements for you, and we've got a real nice mix of Flower announcements, community talks, and partners coming up through the day. We also have 2 more firesides and an incredible action-packed panel at the end that's going to look at what is going to happen with federated learning moving forward, with about 6 people from a range of backgrounds, really sort of diving into that topic. So let's kick things underway for session 1. I'm really happy to introduce Sean. Sean, actually, I've met a number of times here at the AI Summit here. Sean is at Ulster University. He's been coming for a number of years, building up a number of different prototypes and pieces of research in the federated space. And then this year, he really had something special for us to show him. And so I thought of no better person to kick off things for day 2. So over to Sean.
Now the dreaded setup. It's good. Oh, sorry. Yes, hello. My name is Sean. I'll try to remember to speak into this. My name is Sean O'Fittley. I'm a PhD researcher from the Ulster University, as Nick was saying. And I'm going to talk today a bit about resource-aware federated learning framework for networks of constrained devices. In a former life, I was an electronics engineer, so I'm very interested in microcontrollers and IoT sensors and that type of thing. So I'll just get going before my time starts running out. So a resource-constrained device is any device that has a finite set of resources that are not easily renewed or replaced. Oh. That was weird. Examples of resource-constrained devices would be wireless sensor nodes, wearable health monitors, industrial IoT sensors, smart home sensors, and vehicle telemetric sensors. These are basically the types of sensors that are deployed out into the field, and they're not renewed, they're not repaired, nobody's going to investigate them if there's an issue, they're just left to it. And as always, there are challenges with working with resource-constrained devices within federated learning. And they're the types of challenges that we're all very familiar with. It's just within a resource-constrained environment, they're just a bit more amplified. So for communication bottlenecks, resource-constrained devices use low power or low bandwidth protocols. So transmitting large battery or large models back and forth can drain the battery power quite significantly, and it can also lead to network congestion. System heterogeneity, such each of the devices could have a range of different system architectures. So you'll have different compute power, memory, communications capabilities. And again, this can make it difficult to coordinate training across a large network of devices. Then there's data heterogeneity. So each device collects data locally based on its environment and its use cases. And again, when you throw in the various system architectures on top of this, you're going to end up with a very sort of non-IID data set. And as we all know, this will slow things like convergence and could potentially produce biased models and models that just don't generalize very well. And for me, I think the main sort of issue here is the resource constraints, because selecting per devices for a given task is going to slow down your whole training process, your model convergence, and it can lead to the potential of devices failing mid-round. So the problem that I'm looking at is that federated learning on resource-constrained devices faces amplified challenges, and existing approaches addresses them in isolation, leaving networks that are inefficient, unreliable, and hard to manage holistically. And from my point of view, working with these types of devices, what that leads to is just having not an awful lot of trust in the network. And as I said, when these devices are sort of being deployed and out in the field, if you don't have trust in what's coming back to you, you're always going to have a bit of a question over your results. So our approach is a knowledge-driven orchestration framework that jointly addresses communication, heterogeneity, and resource constraints, selecting only eligible clients for each task. So it all sounds very formal. In trying to develop this, I have come up with a kind of a conceptual framework. I'm still obviously working on a lot of this as I'm sort of just about a second year into the PhD. So at the minute, what I'm interested in looking at is really this knowledge representation layer. And this takes the form of a knowledge base. So it's a graph-based repository of device and task information. So the knowledge base will hold up-to-date or sort of like real-time snapshot of the resources of the devices within the network. And it will also hold information on the types of tasks that the network can complete. Some of the properties and parameters that we're interested in is the likes of CPU speed, memory, battery level, and bandwidth. These can be extended out, so if you've got GPUs or accelerators and that type of thing, all that information can be included in the knowledge base as well. One of the approaches that I'm interested in taking is around intelligent clustering. So I'm looking at a multi-parameter dynamic cluster formation. So again, with the just different range of parameters that we're looking to have in the knowledge base, we can cluster on any or all of those. And it's a dynamic clustering formation, which means that whenever an assigned task has been completed, the various clusters can break apart, and then they're available for assignment in the next task. Or if we find that a device in the middle of a training process or in the middle of the loop has dropped below an acceptable level, that device can be removed from the network and another device slotted in. There's an eligibility condition too. It looks very formal there in the equation, but basically what I'm trying to say there is that when we form a cluster, every device within the cluster has to meet one of the requirements needed to complete the task at hand. So to try and prove out what we were doing here, I came up with a little bit of a proof of concept design. So I simulated a network of 10, 50, and 100 devices. There was 30 selection rounds, and the task that was assigned was an AI inference task. So it's very compute heavy. I used the battery selection parameter as the sort of condition for being included in the cluster. And we can see just from the, I did a knowledge-based driven approach versus a random selection. Looking at the battery, we can see that the knowledge base is always selecting devices with an acceptable battery level. So there's enough resources within that device to complete the task. Whenever we look at the random selection, we can see that on average, it will select devices where the battery level will deplete down. I should also say during each training round, the model, the way it works is it will randomly deplete the battery a little bit. So it's to try and sort of model a real world situation. I also looked at a capability score, and basically the knowledge base gives a perfect capability score, meaning every device in the network is capable of completing the task. I think it just have one final slide here. And this was looking at the client selection behavior. So the knowledge base selects only 4 to 8 devices, regardless of network size, consistently choosing only eligible devices, where the random selection, as the network size increases and more available devices, it will obviously randomly select more devices. So the key message here is a resource-aware, knowledge-based driven approach makes more informed client selection decisions a foundation for trustworthy federated learning on constrained devices. Thank you.
Okay, we have time for a couple of questions. So if there's folks in the audience who want to ask Sean more about this work, yeah, the gentleman just here in the middle. I'm gonna run down and give you the mic. You go.
Thanks a lot, Sean, for the presentation. And I believe that coming from the automotive domain, doing federated learning or researching federated learning from the device perspective is especially important. My question basically was that resources is constrained in most of the IoT and the vehicle scenario. One of the parameters, of course, is battery. But what, according to you, could be the other parameters that we would have to look out to, especially when the networks are switching and you don't have this connectivity for you to take a decision of who are your clients and who could not be your potential clients, because this will also keep switching, right? Yeah. So what other parameters do you think in dynamic scenarios could be your?
For me, and I have to say I haven't got fully into looking at this, I think one of the big things is going to be your keep forgetting this is here. One of the big things is going to be your processing ability, because obviously a lot of AI tasks, machine learning tasks, they're very compute intensive. And I think an additional one, as you're sort of saying, would be the bandwidth. So an approach that I want to try and take is to have say if there's an examination or sort of run through the knowledge base to find what's the most capable, say, of being like a central server or a sort of cluster of nodes, group those together that can have like a high sort of processing capabilities, and they can all sort of communicate and hand off tasks within that cluster. But I think for me, processing power and bandwidth are probably the two big ones outside of battery.
Okay, there's a question right here.
Thanks for the talk, Sean. I'm interested in as you just mentioned, compute power of devices. How do you model those?
I'm not at the minute.
Okay.
I do fully intend to. This work is sort of just very recent, and I'm trying to get it published at the minute, and the reviewers are kind of doing their thing at the minute. Of course, yeah. But no, that's going to be one of the big sort of critical things that I need to do. I'm kind of hoping my electronics experience comes into that a little bit, and I'll be able to sort of run a number of tests on different devices and sort of get a good feel for how they actually operate in real life. So.
Okay, good luck with that. Thank you.
Thank you.
Let's thank Sean again.
Thank you.
So our next talk is about Flower Hub. You might have heard about Flower Hub. We launched it officially a couple of weeks ago. What Flower Hub does is bring together the incredible energy, the incredible amount of work that's been done already in the Flower open source community, and make it infinitely more searchable, usable, more buildable in a private and safe way. And so I've got two colleagues of mine to introduce Flower Hub in more detail and tell you about what's happening next with Flower Hub. We have Jan Gao and Mohammed Nazari. They're going to tell you all about how Flower Hub is basically the next advanced evolution of the Flower open source community for everyone to build on. So with that, over to Jan.
Sorry, just one second. Okay, perfect. All right, so yeah, hello everyone. Thank you so much for joining today. Yeah, so today I'm gonna introduce Flower Hub. So from the federated app to the collaborative AI ecosystem. So this talk is about how we can move beyond isolated federated learning experiments and start building a truly collaborative AI ecosystem. So my name is Yan, research scientist at Flower Labs. And I'm joined by my colleague Mohammed, who's also a research scientist at Flower Labs. So yeah, this is what's covered today. So we're going to first introduce Flower Hub and with its core features. And after that, we will show the early traction that we are already seeing from the community. And after that, we're going to introduce two new features regarding reliability and trust. And finally, we will look ahead towards collaborative AI ecosystem. So let's start from the motivation. So why FlapHub? The collaborative AI or decentralized federated AI has advanced rapidly in the recent years, but there's some foundational challenges. So first, the applications are currently tightly coupled with the infrastructure, which makes it's hard to reuse for the applications. And third, the reproducibility across teams is still challenging. We lack a shared platform that can make the experiments transparent, consistent, and easy to replicate. And third, the collaboration is harder than it should be. So, sharing and building each other's work remain inefficient. So this slow down the innovation and scalability. And at the same time, we have amazing and incredible Flower community. So, we have lots of developers and contributors. And especially, we have more than 2,500 dependence projects. It's a massive and diverse open source ecosystem. But there's a problem. It's hard to discover. If you're trying to looking for something specific, it's hard to find, although it's already there. And even you find something, it's also hard to run it. So this is exactly what FlapHub solves. So it gives you a stable place where you can easily find, easily reuse, and easily run the applications. Yeah, so let's see what FlapHub brings to the table. We see it as an app hub for federated or collaborative AI. So with FlapHub, it clearly separates the infrastructure from the application logic. So developers can just focus on what matters on the application level. And importantly, it enables one comment portability across simulation and deployment environments. Altogether, FlapHub makes simple to share, publish, and run federated applications. So now I'm going to show you a brief demo to show how simple it can be. So let's see. This page is the overview page of FlapHub. So if you can, we go to the overview page, and so we can go through all the published app from the community. And in this demo, I'm just going to show you this app. So if you click in, go to the individual page, you will see the details of this app. And so here's the README. And we can also see there's a couple of tags which show the codes, versions, license, and verifications. So that's the two things I'm going to show you. So first, if you want to create an app based on the existing app from the hub, we can just do this command, Flower new, add the app ID. So I just copy this and then go to the terminal and paste this comment, and then it will just download the specific app you want. And after that, if you want run this app directly from FlapHub, it can also be done with Flower Run. So if we do Flower Run and then we copy the app ID that we want to run. And then maybe we add the stream just to show the log. Yeah, so basically, under the hood, it will launch the local superlink in the background, and then the superlink will download the app from the fab file from hub. After that, this will dispatch from the simulated or real supernodes, and the supernodes will run the app. So you see these already show the experimental results. Okay. Thanks. So let's go back. Yeah, as you can see with Flower Hub, the era of collaborative AI starts now. It marks a shift from isolated project to an open shared platform of reusable and trusted applications. Around a month ago, we launched Flower Hub with amazing group of launch partners. So we are deeply grateful for their support and collaborations. So they will help us to shape the platform and validate the direction from day one. So a big thank you for all of our launch partners. And we already seeing a strong early attractions from the community. So you say that we have 10 launch partners and 45 early contributors. And we already, up to now, have 100 plus apps on the hub. And these apps involves 30 plus machine learning tasks with like different 10 plus machine learning frameworks. And importantly, it covers major federated learning or decentralized AI research topics. And this shows that the need of a shared ecosystem is real and growing. So with this strong momentum from the community, what comes next? Flower Hub is just started and it's evolving. So with that, I will hand over to my colleague Mohammed, who will walk you through what's coming next.
Hello, everyone. I'm Mohammed. Thanks to Jan. And Flower Hub is indeed evolving. It started as a place to discover and share apps, and that is still important. But as adoption grows, app sharing alone is not enough. So if Flower Hub is going to support a real collaborative AI deployments, it also needs stronger guarantees around compatibility and trust. And that's the broader shift I want to talk about today. So Flower Hub is evolving from a simple app sharing to a more production-ready ecosystem. And there are two themes behind that evolution, compatibility and trust. And those are two things that users need if the apps are going to be discoverable, reusable, and safe to run. And these two themes translate into two concrete steps for Flower Hub. One is the first stable fab format, which gives the ecosystem a foundation for evolution over time. And the other one is the decentralized trust model for published apps. I'll start with the stable fab format. So this is the first big announcement that fab format version 1 is now stable. And that's an important milestone for us because Flower Hub now has a stable app format that can support a growing ecosystem over time. And stable app format matters because it gives the ecosystem three things. First, compatibility, so apps keep a clear build and validation contract as Flower evolves. Second, evolution, so apps gain new capabilities over time. And third is the coexistence. So all new apps can coexist with backward compatibility. And at the metadata level, this is declared very easily. So the app declares which fab format version it wants to target. And that defines which build and validation rules apply. But again, this is just the mechanism. The more important point here is that the ecosystem now has an explicit compatibility contract. So that covers the compatibility. And the second topic is the trust. So in collaborative AI, code runs close to the sensitive data. So organizations need visibility into what they're executing. They also need a scalable way to decide what to trust. So the main question we are trying to answer is that how do we know what's running on the client? And there are a few ways to approach that problem. One is self-review, where basically every participant reviews the app themselves. And at first, this might sound safe, but the problem is that it doesn't scale. Imagine we have a federated setting with hundreds or thousands of hospitals, and the same review work gets repeated again and again. And in practice, security can become inconsistent because review quality varies among all those hospitals. The other approach is a centralized review. Basically, in this model, we are going to have a trusted authority that reviews apps for everyone else. And this is the model that people are familiar with from platforms like Apple's Apple Store on mobile devices. And although this is like operationally simpler, but it creates a different problem for us because everyone now has to trust the same gatekeeper. So instead of the duplicated effort problem that we had with the previous approach, we get a centralized trust and single bottleneck. So what we want is a better middle ground. So this is the model that we desire, where we can have independent reviewers to review and sign apps, and many organizations can reuse that work. But each organization still keeps control by deciding which reviewers it trusts. So this reduces the duplicated review effort without centralizing the trust. So in general, this is basically is the diagram that we have implemented in Flower Hub. So we are going to have reviewers that actually they download the fab, they inspect the fab, sign it, and then they submit their signature to Flower Hub. So Flower Hub records all those signatures with the fab. And then on the other side, Flower Hub distributes both the apps and signatures. And users or operators, they can apply their own trust policy based on trusted reviewers. So Flower Hub becomes the distribution layer while trust decisions remain local. And you might ask why this works, because it scales across organizations, trust stays local, and it makes reviews reusable. And I'm happy to say that app verification on Flower Hub is available now in preview. So there's already a substantial ecosystem around Flower framework. And as also Jan mentioned, as of today, we have 2,575 GitHub repositories that they depend on Flower. So a lot of important Flower-based work already exists, but much of it is not yet visible or reusable through Flower Hub. And this is the opportunity now to bring more of that ecosystem into one place. I'm sure many of you in the audience, whether you're like researchers, developers, engineers, you already have some work built on Flower. So it's a great chance to make that work visible and reusable. It's very easy. You can publish your app on Flower Hub and enable others to, enable the community to discover your app. They run it, they extend their app, extend your app, and etc. So to summarize, we had a successful launch of Flower Hub with our partners. We now have more than 100 apps available. It is evolving from a simple app sharing toward a more production-ready ecosystem. We have the first stable fab format. We also have app verification on preview. And the next step is the ecosystem growth, which depends on having more apps being published on Flower Hub. And with that, we are happy to take questions.
We have a few questions in the room. I'll just race down and we'll start working through them. Here you go.
Hi, thank you very much for your presentation. I've got a question. What is your business model behind it? Is it people will be able to buy the app, or could they download them? So, because I think it could be a very good opportunity actually to make a good business model for it. If you build an amazing app, people may need it instead of, trying to build it themselves.
So that's not a plan for now. It's more to enable the community to make their Flower-based apps accessible for the others to run, extend, and etc. But that's not the business plan for now, to make them like paid or something. Yes.
On here.
Sorry, there is one other question, then you can go after.
Yeah. Okay. Thanks for the nice talk. I have a question on the verification thing. Do you have, or do you intend to have, a system that allows data owners and reviewers to find each other? In other words, if I have a bunch of data and I want to get, a set of reviewers that I can trust, how can I find them?
So, as Jan showed on the app details page, there is a tab called verification, and you can see all the signatures and the reviewers that they submit signature for that app. So in this way, you know about the reviewers. But I see your point that maybe someone doesn't know about any reviewer or app and they want to find it. Yeah, that's also possible that we can do that maybe later on.
Okay, thanks.
Thank you, Mohammed.
Yes.
So besides applications, can we, for instance, download benchmarks, datasets?
So this is more about Flower-based applications, yeah. But previously we had like Flower Tune, which was about the fine-tuning benchmarks and etc. But this is more about Flower applications.
One more question at the back there.
Yes.
Hey, Mohammed, question. If the app is located on the hub and was verified by certain parties, and then the owner of the app has an update, a bug fix, a new version of it, does it have to pass through the same verification process?
So that's a very good question. The verification is corresponding to an app version. So if the author of the app publishes a new version, then reviewers, they have to verify the new version as well.
Does the hub help with this?
Yeah, it's clear that if you go to, like we have some apps with the verifications, and those are corresponding to specific app version, not like general to the app.
I mean, do the owners or verifiers of the app get a notification they need to review and reapprove? Or is it, again, the all same process that the owner of the app has to pass through every time he has a new version?
Currently they don't get any notification that when there's a new version, they have to go through the process again.
Thank you.
Okay, let's thank Jan and Mohammed again. So our next speaker comes from Leeds Trinity University. His name is Anurag Uptadi. I'm just looking around the room to see if he's here. He's here. That's great. So let me tell you a bit about the work we're about to see while he connects his laptop. Federated learning has many application domains. Quite often it's about training models. You can do federated analytics. But this piece of work is going to explore the direction of reinforcement learning. And so we're going to hear about how you can do federated styles of more robust reinforcement learning for various kinds of applications out there. And I can't wait to see what we got to see next. Great, thanks.
Okay. All right. Hi, everyone. My name is Anurag, and today I'll be talking about FDRL, which is a decentralized way of training different robots, or the same robots which are performing different tasks in different environments. So to set the problem statement, you have different same robots which are doing different tasks. So one robot could be lifting an object, other one could be pressing a button, and the third one could be opening a drawer. Now, in this case, since all the robots are similar to each other, their action spaces and their observation spaces are the same. So in the sense, I would say that the data that they have is the same. The data distribution is the same. So where does the heterogeneity comes from? What is the main issue that we're trying to solve? So first of all, FRL is a pretty relatively new field. So there are not a lot of works in this field. But most of the works that exist, they directly attack the policy parameters. So policy, as you know, in reinforcement learning, decides what actions to take. So they just try to federate the policies together. But as we know, that policies are very sensitive to the task. So if the tasks are different to each other, the policies would be brittle, and sharing them would just be an exercise in regularization and not a structured knowledge transfer. So this can lead to conflicting updates and unstable convergence. The core idea behind FDRL is that we shift federation from policies to representation. So instead of sharing how to do a task, we share what the words look like and what happens when the robot is actually trying to do something in the world. So in reinforcement learning, the environment is actually evolving with the agent's action. So that's what we're trying to capture, and that's what we mean by dynamics. So we shift from just like a static heterogeneous data-based methods to a method that depends on the dynamics of the systems. And the policies, the data and the value functions for each of the tasks remains local with the client. So it's a three-step process. First of all is the local learning, where each client learns a state representation. So instead of dealing with the raw state observations, we are dealing with the latent state, which is a low-dimensional representation, and it removes the noise and just keeps the signal about the environment. And the second thing that is trained is the system dynamics. So based on the action taken by the robot, how is the system evolving based on that action? So that is what is encoded by the dynamics. And then these dynamics parameters are used for estimating the similarity between the clients. So if two clients, even though they have different tasks, but they do induce a similar dynamics in the environment, we federate their representations together, because we believe that this could help them to generalize in a much better way than just working alone in their own environment. And at the end, once we have those weighted aggregations, they're used by the local control. So it could be any of the RL algorithms. It could be TD3, SAC, whatever you want to use. That is not matter. So it is compatible with all the different methods. So the main thing is the aggregation based on latent dynamics behavior. So dynamic behavior is, again, it's a probability distribution. So how is the system evolving? So there's a distribution. Now, to share a distribution, there are many different methods. We can either share the network parameters of the neural network that is trying to parameterize the distribution, but it's a communication-heavy approach. So what we do is that we create a dynamic fingerprint. So we represent the distribution through a single vector, which contains all the information about that vector. So we call it as a naive form of a kernel density estimation. Then based on that dynamic fingerprint, we calculate the similarity between different clients. And then the last step is the aggregation, wherein we combine uniform averaging with a similarity-based aggregation. So we tested the method on MetaWorld, which is one of the benchmarks for multitask reinforcement learning. And we compared the results against different benchmarks. For the federated case, we use Fed average, which is just naive parameter averaging, because we wanted to see what is the performance we get if we do a similarity-based aggregation. So as you can see in the results, our method is much more stable than Fed average or just naive parameter averaging, because as we said, that the dynamics are different. So if you just try to combine all of them together and average them out, it is going to lead to unstable convergence. The main reason why this method works is that the clients which are similar, they contribute more, but we still maintain a base level of federation. So uniform averaging, as you saw in this, is maintaining a base level of federation. So each client does contribute something. And also it helps to stabilize learning during the early phases when the system dynamics are not completely determined and the system is still learning how to figure it out. So together, uniform averaging plus similarity-weighted aggregation reduces interference from incompatible updates and also leads to better stability performance. So in this case, we assume a shared embodiment and observation space. So as I said, everything is similar, but still there is heterogeneity in the system. So as I explained, it comes from the dynamics. In the future works, I would like to introduce cross-embodied federation. So if we have different robots doing same task or even different tasks, how do we federate in those scenarios? So the final takeaway, we move from policy-based aggregation to a representation-based aggregation. And instead of just naive parameter averaging, we move towards a behavior-aware aggregation. And for most of the heterogeneous reinforcement of federated learning, we are dealing with the standard cases just assumes heterogeneity in the data distribution. But in reinforcement learning, it's more about the structure of the environment and the dynamics and how the agent is actually interacting. So I think that's what's most important when we're dealing with federated reinforcement learning. Thank you.
We have time for one or two questions. So if you're interested in asking something, just raise your hand. Yeah. There's a gentleman in red right there.
Thanks. Nice presentation, thanks. I was wondering, because if I understand correctly, you have a hyperparameter that balances between the general averaging and the similarity-based averaging, right? Have you thought about making that parameter dependent on the training time, so that early on in training you do, I guess, less with the similarity-based, and then that becomes more important later on in the training?
So we didn't do that in our experiment, but yes, I think that's a good idea to linearly decay it over the time frame. That could help. Yeah.
Great. There was one more question just in the middle row here.
What compared to the results you had before and the results you had now, how much better do you think they were?
So for different tasks, we got different results. Some of the tasks which were, I would say, quite easy to solve. In that case, the difference was not that much, it was not too significant. But for cases where the dynamics was actually, I would say, different from other clients, in that case, we saw stability of around 60% improvement, yeah, compared to Fed average. Yeah.
Okay, great. Thank you so much again. Okay, so that ends session 1. We're going to go to break now and come back here at 11:30 local time, so that's in 29 minutes. I'd encourage you to take a break, get some coffee, drinks. We also have our posters and demos. This is an official poster demo period too. So thank you. Thanks for attending session 1.
Welcome back, everyone. That's it. That's the first session of day 2 here at Flower AI Summit. I was just taking a look at the agenda, just trying to bring that up here. We have more speakers coming up. This is the unofficial industry day, so there will definitely be more talks about AI in healthcare, in finance, in different sort of spaces like automotive. There are people here that are experts within their field. So if you have any questions that are specifically for an industry, then today is the day to ask those. So I've checked the live stream. You probably have seen some of my comments and answers. We have the whole team monitoring it. So if you have any questions or comments, just put them there. We'll try to get to you as soon as possible. But definitely continue watching the stream because there's more coming up. There are more talks from members here at Flower Labs as well. We heard from Jan and Mohammed before, as well as Nick introducing day 2, and then a couple of other speakers. But if we take a look at what is going on today. So later on, we will hear from Javier. He's the lead research scientist here at Flower Labs, and he will talk about flower health. So that will be very exciting. Then we have a couple of more healthcare talks coming up as well. So there will be from ISGlobal, Flip, DocPort, and Ontario Brain Institute, OBI, and a bunch of other ones. There are some talks regarding finance as well. This will be very interesting. And later on, we have a panel, fireside chat. So yeah, stay tuned for that, definitely. Let me jump over quickly to the live stream, see if there are any questions. I also saw that there were questions in our public Slack, and if you haven't joined already, then this is the time to do so. You can just head over to flower.ai/join Slack. You can also find there's a button on the website that you can click on just to join there. This is the best way to get in touch with all of us from Flower Labs. So we are active there 24/7 basically, and there's always someone online that you can ping, and maybe you want to talk to them about reviewing code. Maybe you're contributing with something to the open source framework itself, then this is a great way to just communicate your thoughts, ideas, anything you would like to actively discuss, basically. We also have a forum. This is called Flower Discuss, and this is more long thread format. So if you are, for example, want to expand on a research idea or discuss, we talked about decentralized FL in the chat. That could be a great topic to open a sort of thread and maybe let the community know what you are thinking about and how you would want to design it. You can actively sort of illustrate ideas, and we'll review it and definitely take a look at it and see how we can implement it together. Let me just go back here. So yeah, stay tuned. I see someone saying it was a nice presentation, for sure. We are looking forward to more presentations, and after this event, we will also make all the recordings available. So you can expect all the material up online on the website and on the YouTube. So in case you missed 1 or 2 talks, then you can always go back and just take a look at them. You can also see the whole stream if that's your preferred way of watching it. So, but stay tuned. We have more things coming up. I don't know. Yesterday we had a bunch of guests coming down here. We might get something similar today. These are people that are around up on the main stage area, and they sometimes come down and want to talk with us for 5 minutes about what they're working on. If there's anything that you would like to hear, or if there are topics that you are interested in, we can always try to bring some of these people down to, not hold an interview, but just discuss the topic itself, basically. So we'll be here all day for that. Other than that, there are various topics that I've seen pop up in the channel, such as hierarchical federated learning. There's clustered federated learning we heard in one of the talks earlier this morning. there were questions about decentralized federated learning. So all these sort of things are very active research topics, but of course it's important that one also makes them more applied. This is something that we are taking serious and trying to work on as we proceed, but there's only so much one can do when it comes to developing new platforms and examples and making sure that the framework is up to the standards that we wanted. But yeah, these are some of the ideas that we would really like to implement, and if you are eager to roll this out even sooner, we always welcome contributions to the open source framework itself. So the best way to go on about that, if you want to contribute to the framework, you go to our GitHub, which is Flower Labs /Flower, and then you'll find, I think in the README, in the main documentation, you'll see how to contribute. There might be a specific document for it, basically. We also have our documentation on the website. This is a full repository of all the documentation that we have, and you can find it on flower.ai as well. But basically, you can go to GitHub, you can fork the repository, meaning that you get your own sort of copy of the repository for yourself, and then you can push new code to that through that one to the Flower repository itself, and we'll review it. And if this all is satisfactory to the rules that we like, how we format the code and things like that, if this is satisfactory, then you can then we'll give you the review and the go ahead. So this will be merged, and this could be an example or just an improvement on general documentation. Maybe it is some new piece of infrastructure. Could be that you want to roll out a better version of the Android SDK, or putting it on mobile, making it much easier. That's something that is very interesting indeed. And so the opportunities are endless. That's kind of what I want to say. So, and if you want to just discuss, you can always, as I said before, go to the Slack and discuss the ideas. We'll try to review them as soon as we can and get back to you. But yeah, let's check if there are any questions in the channel here. Just heading over. Yeah, and you can, if you want. One way of interacting with us is definitely through live stream, but also Flower AI Summit Channel 2026 in Slack is another way to do so. Let's just go back to the agenda, see what we're doing there. Yeah, let's get so the next session is a 3-part section. There will be 3 talks. One is from Javier from Flower, and then there is ISGlobal, 2 presenters plus, and then Flip. So there's a lot of healthcare coming up in the next section. After that, we'll do a lunch, and then also the people here in the main stage, they will walk around, take a look at the posters. Posters are provided by the community, so there are people upstairs that have done their research and put posters up for the main area. We should make them available online as well if you want to check this out. It's also a great way to get in touch with the researchers that are here today and the industry professionals. So we'll try to make that available. Probably goes up on the same website under Flower AI Summit 2026 on flower.ai. Yeah, but then there will be a longer lunch session, but you can just keep the stream running in the background, basically. It's in 30 minutes, 40 minutes, something like that. And then when we come back, there's a fireside chat. So we'll have some people from Flower Labs talk with industry professionals, and there will be federated learning for neuroscience. So if this is your field, you want to stay tuned for that. Then we have DocPort. DocPort is a really interesting company out of Germany. They are running federated analytics, which is, when we think of Flower, we think of it as a framework for federated AI, which you can think of as the overarching topic that sort of encapsulates federated learning, federated analytics, and federated evaluation. What they are working on is the part federated analytics, which is sort of understanding statistics on the client side themselves. They work with the hospitals and clinics in Germany. I think they have, if it's 30 or 50 big clinicals in Germany connected to their actual supergrid. So they are using supergrid since a while. They were one of the early adopters to use so, and they are rolling it out across Germany for clinics and studying the aggregate level statistics of these clinics that are connected. So it's not the raw data point themselves, but it's more the aggregate statistics that you can get from medical records without necessarily requiring the specific data points to be sent to another location, which is very good. And we do see a lot of people asking about this, and it comes up in other parts of the world as well, but they are one of the first ones that are actively rolling this out. So this is nationwide in Germany. It's a very cool effort. We have blog posts up on it, and I think I posted a couple of things on LinkedIn the other day about it. And Nicolas Conce, he is a medical doctor plus head of data science, and he is here to talk about it. So he's definitely the one that you will want to chat to if you are interested in learning more. And you can also talk with us if you want to learn more about Supergrid and how to use it and what to do with it, basically. Supergrid, you can, it's now rolled out. It's launched since of maybe 24 or 48 hours. So you can go to flower.ai and create your own account. You'll see there's a login and a sign up button. You'll just want to go ahead to do sign up. And then if you actually want to see our CEO Daniel talk about it, and we also had Shongshen talk about it yesterday, you can go to day one recordings of Flower AI Summit and just find that specific part, because they give a lot of details on what it entails and how you can use it. So yeah, this is something that you'll definitely want to check out. But yeah, DocPort is on the stage later today. Then we have a couple of other ones, short break, a fireside chat with people from Roche. There's a big pharmaceutical company coming here talking about what they are doing in terms of federated AI. This will be very exciting indeed. And then a couple of other ones. Later we also have a talk from Micah. Micah is experienced industry professional and works together with Flower Labs since a couple of months, and came from Intel, having led their efforts with OpenFL, and is now bringing all of his expertise in terms of security, trust, and governance into Flower, basically. So he will talk about that. So if you're working in an enterprise environment or just doing research on this is a great talk to listen into, because he has a lot of insights and know-how of how this can actually be rolled out and used in various sort of ways. After that, we have a short break, and then we'll do the last session. But, you know, I've been talking about so many presentations already, so there's definitely a lot to come. So stay tuned for that. Let's head over to just the live stream, see if there was anything. And if you happen to join just right now, you can always go back and see what happened this morning. You can also find the streams from yesterday online on our YouTube page. That's Flower Labs. And otherwise, just keep the stream going, and we'll be here all day. Looking forward to all the presentations that are to come, basically. Let's see. In the meantime, if you're wondering what I'm doing, I'm just checking the chat if there's anything, because we have people asking questions both in Slack and YouTube. We are live on LinkedIn and X as well. So if this is where you are tuning in from, you can also ask questions there. I'll probably check those comments and questions right after this break and get back to you. And if you want to get in touch with me specifically, my name is William. I work as a solutions engineer here at Flower Labs. And if you want to talk more about what you are working on, you can always, I'm very active on LinkedIn, so you can reach me there. My email is william@flower.ai. So that's, if you want to discuss a specific topic, you can also ping me there. Let's see. Yeah, we have the program. Then, as I said, the posters, they will be made available. And also yesterday we had a big day. So it was a lot of fireside chats, a lot of panels, people talking. If you're interested in, listening into sort of a, not a brainstorming session, but where people are actually giving their thoughts, their honest thoughts on, let's say, the development of AI over the next 3 to 5 years. The panels actually serve that purpose very well. So yesterday we had Daniel, our CEO, on one of the panels together with a couple of other people, and they were sharing their insights and thoughts on how they see AI developing over the next couple of months to years, which is something that everyone online likes to talk about. And if you are interested in what Flower Labs' view is on this, then that's a great place to go and just check that out again. Because he is actually working deep in the trenches with the framework. You probably see him as one of the most active contributors to Flower Labs, and this is really exciting to see that everyone who works in Flower Labs is active on GitHub and trying to review code coming in from the whole community. So if you're one of those, then you can always ping us, and someone from the team, most likely Daniel, Javier, Shongshen, or Pan, you'll probably see them being very active on GitHub. These are some of the core maintainers of the framework, and you'll probably interact with them. But who knows? Could be someone else from the team as well. They are all here today checking questions and comments from you. So keep spamming the chat with all your questions and comments. Let's see. Very nicely presented. Good presentation. That's great. It's great to see. And we also in Slack, if you join our public Slack, you'll see that there are many channels that you can join. Some of the more active ones are first you'll get introduced to the general channel. This is where new announcements are made, where we announce, for example, a new version of Flower. We also host a session called Flower Monthly every month, and this is where we invite researchers and people from the community and industry professionals to share some of the latest development that they have been working on, specifically regarding if they have been using Flower Labs or Flower, for example. So that we invite people for that. So you can also check that out. There are recordings on YouTube if you're interested in learning more. And if you are interested in being part of it, you can always join us. It's the first Wednesday every month, I would say. I think that's it. But yeah, everything is always up on our socials and flower.ai, so that's where you can find most of the information. Then there is a questions channel as well. That's, as you can imagine, for very sort of quick format questions. If you need something, maybe you want to paste I don't know, code, log output, some bug that you see. If you think it's not a major thing, you can put it there. We prefer to see some of this as raised issues on our GitHub. If it's let's say a major bug or some bigger improvement that we should do on the documentation, then please follow the format and put it as a specific issue that we can take a look at, because sometimes if you just post a log output in a longer log output in the Slack channel, it will go missing. It's very difficult to keep track of all the questions that come in, because at this point I think we are more than 7,000 people in the main channels there on Slack. So please, if there are longer, then just put that, like, make it more follow the format on GitHub. That's easier for us to review then. And then if there are very quick questions that you have about a specific part of the framework, you can always put that in Slack. That's probably the easiest, and that will yield the quickest replies. I think we have some guests coming in. Yesterday we had guests coming in throughout the day. And let's see who's the speaker. Hi, welcome in. Good, how are you? Here's your mic.
Thank you so much.
come a bit closer here.
Thank you.
Yeah.
Hi, I'm Charles Crosby. How are you? Nice to meet you.
William, nice to meet you. Please introduce yourself to the stream.
I'm Charles Crosby. I'm a senior product manager with the Terry Fox Research Institute in Canada, working in cancer research, and really excited to be here today to learn how we can advance our cause using federated learning. So.
Nice. What's been the best so far? Were you here yesterday?
I was, yeah, absolutely.
What is there a presentation that stood out to you, or something that you really?
The leaders' breakfast yesterday morning was great, just in terms of making sure that there was a lot of alignment in terms of what we've got. A lot of common problem statements that we're banting about the room together right now. A lot of that then carried over into the presentations, which was great to see, and to see material ideas kind of being surfaced in terms of solutioning. There's a lot of, again, in the commonality in terms of what we're trying to solve for in terms of the discrete kinds of data sets that are out there, regulatory and governance things that are all kind of things that are on our mind. So it also really validated a lot of our thinking,
right?
The kind of red thread through the themes of our planning. So.
And is there, when you talk about your work and research, what are some of the details? What cancer types are we talking about, or what things are we working on?
So it's effectively it's all of oncology,
as
a whole, which is kind of a good thing, bad thing from a kind of a data set standpoint and the variables and attributes that are out there. Also, just in terms of the harmonization questions, there's so many standards between OMOP and FHIR and so forth in the healthcare world to make sure that they can, that the data is findable and usable and accessible and that sort of thing. So we're starting with cancer. It's kind of the mission of our nonprofit. We will expand into other disease domains once we've kind of got up and running and into speed. But effectively, our digital platform our health platform in Canada has to, again, make all of this data across a huge country accessible, understandable, and then the so what factor. It has to be analyzable. You have to be able to find those kernels of knowledge, those trends, whatever it may be as a researcher that you're looking for it in it. And as we're hearing more and more, people are also looking for that kind of TRE, that kind of collaborative space inside of the platforms.
Right. And how many sites are you connecting at this point, more or less?
Right now, we've got an MVP that is just connecting, I think, 4 or 5 nodes across the country. But I'm happy to say that we have an innovation fund spun up right now, where we have an envelope of money to sponsor our first onboarders. So right now, we've got about 18 projects representing about 100 individuals that are going to be coming online. We have millions of patient records and data points to start playing with, so it is the biggest big data one could imagine, including rich data, imaging and video and these sorts of things that we're having to experiment with.
And it's Canada-centric then, from what I understand. Yeah, right. And do you, how did it come to be that you started looking into federated learning and decentralized? Was it just the nature of the sort of project that you were working on? Yeah, exactly.
And the sensitivities of the data, obviously, and so philosophically, being able to put the software where the data resides obviously makes sense to any stakeholder. We'd initially looked at basically first, a bit of a metal solution, putting an appliance in the hospitals and the clinics and these sorts of things. And then things just evolved, and they just evolved so rapidly. And we had a consultant who did some due diligence in terms of other options that might be out there, and they came singing the praises of Flower.
Okay, that's good.
Absolutely.
Yeah, that's good to hear. And is there, when you are rolling this out, what constraints do you see at this point? Like, is there something that you're working against that you see being the next thing that you need to solve in order to fully be able to roll it out?
So I'd say first it is that the data standardization and harmonization, and so it's basically creating products within products. So effectively having to, do we want to get into just the indexing business using automations and creating our own kind of micro AIs that are running to be able to determine is someone talking about kilos or pounds or this sort of thing. And so addressing that, but otherwise it really is the sensitivity that this has to be, privacy by design, and understanding the sensitivities at their street level when you try to explain to a layperson that we want to look at medical records, but not your medical records per se, and they can be depersonalized. We just need to see the data. We just need to see the trends in terms of treatments and these sorts of things. So a lot of that comes down to governance and how those deployments are going to roll out. There's going to be some similarities between a small clinic in Toronto versus a giant hospital in Vancouver and these sorts of things. But so far, so good. So we've got, as the 18 projects, we've got 50 people in our network so far, 50 different...
It is great to hear. Yeah, we hope for more, and we hope that we can roll it out fully. It's great to hear that you already have an MVP and you're working on that actively. I heard just right now that we have a question for you in the live chat, so let's just check it out. Charles, what are your opinions on federated AI being used in cancer research? It seems that the data gap would definitely be getting shorter if multiple industries and field collaborated.
It's actually the mission that we've been given is to address this in Canada.
Okay.
So Terry Fox, I don't know if the audience is aware, is considered one of the greatest Canadians in our history. He ran a marathon, tried to across Canada on one leg to raise awareness for this. So we know that this is a hard endeavor, and we call it Terry Fox hard. We know that we each have to run a marathon every day to make this happen and to stay competitive, which is why we flew across the pond to come here and see what's happening and be at the leading edge of things. It has to happen. It's going to happen. It's just the means of how we get from here to there. Yeah. And so we're very confident in the MVP that we have with Flower right now. It looks awesome. It does what it says on the tin, right? Yeah. And so the concept has been proven. So to drop those silos is mission critical, obviously, to make sure in terms of data protectionism and these sorts of things, but also from a regulatory standpoint and these sorts of things. So that's a lot of red tape stuff that still has to happen in the background. That's a big, heavy lift, obviously, right? Yeah. So addressing that, and at the same time, again, just picking up on the so what factor. I got access to the data. I want to analyze it. I want to jam on something with a colleague. You know, right. Can you enable that? Can you facilitate that? And we can, and we will. So.
That's great to hear. I know that we are going back to the main stage soon, so I'll probably leave it at that, but thanks for coming by. I think that if the chat has any more questions, I'll be here to answer them. I'm probably going to run them by you anyway. So yeah, thank you very much.
Thank you so much. Thank you.
Thank you.
Thanks.
Okay, everyone. That was Terry Fox Research Institute. They are over here from Canada, right now here in London, UK, and we'll talk more with them most likely. In 1 minute, we're going over to the main stage. It's Javier from Flower Labs. He will talk about flower health. So the next session is healthcare and medicine related. If you're working in this industry or just in general, this is something that you will want to tune into and, keep on watching the stream. After that, there will be a lunch break, but you can just keep the stream running in the background. It's for another 30 or 40 minutes or so. And we are actively answering your questions. So just keep on posting them here or in Slack. We'll try to get to you as soon as possible. But yeah, then, so we're heading over to the main stage soon. Let's just get them to set up there. And exactly. And if you have any questions for Terry Fox Research Institute, then you can also just post them and I'll try to run them by the team that is here today. Just go ahead if you're interested in work, or if you're working in oncology or cancer research, you might want to connect with them as well. And you can always run it by us here at Flower Labs, so we can connect you immediately to the people. You'll most likely find them on LinkedIn as well. This is, we have done some social posts with them before, but we're going live to the main stage area in a couple of seconds. So it will be another maybe minute or so, then we go there. Let's see, I'm just checking the Slack channel at the same time. And if you have any questions, just put them in the dedicated Flower AI Summit 2026 channel. This is where we keep reference of the questions that have been asked. And let's see the live stream. I'll check out the live stream, and we are going to the main area right now, so stay tuned for more, and see you soon.
Okay, we're going to get things underway, folks. Time for session 2. Let's wrap up those conversations and get underway. Session 2 is about to start here. And for session 2, we've got some incredible talks that are going to dive into how federated methods can revolutionize healthcare and adjacent areas. And so for the first talk of this session, I'm really pleased to introduce Javier Fernandez. He is going to discuss a lot of the impact that Flower has had by working with many organizations out there in the healthcare space, and tell us also about how Flower software, Flower techniques has enabled those folks to really move forward with the things that they want to do in the healthcare domain as it relates to AI. So let's give it up for Javier.
Thank you for introduction, Nick, and I'm super happy to be here again. So let's talk about health and life sciences. Yeah. Okay, so a year ago today, we met here in London, also for the Flower AI Summit, and we, the community, and also some of our partners, gave you a first look at some of the deployments that have been used in Flower. Some of those examples were Blood Counts, which is a consortium of over 100 hospitals running Flower worldwide. And they were telling us how they build a new foundational model for helping to understand better illnesses like anemia. And also we heard from Oakin, who is an AI biotech that they are using Flower to train models to better predict phase 2 outcomes of clinical trials. They use Flower inside a method called Fedeca. And you can find this app in the Flower Hub. And I will be talking about this more later. But since then, we have seen an explosion of adoption of Flower and Supergrid. And in the last 6 or so months, the number of deployments have really multiplied. And to give you some numbers on what this exactly means, here are some numbers. So across different projects and different collaborations in research and in production, there are over 500 sites using Flower or Supergrid. These include hospitals, big national hospitals, smaller hospitals, clinics, research labs, research university labs, and more. And through these sites, there has been over 2 million patient records being processed with Flower for different studies and also in production. And out of all these research and services, at least 4 foundational models have been trained. To give you a couple examples, one of them was the one I mentioned about blood counts to understand better anemia and other illnesses related to iron deficiency. And other examples were presented a few months back, which are related to medical imaging to understand better how diabetes affects your retina. As we heard from Jan and Mohammed earlier, there are over 100 Flower apps in the Flower Hub, sorry, and there are also a few of them for healthcare and life sciences. And we are super proud to get the teams from Oakin, Synthema, MonAI, and Heart AI Lab, which is a AI lab in Melbourne, to be publishing apps in the Flower Hub. Also, an app from Blood Counts that you can all use right away from the App Hub. With all this, we are certain that Flower Hub and the Supergrid is by far the most widely used platform for collaborative AI in healthcare and the life sciences in the world. And we can only see this growing more and more. And you have heard about Supergrid already, but I want to give you a different perspective on all the features that are in Supergrid, and I want to convince you on why all these features are really relevant for healthcare and life sciences. So when you start in Supergrid, for example, if you go to flower.ai today, you will be probably starting with your own team. Let's say you are representing this hospital down there, and the first step is always to create a federation. You might name the federation after the project you are going to be doing, for example, anemia, or if you are looking into X-ray images, you might name the federation something related to the X-ray images you are analyzing. And then the next step, as you saw in the demos yesterday, it involves inviting other collaborators. This might be other research centers in the vicinity of your research center, but there is nothing stopping you from inviting collaborators on the other side of the world. And that's what we have been seeing with some of our partners. We understand that not all sites have the same level of, they don't all have the same expertise. Some are more expert in some particular domains of the data being analyzed. Some others have a strong engineering team. Some others have a stronger clinical team. So because of that, there is already a good role-based access control setup in place for your federations. And as the admin of the federation, you can fine-tune what these roles means in your federations. And this varies between project and project. And also it varies depending if you are fully in industry or maybe some of your sites involve also academic research, then the type of roles you want to give changes. And of course, as the project evolves, as your federation grows, some more data might be, maybe you want to introduce more data into the federation, so more different type of applications can be executed in a collaborative way. In the Flower Supergrid and in the federations, each site is responsible and has the ownership of your data. So if there is more data, you can plug it into the Supergrid, and all the members in your federation can make use of it for further analysis, further training of models, further federated analytics queries. It's really up to your use case. And of course, you can also remove the data when the time is right. As we have heard also from the demos, in the federations, also in healthcare, you can make use of the Flower Hub, and it's a great way to disseminate your work. And this is really important, everything that happens through the Supergrid can be auditable. This means that not only the models that get communicating between the sites when you are doing federated training or federated analytics, but also all the derivatives of these models. You can trace what are the configurations sent by all the researchers when they are executing the runs. You can trace the queries sent in federated analytics and the results, really everything. And this is really helpful to understand, for example, what is important for the researchers in your big consortium, because when the federations grows to dozens or hundreds of sites, it's really important, at least for the PIs, to understand what's going on, basically. And all this, as you have seen the demos as well, you can make use of all that through the terminal, if you are comfortable with the terminal, or through the UI, if you prefer to do so. So we really think that what we have been presenting these days makes the Supergrid super easy to use, and also is the safest place to start building real federations and doing real collaboration in AI for healthcare. So if you are interested in trying this out, you know where to go. It's flower.ai. You can already run federations in a simulated setup, but if you want to make use of federations in the real world, in deployment, you can reach out to us and we will give you a preview access. There are many success stories in Flower Supergrid, but today I will give you a small glimpse on what you are going to hear in more detail later after lunch. We have been super grateful to be working with two amazing collaborators. One of them is Stockport. They are a company in Germany that has been building a super interesting project interconnecting multiple medical practices. And this has enabled them for these practices to benchmark between each other, and in this way improve the standard of care that they can provide to their patients, and also has enabled them to collaborate with pharma companies. So you will hear more about Stockport from Nicolas later in this talk, today, later after lunch. And also we are super excited to be working with Aridia. Aridia has built a federation of DREs, which enables clinicians to work in secure environments with the data they are already familiar on how to work with it. Now they can collaborate across different DREs. And you will hear more about this and how this was set up from Scott Russell later after lunch. Those were just some of the success stories we are seeing in Supergrid, and we are super excited to see more in the coming months. So if you are interested in checking out some of our early preview features that I'm going to enumerate now, feel free to reach out to me or any other Flower member today. So we know that what you can get to in Supergrid today is already pretty good, but we are not stopping there. You have heard earlier from Mohammed and Jan about verified apps. This, what it enables you to do is, for every site, even if they are part of the same federation, each site might have different standards on what they want to allow to run through their data. So each site can approve certain apps to be executed through the data or not. And this allows, this brings a lot of flexibility, because at the end of the day, if multiple sites are connected, the data that is on the sites might be different. So even though you have one federation, you can run multiple apps. There is nothing stopping you from creating a federation for multiple projects, as long as the data is there. So that means that makes total sense on why you might want to verify your apps before they run. Private registries, as we saw yesterday in the demo, by default, Flower allows you to install the dependencies that are needed in your app, like PyTorch, any other package. But in some cases, you might have your own private Python packages that are not public. So if you are in one of the advanced features we are working on is to enable these private registries to be used also for your apps. And of course, we are bringing confidential compute to Supergrid. In this way, you don't need to only trust the IT team in these sites. You can just trust the hardware and implementation by means of the mechanisms that are built in most of the cloud providers. And because Flower is platform agnostic, you can make use of all the deployments, whether they are in AWS, Azure, it doesn't matter. There is no vendor lock-in with Flower. And there are also a number of governance features that you will learn more about them later in a talk after lunch as well. And as well, we are bringing agentic mode and Project Kaya to Supergrid. And one of the more exciting aspects on why this makes a lot of sense in healthcare is, for example, to solve the real problem of data alignment. There are multiple sites that have almost identical data. For example, if we think about tabular data, the columns might, overall, the data is present everywhere, but the columns might have different names, or they are permuted. So you really want to smooth out the problem of data preprocessing as much as possible, so researchers can just focus on their algorithms. A few months ago, we announced a program for the UK to help researchers run collaborative AI through Supergrid. It was UK specific, but today we are very excited to launch this globally. And we call it the Flower Supergrid Health and Life Sciences Accelerator. So let me tell you briefly what this means. So there are three main dimensions to this program. One is for academic grants. We want research teams in universities and other institutions to have a really easy time to do their research without having to worry about the engineering. So we are giving free credits for Supergrid Pro, so smaller teams can start working from day one. We want to also reward those teams that put some engineering effort in making it easy for others to include sites that run on SDETs or high-performance computer environments, to make it easy for them to add them to the Supergrid. Sometimes this is not trivial, so we really want to reward those that have the expertise to do this. And also for the most ambitious research, we want to give an even more sizable amount of free usage for Supergrid. So this means European projects, National Science Foundation projects, like really big projects. And we think that through Supergrid, your research can be really impactful. So if you're interested, there is the QR code there. So I'm wrapping up my talk. This is everything I wanted to present to you today. Flower Supergrid is really building a super big connection of sites for healthcare and life sciences. There is the academic and research grants program. The Flower Hub is ready to accept your healthcare and related Flower apps, and we can't wait to see what you build with Supergrid. Thank you.
We have time for questions. Anyone out there have any questions for Javier? There's a lady right in the middle here.
Hello.
Hello.
As my research is about cancer images, so which Flower app do you think is most relevant for me to use for my research?
Yeah, so currently Flower apps working on imaging there is an app called Quick Start MonAI. So MonAI is a super nice package for medical computer vision. So I would say that's a great point to start. Yeah.
Okay. And another question is, here we can see multiple sites. Yeah. So what kind of collaboration they need among them? And what about the security and privacy?
Yeah, so the collaboration is really up to the consortium of researchers to define what it means. Like some collaborators will do, for example, what you said. So they all have some images for prostate cancer, for example, or breast cancer, and they want to be able to train their models on all the data that is distributed, but they cannot pull the data into one site. So that's why they join Supergrid to be able to federate this training of models. So it depends on the use case. Some other teams, they don't work with images, they work with tabular data, but the overall process is always the same. Yeah.
Okay, thank you.
I think we're welcome. In the middle here, right? Well.
So healthcare and life sciences is one vertical, right? And where you have tremendous success with. I wanted to understand, like, what other verticals could also see similar benefits in terms of like similarity with health and life sciences and the challenges there are.
Yeah, good question. Yes, so in the end, if you look at the diagram on the left, even though we have many built-in features that makes it really nice for healthcare, but the overall problem of having distributed data is present in many other industries, right? So is this your question? Like which other industries? Well, you can see that the same type of problem appears in finance, for example, or in manufacturing. There are different sites that have different data that you cannot move for whatever reason. Sometimes it's privacy, sometimes it's regulation. So those sites can also connect to the Supergrid in the same way that we have seen with example of healthcare and do their research or build their services for production. Yeah.
Okay, thank you, Javier.
Thank you.
So our next talk is going to be given by two individuals from ISGlobal. Flower and ISGlobal have started working together a few months ago on something incredibly ambitious, and we're really impressed by how much progress has been made already. And I think a lot of the credit goes to our two speakers here, Juan Ramon and David Surratt. They're both from ISGlobal, and they're going to show us and surprise you with what I've been able to achieve to accelerate HLS in federated circumstances even further.
Okay, good morning, everyone. And first of all, I'd like to thank the organizers for giving us the opportunity of presenting our work in federated data analysis. So the title is ISGlobal and Flower Collaboration. All of you already know Flower, and ISGlobal, I don't think so. So ISGlobal stands for Barcelona Institute for Global Health. This is where it is located. It is in the Biomedical Research Park in Barcelona, in a very nice place close to the beach. So if you want to go there, it's perfect. So you saw any advertisement from ISGlobal or CRG, Center for Genomic Regulation, think about that because it's a really nice place. So I'm leading a research group called Bioinformatics Research Group in Epidemiology. We are doing mainly research in genomics, genetics, and developing packages. And why are having invited to this summit is because we are working with DataSHIELD. I don't know either whether you are familiar with DataSHIELD. DataSHIELD is here you can see different places where researchers has published something using DataSHIELD, not working on DataSHIELD. There are many places where people are using DataSHIELD. So what is important is that DataSHIELD is a federated data analysis software. It's not federated learning software. So the idea is that this package, this software was created for epidemiological studies in which people wanted to share data without moving data from the original sites. And the idea is that they have been implementing many statistical methods, logistic regression, survival analysis, all these methods that are applied in epidemiology just to perform collaborative research between different research centers and hospitals, mainly in consortia. So the idea is that when you work in this consortia, what you normally do is meta-analysis. You get beta values or estimates from different sites, and they send back the summarized data, and then you pull the data. However, DataSHIELD is able to do both. It's able to do meta-analysis and pool analysis. Pool analysis, as you know, stands for doing the analysis without moving the data and without putting the data in a single center. It's just data kept in the original sites, and DataSHIELD is able to do this type of analysis. But also only with regressions, simple machine learning algorithms, and so on. And that's why we wanted to collaborate with Flower, because maybe we could incorporate Flower into DataSHIELD, as you will see in a minute. So DataSHIELD is very straightforward. The idea is that you have some functions in the client side. You send the analysis to the servers, and it checks whether or not it is disclosive. Here in Flower, I haven't heard too much about disclosiveness and data security, don't sharing data, because you are focusing on other stuff. But DataSHIELD is very aware, very take care about confidentiality and don't sharing data and disclose any type of information. So this is how it is organized. So you have data in different servers in a data warehouse, which is called Opal. There is also another data warehouse, which is called Armadillo. And the idea is that you put data there and you connect through a session in R, and the data analyst is connecting through the servers using credentials, and everything is secure. And the only thing that is transpassed from one part to another one are summarized data. Okay, you are familiar with this, so I haven't to say anything. So the idea is that there are two packages in DataSHIELD. One is located in the Opal server that takes care about the aggregation and the assign methods. Assign stands for creating new variables or new tables and new subsets. And then in the client side, when the data analysis is located, you can send instructions to run the site analysis. This is somehow confusing with Flower, because Flower calls client and server vice versa. So don't worry, we are knowing that, so we are doing things properly. So, which is important for DataSHIELD, and this is why I suppose Flower researchers told to us, is that DataSHIELD has been established in many consortia, and it is very secure. It is GDPR compliance. The profiles in Opal, for example, you can control the type of methods and models you can do. You can put different layers of security and disclosiveness. For example, if you want to compute a 2x2 table, if the table is having less than 3 or 5 or whatever number you put in a cell, it is disclosive. So if you get that number, you don't obtain the data, so you cannot recover. And there are other techniques more advanced and more sophisticated to take control of the data, such as homomorphic encryption, secure multi-party computation, and other more complicated we are implementing they are implemented in DataSHIELD. So if you want to read more about that, the layer of security, we have published this paper recently, so you can have a look at it. And there are many functions in DSBase to do many things. Also the scripted statistics, which is nice. And the idea is that people are developing and creating new packages. For example, packages for doing omics data analysis, mediation analysis, imaging, as you mentioned previously, and so on. So here I want to explain very quickly some things that are implemented in DataSHIELD. For example, the DSOmic package is able to run GWAS analysis. For those of you who are not familiar with this, is genome-wide association studies. You can scan 40 million of SNPs in a row, and you run association analysis. It is implemented in the 1 million genome project. So you have different Opal servers in different sites, and you can run analysis, this type of analysis, just doing federated learning, not federated data analytics, federated generalized linear models. And you can obtain this very simply, just writing a single sentence is straightforward. And also, we have been talking about harmonization, data harmonization. As you know, OMOP is a common model to harmonize data. So we have also developed a package called DSOMOP to integrate OMOP inside DataSHIELD. So you can have in the Opal server the OMOP database, and you can run data analysis using DataSHIELD. And we are developing more things. So, for example, we are developing DS Imaging and DSBERT for vertical data analytics using a project we have recently been funded from OSCARs, which is about Open Science Cluster in Research Society. And through the collaboration with Flower, we are implementing DSFlower. Don't worry about that, because in a second, David will explain that. So these are real examples in which DataSHIELD has been or are implemented. So this is the most important one, which is in Germany, many hospitals are having all the data in Opal servers, and DataSHIELD is being used to perform data analytics across different places and for different researchers. And we have also an example in Africa. Recently, we have set up 3 different Opal servers in Kenya, Senegal, and Cameroon, and we are doing analysis in data about HIV and mental health data. And this is some picture we were there. And also DSFlower, which is another project about imaging, incorporating data about imaging, GWAS, health record, longitudinal data. It's about COPD patients. The idea is that in the Opal server, you can have different type of data. You can have different modalities, okay? This is another of the advantages. And there are more. Now, you are going to see how we have implemented or integrated Flower within DataSHIELD, because most of these projects want to do federated learning in the analysis, and we don't need to re-implement a package in DataSHIELD in the server and in the client side, because this is already implemented in Flower. So the idea is to integrate that with it.
Okay, hello. Thank you, everyone. So I'm David. I'm a PhD student in ISGlobal, and I've developed the first functioning version of DSFlower, which is, as we explained before, a DataSHIELD package that kind of integrates both Flower and DataSHIELD, right? So I think it's important to note that I think technologically, when it comes to the training of models, obviously Flower is the way. But DataSHIELD has been around for a long time, and their main concerns have been related to data disclosure control and privacy preservation. So I would say that if we want to penetrate certain markets and certain fields, we may need to kind of have these discussions and establish a strong strategy when it comes to privacy preservation, and especially also having like a robust definition on what is our threat model, right? Okay, so as we've seen, the model of DataSHIELD is we have what we call the client, which for the sake of avoiding these discrepancies in the terminology, I will say the researcher or the analyst instead of the client. And then we have the nodes, right? Like, which is the servers or the machines that are running and that host the data and run DataSHIELD in the hospitals, right? So in this model, we basically rely on the fact that the researcher is the one contacting every server, orchestrating the analyst is contacting every node, orchestrating the actions and retrieving the data or the aggregated results, right? So we wanted to port this into a model that is compatible with Flower. And in our case, what we did was this, right? It may not seem intuitive at first because we are using the superlink from the client side, but we thought that if we establish a good threat model and we ensure secure aggregation and differential privacy, we may protect the data, even if it's the researcher, the one that is running the analysis, like the orchestration and hosting the superlink, right? So basically what we have allowed is DataSHIELD to communicate to this researcher and the researcher to be able to spawn the supernodes in every machine and then orchestrate these training sessions across them, right? There's some stuff happening behind the scenes. Like, for example, we're doing some discoverability and some user verification stuff behind the scenes, but this is something that we usually cover, right? I think it's, we're not getting that technical here. Okay, so there's these two packages, the server side, or should I say like the node side package, which is very batteries included, which means that if we have a hospital server running DataSHIELD, which already contains some tools for the DataSHIELD ecosystem, and they also have this secured patient data, you just install DSFlower, and this is going to wrap, because you need to take into account that originally DataSHIELD is meant to run both in the client and the server with R, right, with R sessions. So we made wrappers that enable interacting with a supernode, managing the supernode completely, and also allowing the communication between the node and the researcher, right? This means that we can communicate between the superlink and the supernode, and this also implies that since this is not our main or our native environment, we also need to manage the dependencies, right? So we have incorporated most of the things that we may need in order to run Flower here. And we have approved 18 pre-approved templates. Now, what does template mean in this context? So the philosophy of DataSHIELD is is focused more on having a more path environment, right? So we don't really let users define these apps, as they call it here, and just submit them to the nodes. But instead, they usually have like these libraries or packages that establish strongly what are the functions that they can run and the functions that they cannot run, right? So since they are drawing the lines here, we thought it would be great to just support specifically the kinds of operations that may be mostly common in biomedical research, right? And then we also added some of this disclosure control and securitization operations that we've mentioned before, right? Which means that in the end, all the interaction between the client and, the analyst and the nodes is going to be secured, right? Then from the analyst side, the person running an R session and having known access or being authorized to connect to one supernode machine from here should just install this package, and then they will be able to spawn superlinks. Of course, they will also have all the dependencies that enable them to run all this in their computer. I've made sure that everything is batteries included. And then from that point, they can just explore what templates set these predefined applications are installed in every server, right? So we can also ensure that every supernode is running the same stuff. And I do some check-ins behind the scenes. I've also added some encryption extra in the main communication, not only the secure aggregation operations, but I think that's maybe too technical for this. So we also, in the end, the analyst is the one that decides what operation is going to be run. They basically compose what we call a recipe, and then they submit it. And then, this is the checking of that this is happening everywhere. And I checked that there's no malicious in code injections and stuff like that, okay? So we tried to streamline as much as possible the interaction between the R session and this ecosystem. So this is basically how you would regularly connect in DataSHIELD. Then you establish the connection of Flower, which means that it is going to order the spawning of every supernode in every server, in every node. And then we basically establish the recipe and we basically run it. We'll see a small example later. Basically, these are the models that we are implementing. This is currently in our application. We tried to make everything that was compatible with the secure aggregation, which is why we made some modifications, and we need to make sure, for example, the XGBoost was a bit problematic, so we needed to find a way to actually make it compatible with the secure aggregation system, which, by the way, is using the old API because we're still waiting for the next the new API, Flower API to support secure aggregation, but I'm sure it's going to be available for very soon. And then we also try to basically support the strategies. Those who are familiar with Flower probably understand that. We just basically specify this through parameters. So there's not much to it. Okay, so there are four layers of protection. I see I'm running out of time, so I'll just explain this very briefly. But basically, we have the main DataSHIELD model and the data protection from there. We have secure aggregation, and then we also optionally, not really optionally, but I'm going to explain this. We have DP, and we have some disclosure controls that we kind of both inherit from other DataSHIELD methods and configurations, right? So since there are cases in which we are super paranoid, and there are other cases in which we are just debugging, and there are other cases in which we have just in a biomedical consortia where everyone is authenticated, and we don't really need to worry much about data disclosure, we have set a set of privacy profiles so that people can just enable the one that mostly fits this. And if a pool of connections involves nodes that have a more stringent profile than others, there is going to be like a negotiation layer in which they establish which is the most strict version of these profiles, and everything is going to adhere to that, okay? And from that, I just made a small demo. I don't have 5 servers here to run, so I just kind of simulated this so that you can see that how it would work. It was an example about the ICU mortality, so based on admissions on 5 servers. And we would basically, we're going to train a PyTorch MLP with FedProx and 10 rounds, just so you see how this would look like, okay? So we will be basically establishing the pool of connections. This only tells us that the data has been loaded into a symbol called D, in this case, and we're using basically the DataSHIELD API. And from this point, we can just tell it, okay, if everything has DSFlower installed on the node side, connect. It has performed the negotiation layer, so it means that it has established, in this case, that the clinical default profile is the one that everything is going to be running. And then from that point, we can just run a recipe, right? I made it a bit more immersive, so it's going to take some time, but you'll see the idea, basically. It checks that all the templates are the same in every code, in every node, so that there are no discrepancies. And then I also, well, we're supposed to have finished training this. And then we can even, I have implemented on the client side an opt-in feature that if you have the dependencies to run predictions, you can basically just get the model and test it, right? Just so it kind of streamlines the interaction between this train model and this R package, right? Just so the people find it simple to do that. And in this case, I just made a person who is very likely to die in this context, and I run it, and it has 73% chances of dying, okay? And then we would just close connections, okay? I don't have much time, so basically I was having some questions about how we can improve the design of this, because we're now relying on a predefined set of applications, but maybe it is more interesting to have, I don't know, like a connection to a hub, like one of those verified applications that you were mentioning. Maybe we can even allow analysts to create their own applications, but we will need to make sure that all the things that are submitted are not malicious code or disclosive code. Maybe we can just grow horizontally, implementing more templates. But I really like the app hub that you mentioned before. So I think this is probably the way. And then I would say that since DataSHIELD is the community that, as I've said, has been around for a long time, trying to deal with this skepticism from biomedical consortia and institutions that are not really that technical, but kind of, we also have these regulators on top of us saying us, all the data you're working with is sensitive, so we need to perform audits. I would say they kind of have a deep knowledge on where do you draw the lines and what is acceptable and what people expect that can be disclosed and what cannot be disclosed. So if you want to get into the healthcare world or in the biomedical field, I would say that it would be really great that we kind of have these conversations and we sit down and kind of try to exchange information. I'm really sure that they would benefit from this, because when we were training people lately in Africa, for example, they were always asking, okay, so can I use DataSHIELD to train models? Can we use this for deep learning? Can I use this for AI? Can I use this from imaging? So yes, now you have a way to do this. So yeah, I'm sure that we can kind of establish a partnership between the two. This is it. Thank you very much. Thank you everyone for attending, and feel free to reach out.
We have time for probably one quick question out there. Anyone want to? Yes, the gentleman right here.
Thank you, David, for the presentation. Just a quick question. You said you deployed DataSHIELD in 3 hospitals. I would like to know what kind of challenges you faced, if there is any. For example, like maybe if you require open ports, I don't know, on the servers, these kind of things. Thanks.
Yeah. So You're right about one thing. So there's usually problems with ports because usually when you interact with DataSHIELD, you use this DSI library, right? Which kind of uses like port 22, and this is the only one that is required to be open to establish the connection unless configured otherwise. So when you establish the connections between Supernode and the rest of the communications, or the pool of connections, you usually need another port to perform this. Now, I've been looking for workarounds for this. So far, I've been doing some work. I don't know if I've shown this here, but basically, there's even like a round of like a discoverability phase in which, because, you know, for example, when sometimes you're connecting to a machine that is inside your network, sometimes it's a public address, sometimes maybe it's a Dockerized environment. So you need to kind of establish the connection for all of this. I didn't put this here, I think, but basically we kind of perform certain fallback operations to make sure that this port is open. Maybe this is a bit of a workaround that shouldn't be like that. And maybe we should just establish something like, okay, if you want to run this, you need to have this port open. But yeah, overall, we're kind of working on that. But I would say that's the main challenge.
Great question. And let's thank ISGlobal for such a great contribution. So our next talk is from the folks at Flip and King's College London more generally. We've been working with them now for a number of months. There was actually an event we ran specifically for UK healthcare and life sciences. So we ran it in Cambridge, had about 100 people turn up. And at that event, we were chatting to Flip, which is the Flip group, which has been one of the longest running, largest and most extensive federations in the UK health scene for a long time now. And they were talking to us, you know, what could we do together? What can we do to make our system more open and sort of expand it and take it to the next stage? And so then that it started an intense sort of collaboration between the two groups that has resulted in a compatibility. You can now use Flip on Flower, and they have they probably have the largest UK federation in terms of patients out there. And so I'm delighted to introduce Alex Berger. He is at King's College London, as well as the London AI Centre for Value-Based Healthcare. He's going to tell you all about it. So over to Alex.
Just use presentation. Yeah, I think that's good.
Oh, great. Thanks so much for the introduction. Yeah, so I'm Alex. It's great to be here. We've seen lots of good healthcare applications. So this is another one. I work at the London AI Centre, and we've been trying to develop this federated learning platform for radiology, so a multimodal AI. So Flip was open sourced about 2 months ago, and as of 2 months ago as well, we support Flower as our federated learning backbone. So we're very excited to be showing you Flip as an open source platform for the first time. And the London AI Centre was an initiative that kind of set out, was established by the One London program, which is a partnership program that was trying to link data, patient data across London. So London's made up of these 5 integrated care systems. And in about 2020, they released this London Care Record, which allows you to If you go to A&E in any part of London, they'll have access to your medication prescriptions, your allergies, your hospital appointments, that kind of stuff. So it required a lot of data ingestion pipelines at the source, so primary care, hospitals, secondary care, community. And recently, one of the deliverables of the One London program has been the London Secure Data Environment. And that lets you go from just securely accessing data from patients to starting to do research. So linking data will lead to valuable insights and hopefully feedback into improved care. But this is what we're dealing with, right? So this is just the data landscape at Guy's and St Thomas, which is the trust we work with more closely. And just as a single trust, you have a very heterogeneous, complex data landscape made up of various different services. Some of them are legacy. So we have about 20 years of real-world data from about 5.2 million patients. So if you remember the talk from yesterday, the keynote, this would fall into the unused data blob. And this data is multimodal, so you have billions of rows containing clinical concepts like disease codes, lab results, but also you have lots of free text reports, so clinical documents, patient letters, any other transcriptions, but also about 8 million valid DICOM studies. So that's images you get when you get scanned. What we're doing is we're trying to tackle this heterogeneity at different levels. So we're using OMOP standard, which was introduced in the last talk as well, which is widely used in Europe as well. And it lets you trying to structure data into relational databases and standardize things like disease codes, for instance. We also use at the AI Center language models, natural language processing to extract insights from the free text reports. But OMOP only gets you so far, right? And so there's data that's bulk imaging data. You can really fit into OMOP. You can link it, but you can't really move it to a trusted research environment. It's very big. And it's also a lot more identifiable, right? So you might need to do defacing, other things if you want to move it out of the hospital. So for us, federated learning is really a need if we want to unlock this data from PAC systems, and we want to unlock it for training AI models. So where we had one single ingestion pipeline where we generated structured databases, we now have another one where we ingest images from radiology PACs into an open source staging environment. And then we add the flip service layer to try to bring those two sources of data close to the compute. And the compute could be on-prem. It was originally set out to do it like that, but we're also supporting trusted research environments as well. So we support two main federated learning frameworks, MV-Flare and Flower. And we're recently, with Zhong Shen at Flower, assessing the feasibility of connecting this compute from supernodes into supergrid. And the advantages are very clear. We would be able to leverage the already very good install base that supergrid have, but also the security features and compliance that they bring. I'll show a very quick glimpse of what flips look like. What looks like we have role-based access control. As a user, you can create a project. And then the first step is to, after creating a project, doing cohort selection. We use SQL database querying in order to select a cohort that you want to do research with. So this is federated across hospitals. And once you're happy with the selection, we stage this project for approval, and it gets sent to a data access committee that approves the project for use. And after data ingestion, you can see that data and train AI models. So currently, we let users upload their code. In the future, we'd like to leverage Flower Hub and verified apps so that you can run them seamlessly on Flip. We're targeting the more lower-hanging fruits. At the moment, in supervised learning, we've got a few tutorials you can check out, but we'd like to move beyond that into foundation model training. We also support model evaluation, and we leverage AI at different steps of the pipeline to make the user experience easier. So data annotation in supervised learning or quality control models before training. And this is my last slide. We're trying to really support the entire AI model lifecycle from data harmonization to training those AI models and then partnering with AI deployment suites to get those trained models deployed into clinical practice for real clinical use and really improve value care. So yeah, check out our GitHub repo. We're a small team, always looking out for contributions. So yeah, happy to have a chat after, but thank you.
Thanks so much. It was a wonderful initiative. Any questions? We have time for one quick question. We'll go with the gentleman just here.
Hi. So I saw in the diagram that you showed that your database is in secure enclaves, right? But you're taking data out of those secure enclaves to train your models. Why couldn't you run your models on the secure enclaves as well? So that gives you an added layer of security.
It's a good question. So there's two answers to that. So when in the unimodal space where you only got the databases, so the London Analytics platform from One London lets you take the data out of those practices, right, and put them into a TRE-like environment. But we think that's not really feasible when you start adding images because you're working with different levels of magnitude, and also that data is a bit more identifiable. So what we do in that case is we just we keep the data at the hospitals, and then only aggregated data ever leaves the site. So we only sending aggregated information, aggregated model weights to the FL server, which could be either in our AWS hosted hub or in the Supergrid if that comes.
Okay, perfect. Thank you so much. So that's the end of session 2. We're now going to break for lunch. We're running about 10 minutes behind schedule. So we're going to start again at 10 past 1 local time. Enjoy your lunch and come back for the fireside chat.
Hey, good afternoon, everyone. Welcome back to day 2 for Flower AI Summit 2026. So I'm Chong Shen. I will be a host for this afternoon for the next 2 breaks. Just taking over from William. So we just heard the very nice session just before this, which is about the focus on healthcare and life sciences. There was a very nice overview from Javier earlier today about how Supergrid can also help you achieve some of your projects through healthcare and life sciences, and also hear some actual use cases and applications that extend and build on Flower to achieve some real problems such as Flip, as we have heard from Alex earlier, and also from ISGlobal, where we have the world's first integration of DataSHIELD and Flower. So we are really excited to work with the organizations to help achieve and empower the community to use Flower through various means. So that includes integrating with DataSHIELD, so that a lot of the biostatisticians who are more comfortable working within our environment or working with DataSHIELD can also use the underlying Flower framework to power the federated learning workloads. So let's give a quick overview of also what's coming up next. Today, right after lunch, we have a very nice fireside chat that will also take place. We are heavily themed in the healthcare and life sciences in the first session right after lunch. And then in the afternoon, we have a lot of heavy focus on general governance mechanisms within Flower. And then as we wrap up, at the end of the day, we move towards looking at how the adoption of collaborative AI and federated AI moves towards scaling compute, scaling in the sense of working with clusters or Kubernetes-like cluster deployment, or also even working with high-performance computing. So I'm really looking forward to the full agenda today. So as always, all of us here at Flower Labs are on standby, and if you have any questions in terms of the what has been announced recently, or even questions for the speakers that have just given their talks, feel free to drop them in chat. We are live on YouTube as well as on the public Slack, so we can more than happy to answer any questions. Yeah, so I'm just going to take a quick look at the public Slack to see if there are any other questions from the audience. Nothing has come up just yet, but of course, feel free to ask any questions if you have any. One thing that I would like to also draw on today as well is there have been very interesting conversations from the healthcare and life sciences use cases. We see a lot of common patterns there from a perspective of how can you ensure your disclosure controls are implemented in the correct way or in the right way, appropriate to the needs of the specific deployment. And those are common questions that come up time and again. So we see this common pattern in terms of disclosure control, and we also see in terms of general governance, how can you ensure that the apps that you execute are verified, and that means you as a researcher, when you execute it, you know that your code is not doing something unexpected, because that is a primary key concern. So I think the learnings that we see there are transferable to all other fields, not just in the healthcare space. And we want to emphasize that all the mechanisms that we see here are truly applicable and relevant for the other industries. I think this is one nice and common pattern that we have seen across industries and applications. So yeah, I'm also very curious to those who are online, tuning in right now. If you have any open discussions or open topics that you would like to just bring up as well, we'd be very curious to understand what your general needs are in terms of running your federated learning workloads. And if you have any questions about that as well, you can also ask us. Yeah, I think, let's see. I think we are. Give me a moment. I think I've been told that our schedule is slightly delayed, which means that we will commence about 10 minutes past 1 o'clock for the next session. That means our fireside chat should start at 10 past 1 local time in the UK. So for the remaining 40 minutes, we will have a lot of time to discuss. We have an interesting guest right now, and it's a familiar face that we have on the previous AI Summit events. I'll just welcome him. If you can step a bit closer to us. Sean.
Yes.
Good to meet you again once more. And for those of you who don't know you and also what you do, could you just introduce yourself to the audience? Yeah.
My name is Sean O'Fihely, and I'm a PhD researcher at Ulster University in Belfast, and I'm researching trustworthy federated learning on resource-constrained devices.
Excellent. Yes, I was there listening to your talk earlier this morning, Sean. Do you want to give a quick rundown of what your talk was about?
Yes, so I'm starting to develop a knowledge-based approach to intelligent client selection, because I kind of see that as the big problem within sort of federated learning on resource constrained devices. Very often, like a random selection approach will pick devices that aren't capable of doing certain tasks. So I'm trying to implement a knowledge-based approach, ontologies and reasoning to intelligently select devices to cluster based on the resources for a given task.
Yeah, that's right. I remember from the talk you gave this morning, in my mind, when I interpreted the proxy for a performant client is the battery, because in this case, it's an edge device.
Yes. No, I was sorry. I was just going to say that was the parameter that I used for sort of the initial work, but I'm hoping to extend it to like a range of parameters.
Correct. Yeah, absolutely. I guess the proxy to measure a performant client would just be more than, could also be more than battery. It could involve other things as well.
Certainly, yes.
Yeah. There was also one question that I had. I was actually more curiosity. It crossed my mind when I was listening to your talk earlier this morning. Was that it looks as though that in this model sampling, the performance sampling approach that you had, am I understanding correctly that you need to aggregate the all the clients' performance somehow so that the server knows which clients to select?
Yeah, so what I'm trying to implement would be taking a real-time snapshot of the available resources. So we kind of, as would be obvious, say if we're just taking the battery, as you have devices doing data collection or training, communication, the batteries will drop down, which means they won't be suitable for every type of task that the network may get. So it would basically just be like a real-time snapshot that's updated into the knowledge base. It's a graph-based knowledge base.
Yeah. Very nice. What do you think the volume of devices, does this algorithm, the algorithm that you propose, does it scale quite robustly to a number of clients?
That is one of the big questions that I need to answer. The initial work seems to be that it scales reasonably well at the minute. I haven't gone into large scales of devices, so I probably will hit a wall at some point where you're not getting any further gain, no further advantage. But at the minute, it seems to scale quite well. And of course, the advantage of having a larger network is you just have a greater pool of devices to select from. So if you're doing a very AI intensive, like an inference task, if a client then is no longer suitable, you have another one that you can slot in its place.
Yeah. It makes sense. I think the approach that you described is it's quite sensible, and I can see in certain scenarios where you have large volumes of devices and you still want to learn in a more optimized way. This is one approach to do it. Do you think then this has a direct impact on the overall efficiency of federated learning? Efficiency from a perspective of energy consumption or utilization? What do you think?
Yeah, no, and that's really one of the keys. In my sort of opinion and my sort of way of thinking about it, when you're selecting the right devices for a task, and in my sort of vision of this, you could have a network of devices that could be assigned a range of tasks. So as long as you're selecting the most optimal devices for the task, you're going to have an efficient network. And in the way that I want to do this, the most optimal isn't always the one with the maximum resources.
That's true.
It's because then it's overkill.
Yeah.
So I'm trying to select the devices with the most optimal resources and cluster them into a network.
Yeah.
So in terms of energy efficiency and all, I think there's potential for wins in that area too. Yeah.
That makes sense. To wrap things up, would you share roughly like what's next in your view? What else can you see in this research path that you have?
Yeah, certainly. Well, the next big thing that I'm aiming to do is to start to develop. I want to develop an orchestration manager, so something that can reason over the knowledge base. At the minute, it's quite hard coded in. So I want to bring in that orchestration manager, some sort of agent, not necessarily an agentic thing, but maybe, but some sort of process that can reason over the network and then sort of select clients based on that. So basically it would just allow somebody to in effect plug and play, just once the network's in place you can allow it to go. So that, I think there'll be a couple of wee minor steps, I'm sure, but that's the next big thing on my plan.
Yeah, that makes sense, I guess. Yeah, so moving away from a heuristics-driven approach to client selection to something more that can decide over this non-linear space of selection, the optimum.
Well, that's it. And sort of, I suppose another thing to look at is how you handle, because microcontrollers and IoT devices, clients drift in and out of the network. So how we handle those types of things, what happens when a device goes down, there's a lot of things, and I think an orchestration manager can help with that.
Yeah, it's very nice, very nice. I like that the space you're working in. I would call it the class of like edge computing, or edge it can be anything.
Yeah.
And I like that. I've also interacted in the past those milliwatt type of devices that have their own set of constraints and connectivities and compute as well. So I can see very well how
that's it. It's sort of, I always say that, the challenges when you're dealing with resource constrained devices, they're the same as in all federated learning space. They're just more awkward.
Yeah.
They're amplified just that little bit more.
Yeah. It's very remarkable how these devices are so actually pretty common, I think, but it's one aspect that as far as I can tell, there is a family of tiny ML that does run on these devices. And there's still so much potential to explore with it.
And of course, I'm going to be biased, but I think it's a really sort of, it's a large space and it's an interesting space.
Yeah, absolutely. And for those of you online who wants to, maybe learn a bit more about FL in edge compute in general, where can they find you?
I'm on LinkedIn. I suppose I don't want to go in to start spelling my name here.
I think it's a bit of an
awkward.
They can look you up on our Flower AI Summit agenda, and they can definitely.
Oh yeah. No, just connect with me on LinkedIn, or if you find me at the university, Ulster University email, give me a shout there as well.
Absolutely awesome. Thanks, Sean. Thanks for.
No worries. Thank you very much.
Yeah. All right. I'll speak to you in a bit. Awesome. That's good. Awesome. Thanks, Sean. Yeah, so that was Sean. He gave a talk earlier this morning as well. And it was pretty cool. All talking about edge compute, and yeah, it was very nice. I think next person that we have here is our very own Mohammed. He's going to jump on. We're going to have a casual conversation as well. Mohammed, if you can grab this, then I think we'll stand on these pink lines over here. And yeah, so Mohammed, I think we worked together for like 2 years now. I know you, and maybe for those of you who don't know yourself, and also the kind of work and interest that you are in, can you describe to the audience?
Hi everyone. I'm Mohammad Nasseri. I'm a research scientist in Flower Labs. I've been in the company for more than 2 years now. And since I've joined the company, I worked on different projects related to security and privacy in federated learning, Flower Intelligence project, and recently Flower Hub. And that's it about me.
Yeah, Mohammed, I think you're underselling yourself. I see that your background comes very strongly from the privacy aspect of federated learning in general. I think you have very deep expertise in that sense, and you also have contributed to a lot of the other features in Flower in general across the space. Could you share a bit about the topic that you covered this morning with Jan?
So recently we launched a project called Flower Hub, which is kind of similar to a GitHub for the repositories that we have, but this is mainly for Flower applications. And So we had a successful launch. We had different partners. We have currently more than 100 apps published on Flower Hub. But that was not like the stopping point for us. We had to make some adjustments, adding new features to make Flower Hub more ready for collaborative AI deployments. And for that, we actually introduced two new topics. One was Fab format version and the other a verification. So the Fab format version actually allows the Flower applications to basically adjust their compatibility based on the validation rules that are defined for the Fab format version, and the verification allows basically having reviewers to sign and submit signatures, and then it allows all the clients that want to execute the Fab decide based on the verification that they have. This is very important for the real-world deployments because not everyone can trust the app or Flower Hub, but they can have a trusted list of reviewers, and based on that list, they execute the Fab applications there.
Yeah, thanks. No, thanks. You highlight, I think, two very important aspects of the Flower Hub, and I was talking to Jan yesterday about this. There is, I think there's more to just the Fab format version, right? So firstly, if I were to describe it in also a different way, the Flower Hub is where you can host your Flower apps, right? And these are self-contained projects that have not just the core app that will run in the Federation or in your workload, but also any other supporting files that can be configured for that specific project, right? So that means you can maintain a well-linted project that people can then use and adapt and build on, right? That's one thing. Then the concept about the Fab format version here, right? I think it's important to also emphasize that it's not just version control, right? It's also compatibility control in the very the simplest way to put it.
Exactly.
Right?
Yeah. So it's maybe more like an application formation basically topic. So those fabs, they can correspond to a specific number, let's say, and then that allows to basically define different rules for that number, and then enforce that rule for the fab.
We realize we talk a lot about fab. Maybe you are quite familiar with it. For those who don't understand it, can you explain a bit more about what fab is?
So fab is basically just a bundle for the Flower application, which includes specific files in it, like the Python files or the TOML file or the README. But yeah, all the users there, they should always check the documentation, because we have a specific documentation for the files that are included in fab, which can be changed over time.
Yeah, absolutely. I think so the fab, we call it the Flower app bundle.
Yeah.
And one way to think about it is like a compiled version of the app that would run in the server app as well as the client app, the app that actually gets executed. That's nice. So on the second point here, we briefly talked about it. You mentioned it, which is the app verification process. As a user, if I want to, so firstly, the app verification of verified apps is a very powerful concept, and it's a very powerful feature, because that means it allows the data providers, those who run the supernodes, to determine what apps are allowed to execute on the data that is connected to the environment. Yeah. So as a general, let's say, infrastructure or developer person, to identify which apps to allow, how can you describe the broad steps for that?
So maybe it's just a recap of what I presented today. Like there are different approaches to the problem that you described. One is that all the clients that they receive the fab, they review the fab themselves, and then they decide if they want to execute it or not. But as I mentioned also earlier, this is not going to be easily scaled. And then the review process becomes like inconsistent between all those clients. The other approach is that what we do like App Store, basically we trust the Flower Hub, and whatever it returns, we just execute it. But this is also not desired for the users. They don't want to do that, or we also don't want to become the bottleneck for the trusted authority here. That's why we decided to make the verification decentralized. So all those clients or participants, they trust some specific reviewers, and those reviewers independently, they review the fab, they sign it, and they submit the signature with that fab, and we save it on the Flower Hub side. And when the client actually fetches the fab from Flower Hub, they also receive all those signatures corresponding to the fab. And on the other hand, they have a list of all trusted reviewers, and then they can basically, based on that list, check if that reviewer has a signature for that fab, and then they either execute it or just reject it.
I think that's a very powerful mechanism. Have you? What would the reviewers, when they review the apps, you need to trust them, right? We have kind of delegated the task of reviewing to the reviewers. So based on the criteria that they have, like some reviewers, they want to basically review all the code line by line, or they just want to execute it and see if it performs anything like suspicious or not, or it's all delegated to the reviewers. As soon as they submit a signature, we know that their criteria has been passed for that fab. And then participants, since they trust the reviewers, again, based on the criteria, they just execute or reject it. Yeah, I think it makes sense. We definitely have had a lot of internal discussions to identify the most optimal workflow that could make this to improve the trust chain for verifying the apps. I think it's very impactful and also very meaningful to a lot of applications out there. Just to switch gears a bit and also want to wrap things up, because I know you also want to go grab lunch shortly as well. I know you personally have a lot of interest in working in differential privacy, or maybe you have some other interests as well more recently. Do you want to share maybe like what do you have in mind? What's next?
I mean, everyone at home knows that the federated learning in its vanilla form doesn't provide privacy or security. It's kind of a minimization approach. And we in Flower actually make it more private and secure by integrating different privacy preserving technologies, and one of them is differential privacy. And the good thing about differential privacy is that it gives us a mathematical privacy guarantee. With that guarantee, we know that there is no leakage from the model updates that are being exchanged between the clients and server, or from the model that is going to be deployed. But the drawback here is that differential privacy actually affects the utility. We have always, we had projects that we once we apply differential privacy, the model is not desirable for us. So I think one of the directions that we are moving toward is that we come up with empirical differential privacy, where basically we also apply attack, and based on the threshold of the attack accuracy that we accept in our setting, then based on that, basically we apply differential privacy, because in that way we can improve the performance and get the privacy that we want. That privacy is not necessarily acceptable for maybe another setting, but it is acceptable for the setting that we have. And I think that's one direction that we are moving toward.
Yeah, excellent. So that means for my, if I want to think of it in a different way, when you implement differential privacy in general to federated AI, it's always a Pareto optimization problem. And the two ways to approach it is to potentially, you could start with applying the differential privacy techniques in the first place, and then work backwards. What is the utility? Or you could approach it from a rate teaming perspective. You know, what can you make what can break, and then only apply differential privacy to achieve the thresholds that you want.
Yeah, exactly.
Very nice. Yeah, I think it's awesome. I mean, I'm pretty excited. There's a lot that I'm getting out from, not just from sharing what we have done here, and also listening to all the other users out there today. And so thanks, Mohammed, for jumping on the live stream to also share your what you have presented. Yeah, I'll speak to you in a bit upstairs and enjoy lunch. All right, thanks. All right, so we've just heard from Mohammed upstairs, who just came down and joined us. I'm going to step out of view for a moment to adjust a cable. Yeah, and it was great to hear from him. Just a recap of, he talked about Flower Hub and where as a user of Flower, you can publish your self-contained Flower apps, full self-contained projects, so that others can build on it, and you can also pull the apps and run it on your federations if you want them to. There's also a lot of discussions about differential privacy. I would say it's not a trivial topic, because when you think about federated AI and collaborative AI in general, you also need to think about what kind of levels of privacy you want to assure from your data providers. And there is a holistic view that you need to take when you roll out a full FL solution in general. So that being said, if you have any questions or any specific projects that you have in mind, that you also like some input from us, feel free to not only reach out to the community through our public Slack channel, but you can also contact us as well at hello@flower.ai and see how we can help you out as well. There's a lot of documentations that we are continuing to update on the topics of differential privacy and secure aggregation. So stay tuned for all the new releases of the documentations for every Flower release. All right, I'm just checking on the time. I think we are about 15 minutes away from the next session. Once again, the next session, which will start at 1:10 local time in the UK. If that has not changed, I believe that is still the case. We'll have a fireside chat with Gabriel Corso, and then we'll have again the 3 topics that is related to healthcare and life sciences. The first one, which will be federated learning for neuroscience, followed by the work in Dortmund in Germany, where they have used Flower to run decentralized AI in GP practices in Germany. And finally, the end of that session would be the work from Aridia. So that will be delivered by Scott Russell from Aridia, where they have integrated their trusted research environments, which they call Aridia DREs, together with Flower, and it's been deployed. So I'm very excited to hear what they have to share as well in terms of updates and progress from their end. And we've seen a lot of a general interest from the audience and also from online, the people who want to solve problems in healthcare and life sciences. All right. I'm also taking a quick look at the public Slack to see if there's any other questions online. Nothing just quite yet. Once more, feel free to post any questions. I can also take them live and also answer them if you have any. Just checking across the other channels. Nothing yet so far, but no worries. I think if there's any other questions from the YouTube, someone will also ping me as well. Not to worry. Let's take a quick recap of day one while we have a bit of time. So day one, we heard quite a lot of things from the Flower side. We talked about Lizzie. Lizzie is Flower's first foundational model, trained in the UK and optimized for UK usage. So Lizzie 7B is freely available right now in an open weights, it's Apache 2.0 license. You can get that from Hugging Face and start to use it out of the box. And that's really optimized so they can start using the LLMs that's based in the UK. We have another guest who's going to join us in just a second. So I'll just invite the guest. And if you can just step over here on the pink line over here. Yeah, excellent.
Yeah,
hi, how's it going?
Good. How are you doing?
I'm doing well, thank you. I know we have definitely met before in the past. And for those of you who don't know yourself and also what you do, can you introduce the live audience?
Yeah, sure. I'm Philipp. I'm a researcher at TU Berlin. I finished my PhD there last summer. And I'm now a postdoc. Right now I'm a visiting researcher in Cambridge. And also I'm a research scientist at Excelsius, and we've been working with Flower. I've been working with Flower for almost 4 years, I think.
Very nice. Very nice. Do you want to give a quick summary of what you've been up to and what you find exciting more recently?
So we were giving a talk yesterday about it was like carbon-aware LLM training. So we're trying to usually schedule machine learning trainings based on the availability of clean energy. So this is the entire idea. We had a project here where we were like training distributedly pre-training an LLM on curtailment windows. That means like at times where we have an excess of, for example, renewable energy in a certain part of the grid, we try to spin up GPU resources or use idle resources in that region to pre-train an LLM that is then quite clean,
yes,
and also cheap, because this energy is usually very cheap curtailed.
That's pretty cool. What's the appropriate metric to measure the greenness of an LLM?
It's a big discussion. There's different accounting standards, different metrics you can use. There's also, there's a consensus on one. It's called average carbon intensity. So you basically try to have a weighted average. You try to sum up all the producers in a certain region, weighted by how dirty the energy source is. Coal would be dirty, solar would be clean, for example. There's different standards. There's a lot of discussion on how to do it right. There's many assumptions. It's actually a very complicated problem, because to do it right, you would need to really understand how all the actors in the grid work, like who is actually ramping up their consumption, who is storing energy and at what price and so on. So it's quite complex. It's an active research topic. There's no good answer to it, unfortunately.
No worries. I think many years ago I come across the carbon accounting topic for other industries as well, and it's super relevant. So now it's
exactly. There's different communities. There's carbon accounting communities. Then there's like electricity markets that work very different from how electrical grids work, and then there's reality. So it's a bit messy.
Yeah, I can imagine. Is the work bounded within a certain nation? For example, since you said you work in Cambridge, is it within the UK borders or?
No, not necessarily. I mean, these approaches are usually most effectively if you like on global scale, because you can, for example, follow the sun with your compute. Like,
oh wow,
yeah,
that's amazing.
It's a powerful picture. It's not as easy in practice because often like GPU resources are usually not just sitting idle and waiting for the sun to come up. So
that's true.
A lot of practical constraints. But yeah, usually they work globally the best, but it's complicated because like also how electricity markets work, for example, is very different in Europe compared to the US.
Yes.
So it's hard to like generalize approaches. Even data availability can be very, very different in different parts of the world.
I can imagine. So apart from the complexities of accounting for clean energy, were there any particular highlights of the project? And it doesn't have to be challenges, but was there something really promising that you got out of it?
Yeah, I mean, this project here was like a very concrete implementation of like a scheduler. So like we really built, based on Kubernetes, we built like a scheduling layer that was like elastically
awesome,
adding and removing nodes from the training depending on curtailment signals. But the signals could of course also be spot instance, for example. So like we're like this scheduler is quite efficient. So like if you see, I don't know, a spot instance popping up, you have a good price, you can add a machine to the training quite fast, and then we change the streaming of the training data to this node in a way so that we can maintain an efficient pre-training without, I don't know, using the same batches on different machines at the same time.
Yeah. That's pretty cool. That's pretty cool. Then looking a bit forward, could you offer your thoughts about like what's next? How else can you tie it out? Are there just more open questions in this research topic?
Yeah, what's personally interesting to me is again carbon accounting. This entire question, like especially if you have like a distributed training or like also like an agentic system where you have like different players that operate their own nodes or operate their own agents. How can you like reliably trace the carbon footprint of a request? So I'm calling an agent, this agent is calling other agents. How can like I maybe even verifiably trace the energy usage of such a request through a system, also the carbon footprint of such a request to a system. So in the end, we want to like create accountability for users. So you can, maybe they change their behavior, or maybe you can like also incentivize better behavior or punish them or like tax them or whatsoever. So the technical basis for this is missing right now. So this is something that's interesting to me personally. So carbon accounting in agentic systems, distributed AI.
Very nice. That is super massive. I think the topic has so much promise, and I'm really excited to see what's next and what comes out from it.
Thank you.
Yeah, thanks very much, Philip, for joining me on the live stream. Yes. I know we have maybe a couple of minutes left before the start of the next session. Okay. So I'll leave you to it to grab a cup of coffee before you.
Thank you so much. Good. Have a nice day. See you then.
You too. Speak to you soon. Okay. See you.
Bye-bye.
Excellent. So that was also Philip, who's also working on an area which I'll have to admit it's something that I've not thought of explicitly, but is incredibly relevant in terms of carbon accounting and what does it mean by ethical usage of collaborative AI. Both in terms of producing the AI model and also consuming it from the sense of running it in agentic workflows, which is pretty cool. So yeah, if you have any questions about this topic as well, if you have any follow-up questions, something that triggers your thinking as well, feel free to reach out to us on the public Slack, and we could also float discussions to Philip. In fact, Flower Discuss is also active. If you want to dispose any questions and just open thread as well, I think that would be a pretty nice place to also put your questions. Great. Taking a look at the time again, we have 6 minutes before our next session, which will be the fireside chat with Gabriel, and that entire block again will be related to healthcare and life sciences. So recap again from day one. Yesterday morning, we heard about the announcements of Lizzie 7B, which is Flower's first foundational model that is trained within the UK for the UK usage. We also heard a lot about LLM usage and agentic workflows from the keynote that Daniel gave. We also heard a lot from the users who have increasingly looking at LLM pre-training and fine-tuning using federated learning. And in the afternoons, we were looking at the arrival about this European NeoLab. So it's a very interesting panel that talks about sovereign AI and how the role of the European culture could help to advance this frontier. I think towards the end of the day, we had a lot of discussions about convolutional compute, learning more about how collaborative AI as well as convolutional compute are very complementary. It's not two sides of the same coin, but something that, depending on the usage, is also very relevant. Depending on depending on the use cases. Towards the end of the day, we give a bit of a talk about the federated AI architecture. So we collaborated with the Red Hat team, for example, with Tony, to talk about how Flower, as one of the federated AI piece, can help to work with the Red Hat technologies such as OpenShift and OpenShift AI to deploy scalable federated AI architecture at scale. We also then heard about Supergrid, where I gave a quick overview of what Supergrid is, including a demo. And the main point is that Supergrid is live, which means anyone, and it's publicly available, which means you can sign up online on flower.ai and create a simulation runtime federation and start running your workloads on Supergrid. You can now also do it without running any infrastructure, because everything is hosted. If you are interested to deploy supernodes and also connect them to Supergrid, you can reach out to us at hello@flower.ai, and we can work with you to understand your use case as one of the early access users to get you onboarded as well. The one thing about the key point as well to work with Supergrid is that you can have multiple federations. So you can create the federations that you need for specific use cases and invite users to different federations. So that gives a very clear separation between the workloads that you want to run as well as the supernodes that you connect to each of the federations. Yeah, I think it's a very nice summary. I just encourage you to just jump online, sign up, and then just start to play around. I think you can see that you can achieve quite a lot just from that. Very interestingly as well, you do not have to use the Flower CLI to run your first execution. You can in fact just go to Flower Hub, so flower.ai/apps, and pick any one of the apps, for example, Flower Labs/demo, and then run it at the federation that you started, which is the simulation runtime federation. Yeah. Talking about moving from Supergrid in the afternoon and evening, we heard from Charles, our very own Charles, who shared about Flower agents. I think we personally here at Flower Labs believe in the era of network AI. So by network, we not only mean being able to train a better model, just in general across this decentralized data and decentralized compute, but also be able to run agentic workflows in a collaborative way. The architecture of Supergrid is very compatible with the workflows of collaborative AI, and that is one of the key reasons why that is we decided to build Flower agents and also have a preview of that. So I encourage you to check out Charles's talk when it goes up online, and if you are interested to sign up and use that, feel free to sign up on the form, and then we'll reach out to you for early access. Okay. All right. So for now, we have the at the end of the day, we have a lot of nice discussions. I've had very interesting discussions with users that work in the data centers as well. So we have this work by Ivan, who talked about federated learning in critical infrastructure. And that means how can you actually use federated learning in data centers to optimize cooling efficiencies, because data centers they consume a lot of power. Being able to optimize the power consumptions is obviously very critical. And the main point is that this data cannot move. So interesting thing is that they really have a platform that works very well, but there are very real world problems there in terms of connectivity, of when these data sets can be made available for training this predictive model to optimize power consumption. It's a very nice use case there described by Ivan. Okay, that was day one, a quick recap. I realized that I ran through quite a significant list for that as well. Let's take a look quickly now on Slack if there are any further questions from the public. I'm having a look at the questions channel. Okay. Okay. So there are no other questions yet on public Slack, but I've just been told that very soon, in about a minute, we are going to start the next session with the keynote, with the fireside chat. So stick around. If you do have any questions once more for any of us here at Flower Labs, feel free to drop them in chat, and we'll also ping you on that. So looking forward to the next session. Really focus on healthcare. I think that's pretty much that from this session, for the lunch session. Our next break will be roughly 2:30 p.m., maybe 2:15 or 2:30 local time in the UK, and that's where I'll also jump back online to talk to you about to recap the session about healthcare before we jump into the next session. I'm looking forward. Once again, we have a very, I think it's one of the biggest attendance here at Flower AI Summit in London. We have, for those of you who are not here in person, it's pretty packed, and we're really happy that the venue here at King's House have really hosted us very well for the past couple of years. Excellent weather, wonderful venue, fantastic audience, and we're about to start the next fireside chat in a couple of seconds. All right, we're gonna start very soon. See you soon.
We're gonna get things underway. Okay, if everyone's ready. So we have our next session after lunch here. It's going to be an exciting fireside chat. I'm joined here by Gabriel Corso. He is CEO, co-founder, or founder, I guess, or co-founder of Boltz. Boltz is a really exciting startup built on a really exciting type of foundation model for life sciences, really quite broadly. You're telling me about the variety of models that you've developed. And so I think this audience, this community, is really interested in a number of themes that touch upon what you're really innovating in. It's interested in looking at how we can advance frontier AIs in important domains like drug discovery, life sciences more broadly. We're really interested in open source models and ways to also unlock new types of data that's currently siloed away in different institutions, different companies. And all those themes really interact with what you've been building up to. Boltz really exploded onto the scene in the last, I guess, 9 months. And so I hear so much about Boltz lately. So maybe we could kick things off by you just introducing Boltz, yourself, where you think things are going for your company and the model itself.
Yeah, so I guess by training, I'm a computer scientist. Did my undergrad in Cambridge, and then went to MIT for my PhD, where I worked on models for kind of structural biology. And the exciting thing of this field is over the past 5 years has been especially started with AlphaFold 2, the model that won the Nobel Prize. Has been a complete transformation in the way that structural biology and subsequently kind of drug discovery is being done. And in terms of kind of the way that Boltz was born, at MIT we're working on a lot of kind of the leading kind of open source models. Obviously the DeepMind team here across the road was also kind of pushing kind of the frontier with the various AlphaFold models and so on. But at some point the DeepMind team decided that the way that they wanted to commercialize these models was by basically starting isomorphic labs, which is sort of like you can think about it as a fully integrated pharmaceutical company. Mm-hmm. So they develop these frontier models, but then they keep the models internal to just limiting the access to their scientists, to their chemists and biologists, to build new drugs. And so what we saw was that the 99.9% of chemists and biologists in the field that work outside of isomorphic all of a sudden didn't have access to the latest, state-of-the-art models that could really help with their ability to push, kind of the discovery of, kind of new therapeutics. And so we really started Boltz as a way of, kind of countering kind of that trend and developing models and, developing tools that we could give to every scientist. And so we have built a number of models, many of which are open source. Our open source models are kind of adopted across kind of the industry. Every large pharmaceutical company is using them. We have hundreds of thousands of scientists that are using them on a regular basis. And we have also since then we've also spun off from MIT, started a company actually based a block away from here. And, we are continuing to push the frontier as well as, building, the right kind of tools and also, the right kind of tools for enterprises to use these models. It turns out that especially when you're dealing with, chemists and, biologists, putting a model on GitHub is not enough for them to very effectively use it in their, discovery programs. And so we're also thinking about, what is, kind of the entire, platform that, these scientists need to make the most use of these models.
Oh, interesting. And so what are the industries that are adopting, as you mentioned, chemists, you mentioned, quite wide skill sets. So where are your users coming from?
Yeah, so I would say kind of, a large part is pharmaceutical. So any kind of therapeutic discovery, especially for developing novel small molecules as well as novel biologics. So the vast majority of kind of, approved drugs. But on the other side, there are a lot of other places in life sciences where you're designing novel small molecules, you're designing novel proteins. Interesting examples are, perfumes are, molecules that interact in a particular way with the proteins in our nose. Same is for taste. And so all the similarly, if you want to build new agricultural products, new food, new beverages, there is a lot of work on chemical products as well as chemical synthesis of different products where we see a lot of usage of this model. So, and then obviously a lot of more kind of core biological research that has been using kind of our models to really understand how molecular biology works.
Oh, that's interesting. And so it sounds like people in those fields are sort of undergoing a real kind of computer science AI moment in the way that they approach their task, their sort of process.
Yeah.
Could you give us an example of their workflows? Are they taking like one or two foundation models and then fine-tuning it or adapting it for different stages of things they're doing, or are they very specific models? What does it look like to them? We're quite familiar with certain kinds of other domains, but I don't have an insight.
Yeah, so I mean, I think an interesting example of how the field has evolved is for example, looking at a particular task is developing an antibody drug. Antibodies are a very common type of drugs, and the way that you would initially start developing an antibody for a particular disease is that you have a target for that disease, and then you would try to find an antibody that targets that particular target in a selective way, and this target tends to be a protein typically. And so the way that historically people would do this is with what's called immunization. So you basically inject this protein in a particular way in different mice or rabbits or llamas, and you would wait for a while and hope that they develop antibodies to fight against this protein that you have introduced, and then you would try to sequence their blood, find their antibodies, and try to find good ones that might be applicable to your task. Now, with the development of kind of this new protein design and protein kind of, structure prediction, affinity prediction models, we have a completely different workflows where instead, people are starting by computationally designing these proteins. So not getting the mouse to design these proteins, but computationally designing these proteins, and then only testing, maybe, 20 to 100 in the lab, and already finding kind of good hits that then they will kind of further optimize to become therapeutics. And so we see obviously the timeline shortening, getting a lot more controllability using these models, but also shifting reducing the cost and shifting a lot of the cost from having to do very heavy experimental work to a much more limited experimental work and a lot of computational design.
Interesting. And there's a lot of discussion about the shortening of these timescales to do different stages of discovery and development and so forth. Do you think, are we at that point where the timescales are actually starting to shrink visibly, do you think?
Yeah, so we're definitely seeing kind of timelines shortening for different rounds. Obviously, the biggest challenge right now is still, kind of one of the steps that takes the longest is, the clinical trials. And that, there are interesting things that people are doing to also shortening those. But I would say, in general, when it comes to the preclinical phase of developing those molecules, we are definitely seeing, timelines shortening, especially for protein biologics-based drugs, and more recently also for small molecule-based drugs.
Can you give us a sense of the dominant architectures and sort of data sizes for the models that are being used? Because we're quite familiar with, large language models and, CNN for computer vision tasks and so on, but maybe we're less familiar with what it looks like to these folks.
Yeah, so I would say, actually one of the things as a computer scientist, a machine learning scientist, that is really exciting about this field is that, we haven't converged to a transformer yet. And so the architectures actually in this space, are very interesting. We have architectures that use these different kinds of attention layers where the attention is basically cubic. We work on basically trying to understand interactions between pairs of kind of what we call tokens, which are subparts of different proteins. And so we have these very somewhat unique architectures. They are quite actually computationally pretty heavy, compared to a normal transformer because of the higher complexity and the cubic complexity, and the corresponding of the next word prediction, pre-training of language, in this space is structure prediction. So this was the task that AlphaFold was particularly effective at challenging, where we have this data that's been collected over the past few decades of different structures of proteins and biomolecular complexes, and basically we are training these models to predict the structures. They are largely diffusion or flow-based models, and then though the critical thing is that then we do reuse these models as basically foundation models to then also use their understanding of how molecular interactions work to predict other things apart from structure, other properties like the affinity, the strength of the interaction, as well as designing kind of novel small molecule and proteins.
And the data scale? What is the data scale for these kinds
of
models?
The data scale for structure prediction is on the order of a couple hundreds of thousands of structures. Obviously, a structure is pretty rich in terms of a data modality. Is on the order of like the atomic position of a few thousands of atoms. So a few thousand of atoms times around 200,000 structures is kind of the base model. We've also figured out, like in the LLM space, a way also to generate distillation data that obviously helps these models. And then for many different downstream tasks, we also have a lot of downstream data on affinity and design and so on. But structure has been this incredible kind of task that even though you might think and it is somewhat limited in terms of the scale, where especially when compared to some other fields, we've been able to do incredibly interesting things with that.
And is there an evolving open source movement behind this? You mentioned that you're sort of, if I'm paraphrasing correctly, so there's isomorphic labs model of like internal usage, but there's a bit of a vacuum for everyone else who wants to participate, and that's where you're sort of occupying. Given that, is there a lot of interaction with people improving these models and then sharing new data sets and kind of an open source acceleration of the models of these kinds in that community, and one that is sort of in contrast to these closed models?
Yeah, so I would say kind of the interesting things is that, when people think about, open versus closed models in the LLM space, you think about, an open models where it's kind of open weights versus a closed models, that is available under an API. The interesting thing about, this space is that, when we think about the closed models from some place like isomorphic, it's not that, you have to use an API, it's that you really don't have access to it. Even if you're willing to pay, you really don't have access to these models. And so, it's really like a open access versus closed access, I would say, kind of, the big difference that it's even more dramatic in this space compared to in some of the LLM space. And yeah, so us and a couple of others have really been, pushing kind of, this open source and open access, set of models that, the wider community, both in academia and industry, can use. Interestingly, kind of the biggest players is like a couple of them. We are a couple of startups. There is, some academic labs are also trying to push kind of these models, and then there is ByteDance that is also kind of like playing interestingly in this space with some interesting open source models. So it's an interesting ecosystem. Obviously, there is a lot of a community. We have a very widely engaged community. I would say it's obviously as with many open source models, it's a bit more challenging with open source models versus software for the community to really kind of directly contribute to the models, but definitely it's we get a ton of feedback that really kind of drives the next generation of models.
Interesting. And what are kind of the hardware and training timelines that people will see for models of this scale if they're building them maybe from scratch?
So I would say kind of like a typical one of these large models, at least the base models would typically take a month on a few hundred GPUs to train. So still, reasonable scale, like a couple of millions worth of compute.
Yeah.
And so that's kind of the scale that we're talking about. People have tried to scale up, but in practice is actually is not as because the data is limited, it's not trivial to scale up. People are trying to scale up the distillation data, so that's definitely something where we're seeing kind of a lot of compute being spent. And then the interesting part is the inference time. As I was saying, these models are pretty expensive. Just an inference pass for like a single complex takes anywhere between 5 seconds to a couple of minutes because of this very kind of high complexity on a single GPU. And then when we are trying to do, for example, the novel designing a novel protein, we end up, running these models hundreds of thousands to millions of times. Oh. And so, we see this very clear inference time scaling, where, the more you search for the right molecule, the right protein, the better the molecules you find are.
Interesting. So something I wanted to bring up to you was, how do you see the data landscape changing? Something this community is very excited about is the potential to unlock a lot of siloed data and safely aggregate it together during the training process in order to build better models. And it seems like it would probably help these models that you're discussing. I imagine that there's a fair amount of siloed data and proprietary kind of restrictions on these. So what's been your experience so far in getting access to more data? And then also I'm kind of curious, generally, what's your take on, is that a pathway that you think this emerging sort of set of models is going to take or benefit from?
Yeah, so I would say this is a perfect, example of a field with a lot of, silo data. Pharma companies are not famous for being very open about sharing their data, and partially, rightly so, because data is really like, the molecules that these pharma companies develop are really kind of their core IP, and so they're really protective about this data. And so there will be a fair amount of data, especially when one goes to later stage of preclinical data, because early stage there is a lot of base research in academia, and so there is a fair amount of data that's been published. But the more you progress towards clinical trials, the more the data is really siloed inside of these companies. And so we're definitely seeing, companies, even, for example, with us being very open and very excited about, us, coming in and, retraining or fine-tuning their models in a combination of our data and their data. But it's being a lot harder to, get, companies to pull data together. There are some initiative on this front. I would say the biggest challenge is really, I think, a question and, of what are the kind of guarantees that we can give. Even if we are able from a legal standpoint to put together data in a federated way, what kind of guarantees can we give to these companies that the identity of the molecules that they would contribute in the data are really not something that one can extract from the resulting model. And this is something obviously that because of this core IP, these companies are super careful about.
That's a tough problem to manage, but there are different solutions that are available. But fundamentally, if there's concern of like extraction of underlying data, it's very hard to.
The second challenge that we've encountered, and I'm sure it's also present in other spaces, is that a lot of the data that when we come into a pharma company, we have to do is around cleaning the data and figuring out the right way of structuring that data. And so that has been another thing that is, I would say, kind of been somewhat challenging to really have, this model operate on data in a sort of like black box approach. Yep. Now, I think that's actually more of, tractable problem because, as I was saying, it's not necessarily a blocker for us to get into these companies and do the data cleaning, but it's definitely a blocker to ask them to move the data to a shared, resources where they would train across.
Right.
So I think, there is definitely a path if we're able to, kind of convince these companies on, kind of the security and the privacy for these companies to pull in some data.
That's super interesting. I wonder if there's any questions in the audience that people would like to ask. There's a question in the back there. Could someone take a microphone there? We've got a microphone coming momentarily. And while you're waiting, people could think about other questions, perhaps.
Thank you very much. That was really interesting. I'm aware of isomorphic labs as well. I was wondering on the federated nature of models, especially for large models like this. If you have like one company developing it, it's usually easier to audit the whole thing end to end. They can see what changes were made by who, when, etc.
Whereas with a more distributed model, it might be harder to do so. So if you are trying to, regulate the way that these models work in conjunction with data, it would make it harder. What's your understanding and opinion on that?
Yeah, no, I think that's very interesting, and I think maybe that's also part of the solution of to keep some of that privacy is not allow full access also to the resulting models, and being kind of careful at the way that these models is being used at inference time to avoid attacks, and obviously same thing for training time is can we extract. And so I do think that there is definitely a path. I think these companies are okay with trusted third parties like us being somewhat in control of this training processes. And so I think I think the more challenging part from them is kind of knowing whether it's like I don't know, like Lilly versus Novo. It's knowing that Novo wouldn't be able to extract from the model Lilly's data and potentially quote unquote steal some of their molecules.
Any other questions out there? I have another one. You brought up an interesting topic where you're saying in the currently there are even with the frontier model frontier AI companies with their proprietary models, they're completely closed. They're still providing API access, so people can still use these models and build around them and so forth. But you're saying in your area that's not happening. For example, Isomorphic has these models that are completely closed. Do you think that the world is going to move to this first case where even proprietary models of all domains are available from APIs? Or is it a special case whereby we'll see increasingly companies build models more and more and then completely close them from being used in any way?
Yeah, it's interesting. I think I think pharma is a very challenging space because a lot of the value historically has come not to the platforms, but platform companies, but to the value of the assets. And so you see very vertically integrated companies versus in software we have a lot more of horizontal integration.
Right.
And so that has been kind of partially the reason why the software market is not as developed in kind of the life sciences and pharma space, and that's why when Isomorphic was started, I'm sure there was like a very clear, deliberate decision of saying, we don't see necessarily the path of creating a $100 billion company without developing our own assets. And so I think that hopefully will change, and obviously we're making a bet in this direction. But it's interesting. I think there is also some folks I've been hearing recently saying maybe Anthropic will decide to actually not provide API access and build all the software in the world, which is kind of like what Isomorphic is. Their mission is build all the drugs in the world, and is are other fields going to go towards this open kind of space where players have kind of clear specialization, or we're gonna see kind of companies vertically integrate and to try to capture all the value. I'm not sure.
Yeah, it's an interesting question. Any more questions from the audience? No, well then I have one final question. I mean, in your domain, it seems to be moving so fast, and it's really transforming the way that people are building maybe materials, drugs. It seems so fundamental to the way the world works. And so I was just curious what you think we will see. What will the world look like given the adoption of AI and the advancement of these models in as little as 3 years' time? Perhaps you think things are going to progress a little slower, or maybe you think a lot of the predictions are going to come to pass. But I'm just curious from your vantage point, what do you think?
Yeah, no, I think the field is progressing incredibly fast, and I think that there is no signs of that slowing down. Now, obviously, there are big changes happening to the preclinical, the way that we develop new drugs. There's always a lag to those drugs being developed and them actually kind of getting into patients because of regulations and clinical trials. But I do think that we're going to see kind of like a big wave of new drugs coming, and I think there are like a few ways that that's going to develop. Obviously, there is a lot of push towards more consumer drugs. Obviously, kind of with obesity and GLP-1s being kind of a first big examples. With the lowering of these barriers, there is also going to be, I think, more and more rare disease kind of drugs becoming tractable. And then finally, there is also like recently a big push towards personalized medicine. And so can we get, all the way to, having drugs that are, unique, personalized, can I design you a specific drug for your specific, for example, cancer type, kind of basically on the spot by, basically having kind of, this protein design and so on, timeline reduction, so reduced.
Wow, I hope we get there. So thank you, Gabriel, for coming. Let's give him a round of applause, everyone. So our next speaker is our next speaker is Bryce Picard. He is the Chief Operating Officer of the Ontario Brain Institute. It's a real pleasure and honor for us to have him here today. He'll be speaking about some really amazing work they've been doing in the direction of federated learning. We've been collaborating now for quite a few months. There's some exciting things coming, but I'm really happy to hear from an organization that really understands the value of federations and trying to make the world a better place by applying the techniques. So thank you for coming.
Thanks, everybody. I'm really excited to be here today to tell you a little bit about OBI and what we're doing in the area of federated learning, specifically in our goal of setting up an intelligence network for brain health. Thanks. So just a little bit about OBI before we begin. So OBI is a not-for-profit organization out of Canada. So we have a broad mandate to advance brain research, commercialization, and care. And we do that through a variety of mechanisms. We have very traditional mechanisms around patient engagement, knowledge translation and communication, but we also have different areas around commercialization and care. And really core to what we do is around our analytics capabilities and a neuroanalytics platform that we call BrainCode. So BrainCode houses about 30,000 patient data points or patient points for data. And it was started way back when OBI first began. So we fund research across a very broad range of neurological diseases, right from things like concussion all the way through to neurodegenerative disease. And right from the very beginning, OBI was set up to share this data. So it's consented for secondary use, which means we can share it with external partners, including pharma partners, as well as other research collaborators. It's got common data elements, and we have a really neat technology in Canada using homomorphic encryption to link it to our one-payer system. So you can actually get outcome data or hospital data associated with the patients in our research studies. So this has served us really, really well up until now. And I think what we heard from yesterday was, in order to scale and make things bigger, this one node is pretty good, but it's not enough, right? And it doesn't give us access to that data that is hidden in different silos or very, very private and can't share. So this is where we turned to federated learning. So we did so from two main vantage points. The first was to accelerate our data sharing capabilities, and the other was to give our researchers more access to data. So on the data sharing side, we had a really interesting project in depression. So we had a team looking at finding biomarkers to predict the treatment or how you would respond to antidepressants. And this data is a regulated clinical trial, has very distinct endpoints, and it turns out is very interested in sharing to different pharma companies. So how do we share this data quickly without very long agreements? And how do we keep all that data very safe and very private? So to do that, we're going to turn to federated learning. The other side of BrainCode that we want to accelerate through federated learning is around giving our researchers access to more data. So we now have a really interesting study in neurodevelopment disorders. So if you look across autism, ADHD, and obsessive compulsive disease, what you'll find is that the underlying condition or the phenotype that the patients present is often not as clear as having one of those three diagnoses. So how can we advance the research in that area by giving the researchers more data to better diagnose those patients? And we're going to do that through genomic data. And as you know, genomic data is very large, very hard to centralize, and very difficult to share. So we're going to turn to federated learning for that. So all of these present an opportunity for us to go to federated learning. And as part of this process, we actually did a pretty comprehensive landscape search to look at where we wanted to go. Did we want to go with a proprietary provider for federated learning? Did we want to go open source? And we were very fortunate that we have a very, very strong in-house team on the analytics side. And we also had just a great relationship starting with the Flower team. So we ended up going with Flower for a couple main reasons. The first was our dev team really found that it was really easy to stand up and really easy to use. And they were able to get in and test and use the platform quite easily. The second one was around the community or the ecosystem. Right, the open source component of it allowed our team to get in and see what others were doing, see what challenges they were facing, and had that really supportive community. Finally, very specific to Canada, is we already had a couple partners working with Flower, very strong players in the Canadian ecosystem for data and analytics. So it also made that decision a lot easier. So we went with Flower and we stood up what we're calling NeuroFL or Neuro Federated Learning. So with that, then I'll tell you a little bit about how we're doing it. So there's really two key components for how we're thinking about federated learning in the neuro space. The first is scaling brain code, right? Making that data more broader available. So we're using that as sort of our first anchor point, right? How do we use that as a value prop for bringing people into this sharing network? The second component really is around our role as a trusted ecosystem provider. So what we did with federated learning is we took all of the governance and privacy and security components that we already had built into brain code and layered some specific components for federated learning with that. So there's some physical securities. So for example, only there's an outbound connection to the clients, to the server, as well as some governance capabilities. So anytime a modeler uploads a model to NeuroFL, it's reviewed internally before it's deployed into the network to make sure there's no malicious code or any ill intent in that model as well. So the idea there is that OBI becomes this trusted provider in establishing and growing this network. So you don't necessarily have to trust and know everybody in the OBI network, but you trust and know OBI centrally, and we sort of like vouch for that network. And the idea there is that helps to scale, helps us to grow a little bit faster than it would having to establish those one-on-one relationships. So I'll tell you a little bit about the components of NeuroFL. So like I said, we just love working with the Flower team. We were able to set up an alpha version within a couple months over the summer. And then we had a beta version that we're using for our pilot programs that we developed and launched this past December. So these are some user interface screenshots from our modeler. And the idea behind setting up our modeler is we really wanted the modeler interface to be really easy to use, and we wanted it to interact with existing workflows. So in order to do that, we built a user-friendly interface, and we had a REST API. So the idea here is we didn't want our modelers to have to use a complicated command line interface to go in and run their jobs. So they upload 2 files and they're in and running the system. The other things that we're doing, we've got some node data dictionaries and some file structure previews. And we're also starting to experiment with LLMs so that our modelers can go in and compare the different data dictionaries for the different nodes that they're working with, and just making that job a little bit more flexible and easier. The other thing that we're working on is data attribution. So to be quite honest, we're not really sure where data attribution is going to sit within our platform, whether it's going to be a modeler feature, whether it's going to be a central admin panel, or whether it's going to show up in the client node. But our hypothesis is that people want to generate data. They want to contribute data to a data sharing network. And we know that more data makes for better models. But that's not always enough incentive to generate large networks of data. So we believe that data attribution will be that next little layer of incentive for people to contribute their data into our network. So these are some very early screens of our test environments where we're looking at 4 or 5 different methods to develop data attribution. And the idea is if you know how much your data is valued within the network, if you know how your data contributed to the development of a model, you're more likely to contribute and be a part of that network. And then you can realize some of that value back for your networks. On the modeler side, if you know how that data will contribute to your model, how it increases the model performance, you're more likely to contribute to being a part of that network. It's a little less friction in coming together. So all of this will help us grow our network, help us grow our model network or our model community, as well as our client community as well. So this is our client UI. So again, we took some core Flower features and then layered on a few specifics for NeuroFL. Our goal here, really, because we're deploying in hospitals, is to decrease that friction of deployment in the hospitals. So really to make that InfoSec review nice and easy and clean. So in order to do that, we added things like there's only an outbound connection from the node to the server, which helps that IT review. The other thing we did is we developed what we think is a user-friendly user interface, but we did keep that command line interface option within there so that the client nodes can go in and make it super easy and flexible to add their data and add their data dictionaries. We have live logs on the running jobs so the clients can get in and see what models are being trained on their data and where they are in the process. So all of this brings us to the future direction. So what we just showed you there was the beta version that we're using to run our pilot programs, and we'll talk a little bit about the pilot programs in a second. But we're also working on some new features. So we're working on data pre-processing. We're looking at using synthetic data as a preview tool within the network. So before investing into establishing a node or getting in as a client, you can come in, play around with the synthetic data, see if there's an impact before actually getting into the network. We're, of course, working on cohort building. So pharma, as a general rule, is very interested in some of their trial data. So can they get in and build cohorts across the network and see the impact of that data to their trials? We'd really love to have interoperability with other frameworks. And we're starting to really build and establish this data ecosystem, which I'll talk about in a second. So our first pilot projects, so we've got 3 pilot projects that are currently running in various forms right now within NeuroFL. So the first 2 at Toronto Metropolitan and with the Neuro and CAMH are really looking at how can we use federated learning to test the real world applicability of the models that are developed. So what do the models, are they generalizable across various device or scanner manufacturers? What does it look like when your models are being used in real world data? And then at Hull and Bloorview, we're looking at precision care for neurodevelopmental disorders. So again, this was one of the programs that we really liked federated learning for. They're trying now to get better diagnosis through integrating genomic data into the analysis of the conditions. So they'll be able to use brain scans to look at brain morphology. They'll be able to use phenotype data. And now with federated learning, they'll be able to use genotype data and better diagnose those conditions. So these are their 3 pilot projects. So hopefully next year, we'll be able to come back and tell you some of the outcomes of these pilot programs. But I would like to talk a little bit about what we're calling this data intelligence network for brain health. So right now, currently, we have, I think it looks like 7 clients in various forms of being stood up for our neuro network. So you can see at the top left, brain code is that first node. And we've got the pilot programs here as well. And there's also various other programs that are just starting to bud out. We're Ontario focused, and we're starting to move out of Ontario into Montreal is exciting. And we've got Child and Mind Institute, which is in New York, which is very exciting for us. But what we'd love to do is bring on as many nodes as we can into this network, with the idea that we have with the governance and the data sharing principles, as well as the privacy and security controls. Our vision is that we can create this data intelligence network where if you have data in the neuro space that you want to contribute, you can set up a client and contribute your data. And if you're a modeler in the space and you're looking to train models or validate models and you're looking for very high value neuro data, you can come to NeuroFL and access that data as well. So if you're in the space, we'd love to talk to you about how you can contribute and be a part of NeuroFL. So here's a couple different ways of getting a hold of us. And again, would love to hear from anybody who's interested in working in the space, share ideas or work around the framework as well. So thanks very much.
Thank you so much. We have time for a few questions from the audience, if there are any. There's one just here. Mike's coming.
Thank you very much. for the presentation. I have a question. You mentioned that one of your future direction of research is data pre-processing. I think that's not just relevant for this specific use case, but for kind of any use case where you have multiple players that may provide data. So how do you intend to do this and like potentially have an automated method for pre-processing that's also generalizable?
Yeah, I mean, it's a great question. So I don't know the specifics of it exactly yet, but we're looking at developing the workflow so that you can do the pre-processing that fits right into that modeler's workflow. I'd have to follow up with you on exactly how we're doing it because that's not my area, but I can do that.
Great. Anything else out there? Any further questions? No? Oh, yes, one down here. I'll pass the mic on.
This is very similar to the last question. One of your directions was using synthetic data for a preview. Could you say a little bit more about that, if that's your area?
Yeah, for sure. So the idea is we'll generate synthetic data from the data that we have in BrainCode or the specific nodes. And because you can share synthetic data a lot easier, the idea is that you can get in and essentially train your model on the synthetic data or look or maybe do some exploratory data analysis on the synthetic data or pre-processing, and then get in and just see whether or not it's worth your time to invest in becoming part of the network or in contributing to that relationship.
Well, thank you, Bryce. It's an incredible talk, incredible mission. Thank you again. So our next speaker is Nicholas Kontz of DocPort. DocPort was featured in Daniel's keynote yesterday. They are an incredibly progressive and aggressive AI company in Germany that is trying to safely access and leverage a lot of data that's stuck in GP practices across Germany. We've been working with them now for maybe about a year or so. And so they've got incredible progress to report today. It's one of the best examples, I think, of really unlocking data in a privacy-preserving manner that really can help the community at large. So over to them.
Thank you, Nick. Can we mirror? Oh, thank you. 250,000 patients, electronic health records containing valuable longitudinal health data, information about the progression of disease, but also about the provision of care. However, inaccessible to any kind of centralized analysis. And in the next 10 minutes, I want to share how we leveraged the Flower Supergrid and Flower technology to perform or to conduct the first federated study on chronic kidney disease in our primary care network. My name is Nicholas Kontz. I'm a medical doctor by training, and we were doing this study in cooperation with AstraZeneca. Let me quickly tell you just a couple of words about DocPort. We are a network, or we're serving a network of 60 practices, mostly GP practices in North Rhine-Westphalia, Germany, serving more than 200,000 patients per year. And within our databases, there's information of more than 1 million patients, patient records, historical data. However, inaccessible, as I said, and I was trying to remind you of the keynote that we were seeing yesterday. It's this siloed data that we're dealing with, so a very representative illustration of the difficulties and the challenges. However, there's many things that we can do to provide support at the point of care, and this has always been our mission at DocPort. We have local dashboards and other technology in place to not only provide support for the doctors running their practice efficiently, but also to add value to the provision of care. Key business figures, services, claims, invoices, but also identifying risk cohorts that we can address by prevention programs, chronic disease programs, and moreover, care quality indicators that we use to assess in how far patients with diseases like diabetes, hypertension, or cardiovascular disease are treated accordingly to guidelines and the best available knowledge. What we know is that, especially in chronic kidney disease, being one of the main complications of diabetes, hypertension, or cardiovascular disease, there is a large care gap. There was this large landmark study in 2024 outlining that it's 86% of patients that have laboratory confirmed chronic kidney disease are not receiving the correct diagnosis, and then same applies to treatment and further diagnostics. We were approached by AstraZeneca with the question whether we could leverage our network and our databases to perform a follow-up study that is regional and that uses Federation as the key technology to access this data, compliant with legal regulations and law in force. We were very lucky to be part of the first cohort of research groups or companies that was able to access the Flower Supergrid. That helped us to really orchestrate the on and offboarding of single sites. However, we needed to navigate very carefully because, as you know, GDPR, professional law, medical device regulation, this would all be hindering us from just looking into the raw data. So there needed to be technical features in place to guardrail us and to help us to comply with the regulation. We were partnering with a specialized law firm to really make sure that we are seeing and meeting all those goals and guardrails that we need to have in place. Most importantly, at each step of the data processing, having a legal basis for what we do, having secure data access and query control, having a proper anonymization pipeline in place that prevents any identifiable data from being shared outside of the local clients, and also having a transmission integrity auditability that would help us to document everything correctly. There is more technical aspects, and I'm happy to share more details with you later on. If you want to approach me, please feel free. I'm happy to share all details of what we did. I want to point out the orchestration layer, permissioning, traceability, auditability. This was really where FlowerGrid helped us do our job. Onboarding practices as supernodes was as easy as running the federated analyses on the supergrid. Luckily, we were not using too many credits, but that might change at a later point of time when we're trying to really train federated models. I'm going to talk about this in a bit. So let me quickly point out the centralized versus federated approach. What are the results? Most importantly, we were seeing that within our cohort of patients meeting complex inclusion and exclusion criteria that were drawn from the study analysis plan of this initial 2024 landmark study, we could show that we have a representative sample, we have the federated architecture, and we have real-time insights. So again, this was helping us to show that we can add real-time value at the point of care for practitioners in their practices, in their daily business. And that is something that is of real importance for really having an application to the struggle in everyday practice that there is. Again, I'm happy to share more insights at a later stage. Importantly, we replicated the study analysis plan on a one-on-one basis, obviously rebuilding it in a federated way so that we were able to collect data from the individual sites. And as you can see, baseline characteristics such as age, or age characteristics, blood pressure, gender distribution, but also comorbidities, was almost identical between the very large landmark study covering approximately 400,000 patients and our risk cohort that we identified covering 70,000 patients that were at high risk of developing chronic kidney disease, suffering from chronic diagnoses like hypertension, cardiovascular disease, and diabetes. But moreover, and that is the important part, I think, is that we were able to provide benchmarking. So another addition to the quality measurement in the practices to the doctors that we serve, and that we were able to combine this with the federated analytic, with the research, with the collaborative research to really have impact on the provision of care in the practices. This is just a snapshot of the real-time visualization of quality of kidney disease or care for chronic kidney disease. We see risk cohorts that the practices can access using filters, time filters, precondition filters, looking into just age distribution, gender distribution, but also about this kind of 4 key quality indicators, whether patients at risk of chronic kidney disease receive adequate treatment, adequate diagnostics, and are coded in an adequate way. I think what really could differentiate this approach from the more research isolated research approaches is that we have a full circle impact. We have the real-time dashboards supporting doctors in analyzing where are their care gaps, where are areas of improvement. We have continuous benchmarking to really help them to locate themselves. Are they over or underperforming in comparison to their peers? We have anonymization by aggregation, federated analytics, so we can run studies, we can collaborate with research institutions, we can collaborate with pharmaceutical companies, and all of that being fully compliant with the legal regulations that we are having in Germany. Interactive feedback, feeding this and making it a full circle impact. What's next? We have accomplished to use the Flower Grid for orchestrating, making it traceable and compliant with legal regulations. We saw that we have a representative sample, so whatever kind of disease we're looking at, whatever kind of progression of disease we want to understand, or the provision of care that we want to look into, we have a solid database to look at. We definitely want to make sure that we have this privacy-preserving features in place to, for example, suppress cell sizes or add secure aggregation to the pipeline in a more standardized, modularized way. I think we have seen great projects showing that this can be done, also building on the Flower infrastructure, and obviously the topic of heterogeneity of data, making this more interoperable, is something that applies to all environments of medical practice, I guess. And speaking of Outlook, we're very happy to announce that we were able to secure a research grant covering roughly €1 million for the next 3 years by the European Union and the country of North Rhine-Westphalia. Our project is called FLIP-IT, Federated Learning and a Practice Network Infrastructure for the Decentralized Training of Risk Models. And this underlines our endeavor to now really progress to the next step, training the first risk prediction model for chronic kidney disease across the network of practices that we're serving. And with this, I'm open to questions, and thank you for your interest.
Do we have questions? Okay, one in the back. Let's get this underway.
Thanks for the nice talk. I just wanted to hear a bit more about your experience on connecting regulatory requirements with technical specifications. Like, for example, you mentioned some of these privacy-preserving techniques. Like, if there's a legal requirement saying that you can either share something or not share something, or maybe share something in a certain way. So how would you usually translate that into something that Flower supports from a technical standpoint?
In terms of, thanks for the question. In terms of federated analytics that we're dealing with, I think there were some manual techniques that we had to apply, like really making sure that we cannot address cell sizes, so kind of specified groups of patients that are under a certain threshold, like 3 or 5 patients or 10 patients, whatever level of security you want to have. I think that might be something that could also be baked into Flower, being another module. Importantly, accessing data is maybe something that could be addressed. We are now building a FHIR representation of the most important resources, making it more interoperable for the whole kind of research community. And I guess when building on international standards, that is also something that would make it easier for Flower to really to support this this collaboration.
Hi, amazing talk, by the way. Really interested from like an insurance standpoint as well. You guys mentioned about kind of partnering with pharmaceutical companies as well. I was wondering if you guys would consider expanding into kind of more insurance or having a kind of a life cycle of that data being reused and over. What are your thoughts, and where do you guys see your your North Star goal going to?
100%. Thank you for the question. There are so many opportunities in collaborating, accessing the data, drawing meaningful information from it. Our first principle is that it always has to support doctors at the provision of care. So whatever we do, we will always have this kind of dashboards, benchmarking aspect, making insights that we want to see on a regional level, also accessible for the practices at the point of care. And that's also a very important aspect of our legal framework, as there is the purpose of doctors to improve their care through technology. They are asked to use the data to do so. And by doing that, we are generating aggregated and thereby anonymized sets of data that can be then transferred and be accessed by other research institutions. And partnering with insurances, with medical tech companies, or with pharmaceutical companies is definitely something we want to promote even more in the future. Thank you.
One other question over here. Thanks for the great talk, and I really liked. As you know, we really love working with you on this project. I really liked the list with all the green check boxes, where you showed that a federated approach cannot be is not just closely matching a centralized approach in terms of performance, but you can really build a system that's better in many dimensions if you use the federated approach. You mentioned you worked with a law firm to check all the boxes and make sure that everything you do is compliant. Do you have any general recommendations to people in the room on what is something you should think of early in a project?
Yeah, start thinking early about the legal implications of what you're doing, because for us it really meant kind of flipping the whole thing around, not starting from the researcher's perspective, but starting from who is allowed and what kind of way allowed to access and work with the data. And then having a layered approach towards what kind of anonymization are we really seeing? How can we ensure that this is that we have a disclosure control in place? We were hearing about this earlier. So I can only recommend starting to think about the legal implications and the compliance from the first day on, because otherwise it might in the end kind of kill a fantastic technical approach that you have engineered. Thank you.
Thank you for the great talk. Thank you. So our next speaker is Scott Russell. He is the Chief Product Officer at Iridia. This is a company that specializes in building secure enclaves. So hardware secured repositories of data and computation that institutions can trust to partner with when they want to do some type of analysis on sensitive data. We've been working with them for quite a while now, trying to look at means by which we can take a single repository such as a TRE or a similar type of technology and start to network them together to sort of amplify what you can do with that data. Scott's going to tell us all about the potential of individual TREs and network TREs and how they've been working with Flower. So over to Scott. It's a pleasure.
Thanks, Nick. So yeah, thanks for that introduction. So I don't have to tell you who I am. But firstly, also thanks to Flower for having me here today, and particularly for the T-shirt, because it meant I didn't have to iron the one that I brought with me to wear today, thankfully. And if you speak to my wife, she knows how bad I am at ironing. However, so I'm going to spend the next 10 minutes just talking about what we do at Iridia, what trusted research environments are, and how when you combine those with the power of Flower, how you can really make federated learning super easy to implement. So I was asked this question about 4 times yesterday, so I thought I'd better address it. What does Iridia actually mean? It's actually a Swahili word. Our CEO, David Sibbald, spent a lot of his kind of early adulthood in touring around Africa. And it's a Swahili word for to inform. And it's quite appropriate for what we do as an organisation. As Nick said, we are a commercial TRE provider. TRE, you've heard that acronym a couple of times over the course of the last few days. You've also heard another couple of acronyms which describe the same thing. So there's the TRE, the Trusted Research Environment. There's the SDE, the Secure Data Environment. In Europe, where EHDS is coming into play, you have the Secure Processing Environment. We've heard Secure Research Environment. There's all kinds of acronyms basically describing roughly the same thing. And at Iridia, we've made it more complicated because we've got our own acronym, the DRE, the Digital Research Environment. Now, we've been in this business for about 14 years now, so we'll lay claim to that acronym, and we're going to continue to use that. But what is a trusted research environment? It's a secure collaborative space, typically in the cloud, that allows data owners, hospitals, research institutions, large consortia, perhaps focusing on particular disease types or rare diseases, allows them to share the data they have for secondary research in a secure environment and in the knowledge that their data is safe and cannot leave that environment. And for the researcher, it's that cloud space where they can collaborate with their team. Some TREs are perhaps a pre-provisioned virtual machine with access perhaps only for one person at a time. Our environment, our TRE, allows for large project team collaboration. One example where we worked with the Alzheimer's Disease Data Initiative, they created a novel data set called GNPC with 100 individual users within the same workspace, all collaborating, bringing all their data together into one space to create this unique data set. As you can see on the right-hand side, we have quite a global footprint. Each deployment of the DRE is called a hub, so we have over 20 of those. We have users, researchers across 110 countries, and across the data sets that are available on our platform, over 5,500. And active at this point in time, we have over 1,000 individual project workspaces in use. At the bottom here, you have some of our customers and partners. This isn't the exhaustive list, but it's the ones which are relevant to our conversation today, hospitals, and particularly those that are interested in federated analytics and federated learning. So a little bit on our experience in this area. We've got a number of federations currently on the go at various different levels and stages of development. And the first one here that I talk about is Aurum. Now, Aurum build an analytics platform for doing analysis on perfusion devices. Now, if you've seen a perfusion machine, it's an absolutely terrifying looking thing. It's full of tubes and dials and knobs and gauges, but it's basically what keeps you alive during heart and lung operations, operated by extraordinarily skilled individuals. Obviously generating a lot of data as it does so, and quite often that data is treated almost like exhaust. And however, there's rich seams of analysis that can be mined from that data, and Aurum build a platform to do that. And where that becomes even more valuable is when you can compare and you can benchmark against other uses of that machine in other institutions, and build build a machine learning model to really help with precision perfusion. So we're working with Orem and setting up that network right now. And hopefully this time next year, I should be able to talk a little bit more about that and the results. FEMS is a very interesting one. It's European-wide. It includes Great Ormond Street Hospital here in London, who are one of our large customers, HUS in Finland, Erasmus in Rotterdam, SGD in Barcelona. And it's all about bringing together complex pediatric data and benchmarking each patient journey within those hospitals. So we've assisted in that as a technical partner in FEMS to build that federated network, allow access to the benchmarking dashboards, allow each hospital to compare patient journeys and learn from each other. But then beyond that, we are in the process of putting together the federated learning network as well. And that's really all about building predictive models, in this case here for the emergence of sepsis and hemophilia in pediatric patients. And then finally, this is one which we're just kicking off, is LCC and DataSHIELD. LCC are based in Perth, Australia, the Liver Cancer Collaborative, and in conjunction with the Henry Perkins Institute, they're a biobank who also have genomic data, clinical data, and they've curated that data and made available through our platform for research and analysis. But I want to combine that with the kind of work that's been done out of Edinburgh with DataSHIELD on non-alcoholic liver disease, and to enrich the data that they can make available to the researchers, and with the anticipation to also use federated learning to build machine learning models that they can all benefit from. And crucially, particularly in Orem and FEMS, these are models which we want to run continually, constant refresh, constant update, and providing continuing and updated value to the researchers and the institutions. So on the challenges on federations and federated learning, so these challenges are much more than technical. Now, obviously, as a software platform provider, we focus on the technical side and implementation of that, but the realities of putting together an effective federated network are complex. And particularly when you're looking across geographies, across Europe, where we're looking at, in FEMS, we have the UK, we have the EU, and we have Nordics. There's lots of complexities on what hospitals will and won't allow with regards to connectivity to the network, what can come into the hospital or what can't be. Do they allow inbound connections, for example? Data harmonization, we have our friends from the Hive here who are very experienced in this area. If we consider FEMS, this is very messy data initially coming from EHR systems, different EHR systems across each different hospital, different ways of recording that data, different ontologies perhaps being used, and that all needs to be harmonized. And we heard a little bit about that yesterday with John from Red Hat was talking about the importance of harmonizing those ontologies, harmonizing the concepts and how those are used. The data is crucial. They say garbage in, garbage out. Your model is only as good and your analytics are only as good as the data that you have, and harmonization is absolutely crucial. And regional governance and legislation. Something that we're running into in some of the networks we're involved in, when you're training these models, how can you prove to the regulators that you can't reverse engineer that model to extract any sensitive information? And that's a very difficult thing to do, to prove that you can't do that. And that's one of the things that we are kind of wrestling with right now. But also on the technical side, we have, where does the training data reside? Is it safe? That's where we come in as a trusted research environment. And in the learning network, where does the aggregator live? And that's where Flower comes in with the supergrid as well. So addressing those technical challenges, it's quite like this slide. It looks like they've got the sun over this data of this kind of sea of data, sorry. I really do think that Flower share our kind of similar vision on the ease of use and rapid time to value. You've heard it and you've seen it for yourself, so I don't have to really go into too much detail, but it's super easy to implement Flower. It's super easy to get it running, and it was really, really straightforward for us to integrate that with our platform. And I'll talk a little bit about that in a second. But also, security is obviously primary focus for us, and Flower with their approach in Supergrid also share that same understanding and ensuring that they are ISO 27001 compliant and all the data security and information governance that goes with that, and that's a real complement to our environment as well. So by combining Flower and the Iridia DRE, it was a really seamless integration for implementing federated learning networks. Now, just a little bit on what we've done, and I'm happy to go into this in more detail. We've actually got some blog content on this, which goes into a lot of detail. But if you consider every deployed instance of the Iridia DRE is we call a hub. And that hub can be divided into organizations. And each organization is completely distinct from each other, separate users. Workspaces are not able to contact each other, effectively completely distinct environments, sharing some underlying infrastructure and capability. Like you can see here, we have our workspaces, and that's our collaborative environment where the research tools reside. Users can bring their own tools into that environment. Admins can provide a large suite set of tools as well. And connectivity to that workspace can be restricted on an IP address basis. So we have the security provided by the organization, and we can also extend that by ensuring that you can only access that workspace via the VPN. And each organization has its own unique supernode, which can interact with the Supergrid as you've seen itself. So I'm quite happy to go into a lot more detail about how we've implemented this, but I'm very conscious that I also only have about 45 seconds left. So I'm just going to go into the final slide here. There's a very quick demo of this in action. It's real time, so it shows you just how fast it is to actually get this running in our environment. So this is our interface. We have two organizations here, each with their own workspace. This user here, Liam, has access to both workspaces, which is unusual, but it would slow the video down if we had to log out and log in again. So these are both two distinct organizations. And you see we're just going to click into the workspace very quickly, and we're going to go into files. Now, what I'm going to show here is us bringing some data into the platform. I'm just showing you this comes in what we call through an inbound airlock. Liam is an administrator here, so he can approve that, but normally a user would have to get permission to do so. That data's come in. Now, this is a very simple data set here, just a very straightforward CSV. However, as you can imagine, OMOP data sets can be very complex with lots and lots of data dictionaries. But in this case here, we're going to load this one CSV into the database, which the supernode and the model that runs inside this environment can interact with. So now we have that database in the system. There we go. Click, 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 click. Come on, click. There we go. And now it's available. Then we go to the preview of the data. And now we've done that. We go to our terminal. So this isn't a virtual machine. It's crucially that this is all running inside the DRE, and this is a command line interface that we have inside the workspace. And we are going to the Supergrid to see that this node is now active and available to the Federation. And then Liam is now going to go back and log into the second organization workspace. And very quickly, kick that off. That's a node running, and he's going to now do a Flower run at this point here. You can see that node is now active. A quick Flower run. And then from there, we'll be able to go back to the Supergrid and see that that has run successfully to completion. And that's in real time. We haven't sped that up. That's how easy it is using Iridia DRE to interact with a federated learning network and make that available to your users and researchers. So, I'm conscious I've gone a little bit over time, really sorry. But hopefully that was informative and useful. Please reach out to me. My details are here. Unfortunately, I didn't put a QR code there, so apologies, but feel free to get in touch should you have any other questions or anything you want to talk to me about. So thanks very much for your time.
Thank you, Scott. I will take just one question. The gentleman there with his hand up.
Thank you, Scott. I don't know if you can hear me all right, but I had a question about your data harmonization and how you approach that with the multiple organizations you're working with, and I was just kind of curious of your insight into that.
Yeah, no, that is a really good question. Data harmonization, as you know, is extraordinarily complex. In FEMS, it's a really good example. We've actually been working with the Hive, who specialise in that area. Now, ourselves as a TRE provider, we don't do the harmonization itself. However, we have established ETL pipelines which will take those rules and run those once they're in place in the data ingest process. And the individual organizations or the nodes in the hospitals have been working together and with the Hive, in this case, to work on that common OMOP data model. And once those are in place, we can help put those rules in place as part of the kind of ETL ingress process. Does that answer your question?
Yeah, just a little follow-up on that. Then is OMOP your standard in order to be in your DRE system?
No, not at all. I mean, we are completely agnostic. And in fact, we work in multimodal data. But we are seeing increased use of OMOP, particularly around Europe, for these kind of federated networks and analysis.
Last question, I promise.
I'm only one.
What's the typical timeline? Like depending on, I guess it depends on the client or the data set and how big it is. But like, what's that duration of like how long it takes for someone to organize and synthesize and kind of harmonize that data?
Yeah. So the actual technical piece, and once all that is worked out, is actually quite straightforward and quick. But the time taken, particularly across these hospitals with our various different ways of doing things, let's say example, FEMS is now in its third year, right? And when we were at the last kind of meeting, they were finalising on the concepts that they were going to include in the data, and which operations each one did and which ones they didn't. And then so that they were still going through that process.
Okay, wow. Okay. Makes sense. Thanks.
Thank you, Scott.
Yes, thanks.
So we're going to go to a break. We're going to come back here at 2:45 local time. That's 14 minutes from now. So enjoy your coffee and we'll come back with another fireside chat. So join us then. Great. Thank you. Thank you so much.
Hey everyone, welcome back to the break. We just had an excellent session hearing all about the healthcare use cases and how users are using Supergrid to power some of their deployments in trusted research environments and also across actual GP practices in Germany. In this short break that we have, since we're going to resume at 2:45 p.m. local time, we have our very own Pan from Flower Labs, and I'll invite Pan to just step into the view. We're going to have a short conversation. Come on in, Pan, and we'll just have a chat. I think there'll be some very nice highlights from the Flower framework that'll be pretty cool to share with you. So firstly, how's it going?
All good, thanks.
Yeah.
The framework side, we did quite a few releases in the recent months.
Nice. So for those of you who actually don't know you, Pan, we've worked together for 2 years now. Do you want to quickly introduce yourself?
Yeah, sure. Hi everyone, I'm Pan. I'm the lead research engineer in the Flower Labs, and my main job is just maintaining the Flower framework and also making new releases. And yeah, and thanks for interviewing me.
No worries. Look, super casual. I think you don't. The people out there don't really, get to see and speak to a lot of people here in Flower Lab. So it's nice to put a face to the name. And we've worked a lot on a lot of releases in the past couple of months, not just because of the Flower AI Summit, but in general, we want to improve the Flower framework. What were the couple of key highlights of the recent releases that you want to share?
Yeah, there's actually a few quite key highlights. Actually, that also suggests a change of paradigm in like what's the current focus of Flower framework. Because I recall last year we rolled out quite a few user-facing changes like a message API and stuff. And we don't want to really burden our users again by introducing them to new APIs. So the entire team has refocused on how to make the Flower as a system, as an infrastructure, to be more stable, to be more reliable and usable, and also to minimize or even eliminate any security issues related to like the security of communication, etc. And also the usability, general usability to make the life of data science or admins much easier, because they don't have to know in very detailed like they don't have to know every single piece of code to monitor a run and also to intercept what's happening.
Yeah, absolutely.
And the first thing is actually a big improvement is that we introduced the Flower config. It might sound a bit abstract, but what we actually do under the hood is basically before we rely on reading before if you wanted to specify what kind of simulation you want, what kind of super link you want to connect to. You have to write the configuration down in the PyProject.toml. I'm speaking, that shouldn't be the right way, because the TOML is only for the project, but all those settings, for example, the superlink, like what's the IP address of the superlink, what's the certificate are going to use to connect to that superlink, should not be considered as part of the project, because obviously if you deploy a super link, you don't really want to just use for a minute or so. You want it to be long running.
Exactly.
And experiment with different ideas, and that's also the reason driven us to move all the connection related sibling connection configurations to a centralized place and put them under the Flower home directory. So we now have already moved that thing out into a standalone, centralized configuration, so that when you run any command like FLWR run, FLWR list, or FLWR log, or those very useful commands, you don't have to point to a specific folder, because because Flower will automatically locate the configurations you set in the Flower config, the centralized file. And that's the main benefit. And also we have a clean separation now. What's inside the PyProject.toml, that belongs to the project.
Correct.
And what's the configuration about the infra and about superlink, it should stay in the Flower config.
I think we want to emphasize that it's one of the I think a big quality of life improvements in terms of running Flower apps in general. So we also want to say that we are keeping our API surface as consistent as possible to minimize and eliminate any changes in the future. So all the changes that you have seen in recent releases really improves the overall usability of Flower, making it very repeatable. So one concrete example I can give is if you have 5 different Flower apps, before the introduction of Flower config, you would have the same superlink connection repeated across these 5 apps.
Correct.
But with the Flower config, since that same connection is now stored in a unified location, right, in the Flower home directory, then you can run from anywhere and always use that same connection.
Exactly. That's a very nice example. Thanks, Chonghen.
Absolutely.
And this the also, as you say, it's a big quality improvement. Especially makes the life much easier than just doing copy pasting. Especially you use Flower for different apps.
Yes.
And apart from that, also we have a very good thing for all the researchers who mainly doing local simulations with Flower. I know I really like to have feedbacks from the researchers because they're one of the biggest community member using open source Flower, and they support us a lot. And previously, when you run simulation, it's quite obvious, like also very quite straightforward. Just do FAW run and then run the simulation, and once it ends. There seems to be no issue with that approach, but actually Flower introduced quite a few monitoring tools and making the deployment much better. And we also want to have those kind of mechanisms and functionalities available to our open source users who are just doing local simulations.
That's true.
So we actually introduced a new idea, which is local superlink. So what happens is that when you do FAW run, before we directly start a process running the simulation in the foreground. So you can see what happens. But right now we will delegate like the starting of the simulation process to automatically started local superlink that helps you manage those simulation runs.
Yeah, indeed. So I think the nice and right way to think about it is that there is a local infrastructure that is handled by Flower for you.
Exactly.
You run a simulation runtime in a local setting.
Exactly, yeah. And you can also, after running the simulation, like even 10 days later, you can always use like a FAW list to check what kind of runs you run previously, like check how long it takes, if it's successful, and also inspect it log whenever you want to.
Yeah, that's nice.
Yeah. And basically, Flower helps you manage the history of the runs.
Yeah.
And everything will store locally because it's local superlink, storing using a local database.
That's very nice. Yeah. So just to wrap things up, we have lots of great ideas, something that we've been also incubating for a long time as well.
Yeah.
What for you, in a very short, 30 seconds, can you give an idea of what you're excited about in the next 3 to 6 months for the Flower framework?
For Flower framework, if we look ahead, actually, I'm very happy that we now have the dependency management. There's a big improvement for the deployment, and for the next quarter or next 2 quarters, I'm also looking forward to more reliable features and better security guarantees for our infrastructure, so that when you deploy Superlink, you will have better experience. And also, if you use SuperGrid, we also want to offer a better user experience, especially with our SuperGrid. Right now, it's become a platform and makes collaborations easier. And also, we want to continue working on that front and also make our framework more reliable and also allow to scale horizontally. And
yeah, it makes sense. I think Flower framework is our primitive to allow collaborative AI in general, and SuperGrid is how we position as the enterprise-ready way to run it.
Yeah, and I also wanted to mention that even if we focus on the SuperGrid side, but I can ensure that like 99% of the features will definitely be available in the open source, and the tiny 1% is purely and exclusively for some edge cases for enterprise uses. So we're not shifting our focus to some internal hidden repository, or we are still focusing fully on our open source. And we are open source friendly framework.
Yeah, excellent. Well, thanks a lot, Pan. Thanks for jumping in and giving us your.
Thank you for the chance.
Yeah, I'll catch up with you shortly.
Sure, no problem. Yeah.
Right. See you.
Take care.
See you. All right. So there we have Pan, the lead research engineer from Flower Labs, giving you his insights about the Flower framework as well. And it's good to know, and also like to share with you the progress that we have in Flower framework. So we have our next guest. We have a couple of minutes left for the next session, but we are our next guest, very familiar face. I've interacted with him in the past. So welcome Shiqiang over onto the live stream. You can step on the pink sign up there.
Oh, okay.
Excellent. Hey, Shichang, how's it going?
Hey, good. How are you? Nice to meet you.
Yeah. I'm doing fantastic as well. I know we have met in the past. I think maybe we have briefly interacted as well before. Maybe a little bit closer, just for just for audio. For those of you who don't know you and what you do you want to just share a little bit with the live audience?
Yeah, sure. I'm Shichang. I'm currently a professor at the University of Exeter. I actually joined the university only half a year ago after working 10 years at IBM Research in the US. So my work over the last couple of years have been mostly on federated learning and some large language model stuff as well, like deciding which model to choose for the best performance and energy or cost trade-off. And also, most recently, we've been looking into agentic AI as well, including collaborative and federated agents, and also obviously in combination with large language models. And just trying to see how to maximize the performance while keeping the cost in check.
Yeah, absolutely. That's fantastic. I hear you asking a question in one of the talks about the edge computing as well. Could you share like one of the more the recent insights that you have found in the recent work?
Well, I would say for agents, I think agents these days obviously is a very hot topic. But I think especially in the case of distributed AI, I think there's still quite some challenges and some technical hurdles that we would have to overcome, especially if you think about the different components of agents, right? Like you have tool calls and you may need to access some parts of the local data and maybe call some cloud service as well. So if you think about it, it's actually quite complicated. So sometimes you need to connect to the cloud. Sometimes you may need to connect to some other agents that's running in some other place. And the agents would have to decide themselves what to call and who to connect to. It's a little bit like human interactions in the end, right? But I guess the other thing is like the models these days, they are all trained using some instruction tuning data sets, which is usually user assistant pairs with some tool calls maybe. But how do the models actually understand multi-agent interactions or even interacting with multiple humans? I think that could be another challenge there as well.
It makes a lot of sense. I never thought about this topic so deeply before. Just in the last minute or so before we wrap up. Okay, we are about to start probably in about less than a minute from now. Do you want to share very quickly in 10 seconds what is exciting for you in the next 3 to 6 months?
I would say AI agents in decentralized systems.
AI agents.
I think that's quite exciting.
Excellent. All right. Well, great to have you on the live stream. Thanks for joining me.
Thank you very much.
I'll speak with you upstairs in a couple of minutes.
All right. Thank you.
Yeah, see you in a bit.
Yeah, see you.
Okay. All right. Yeah, thanks. Okay, so here we have two very nice two guests on the live stream. We heard a little bit from Pan and also from Shichang about agentic collaborative AI. I think it's pretty neat as well. It's all very relevant. In the past 3 to 6 months, we have seen a lot of interest to use in that space, and I think we are positioned quite well in terms of developing the framework and also all the toolings that you need to try and work in this space. So we'll be very keen and excited to learn as well from the community in general. What drives you? What drives the use cases that you have? That would give us also a lot of insight on what areas would need development as well as we continue to refine the framework as well as Supergrid. Shortly, we'll be starting our fireside chat. I've been told that we have about less than a minute now. We're about to start very soon, so do stay tuned. And then we'll go on a live stream. We'll switch over to the main stage very shortly. So in the meantime, once again, if you have any questions, feel free to drop it in public Slack. We have Flower AI Summit 2026 Slack channel. You can also drop the questions in YouTube, and there are a couple that we will get to soon as well. Okay. All right. Thank you very much. I will see you guys very soon, and take care.
We're going to start fireside chat now. If everybody can sit down and take the networking outside. Hey guys, can you please? Yeah, no worries. Break is over. Can you tell Nick to get people under control? Yeah? No worries. Thanks, everyone. Okay, we'll get started. So now we have a talk with someone that has been working on federated learning for a while. His name is Eric Bernert. He's working at Roche, and he will be joining us for a fireside chat, a virtual fireside chat. So it's a bit of a fake one. But we'll make it engaging. I think this is going to be very interesting. There's a lot of people in the room here that has been working on federated data networks, that invested a lot of time and effort into building them. And Eric has been a pioneer with Roche building this. Hi, Eric. Can you see me?
I can see you and I can hear you. Hello, everybody.
Okay, excellent. So we don't have a fire, unfortunately, but it still feels cozy in this living room that we have here in King's house. So I want to first start by allowing you to introduce yourself and tell us a little bit about what you've been doing with the federated open science at Roche. I think you have a great experience, and I think a lot of people in the room would benefit also from hearing what you've been doing at Roche.
Sure, thanks for the opportunity and interest, Pedro. Actually, I was really looking forward to be with you there in the room in London. So my apologies for kind of my last minute change. I really liked the energy last year. You see, I'm proudly wearing also my, flower t-shirt. The socks didn't make it, but the t-shirt is still there. So I'm sure you're having, again, a great summit this year. So now about myself, I'm Eric, working in Roche Digital Technology and leading a very diverse and experienced team focusing on the global development and adoption of privacy-enhancing federated computing capabilities to enrich and scale our ability to access more diverse medical data from outside of Roche, mainly from the real-world healthcare setting. And yes, it's true. I'm, within that topic for a while. So I'm active actually in the field since 2020. I was just looking this up, but yeah. So that's about me. For the ones who don't know Roche, we are a global leader in healthcare, one of the world's largest biotech company and leading in vitro diagnostics companies. And we have a innovative portfolio, spanning, of course, oncology, immunology, neuroscience, ophthalmology, and also very lately, the cardiovascular metabolic space. So that's about me. Thanks for having me, Pedro.
Thanks for joining us and for making the time. So yeah, I guess everybody knows about Roche. Otherwise, you can Google it. You will find plenty of results, particularly in federated open science, for sure. I want to start. So I want to make this talk. We heard a lot of things today that are very technically advanced, and you've been working in this field for a while. But I want to take a step back first and talk about, first of all, why do you need real-world data? I would like this to be accessible for everybody. Not everybody is engaged in pharma and research and so on. So I would like them to understand also why there's such a dire need for this sort of data. One would wonder, okay, pharma companies already do clinical studies. They already have a lot of databases they can buy or data they can license. But why would you need such a specific data set? And why is that so important for Roche and pharma in general?
Yeah, fair question. And I think I will try to give it a short explanation. The main reason is because we want and we must understand and observe the tiger in the wild and not just in a cage, right? So real world data allows us to learn from the real world, obviously, rather than just from clinical controlled trial settings. Now, for example, these controlled trials, of course, are super important and, they're essential. But in general, they have also a lower generalizability. So that means the degree to which the results of a study, may apply or be relevant to other populations or groups that didn't participate in such a study can be very limited. So trial data is very focused. And that's, ultimately lead to evidence gaps in treatments, in patient outcomes, in the real world settings, right? So real world data can provide complementary, valuable insights into the utility, effectiveness, and overall impact of therapies due to this, much larger and more heterogeneous, more diverse, more rich patient pool that is out there available. And that's why this is so critical, in addition to clinical trials.
Excellent. Kind of a follow-up question would be then, why do you need to do these federated data networks to access this clinical trial data? Why can't you just go to a single hospital and try to get data from that single site? How does that look like for you?
Yeah, you can try. Maybe you're successful, maybe not. But why you need it? Because it can practically break down the barriers to access such data, right? Based on the core principle that we all know of keeping data where it belongs, where it sits at the source, and you only move the analytics, your machine learning model, or the insights, right? And with that kind of principle, it enables trusted collaboration to generate then again new scientific insights. The traditional way of centralizing or insourcing, buying data from a pharma company, is still, needed and, will continue, but it's also hitting a limitation, obviously, right? Due to the known reasons. And it's an obstacle, especially for multi-party, multi-site, multi-country collaborations, which are very much needed in these days. So that, for example, in, AI models, of course, can uncover trends, new patterns that may be missed by a single institution, a single hospital, or a single pharma company, right? So I believe this approach is going to make a difference in improving health outcomes by revealing new insights for a broader group of people. And this then, has this cascade of, eventually leading to better discoveries, new treatments, and eventually improve clinical decision support. But it's kind of, it can break down these barriers and enable collaboration.
I have kind of also a follow-up question to that. So I'm thinking with the uptake of, basically, we see a lot of pharma companies, a lot of them came to the event today. They're building exciting models. They're really pushing the frontiers here. So I'm wondering how this impacts your work and the need of, or kind of like the demand that you see internally and also in the industry for these federated data and more real-world data, because I would really like to understand kind of like what things can you do with real-world data that you, and with these federated data networks that are kind of like the best source for them, that you cannot do with the data sets that you buy from third-party providers, and how pharma as an industry is kind of like seeing the limitations now that they're trying to do more advanced things with the data.
It is, I guess, that you need to have, deep data. You need to have broad data and you need to have deep data, right? And I think, there are different approaches, and it's, of course, the kind of the questions mark, which approach fits best for your need and for, the data, that you want to access or that you want to train or evaluate or validate your model, right? So I think it's still, finding out this path to navigate, which use case fits to which solution best. But yeah, I think it's very much a strategic necessity.
Excellent. I heard you say before that when you come to these conferences where we're talking about federated learning, that, sorry if I'm paraphrasing the wrong way, but you mentioned that this is like sometimes we are building a Ferrari, and when you go to the talking with hospitals and so on, it's like trying to take it through the mud, in the sense that it sounds like this we are building very sophisticated machines and very sophisticated systems that perhaps when you go and talk with a hospital, it's very hard to, even though you may have all the necessary features and so on in place, the knowledge about federated learning is kind of just like not there. So I would like you to share a little bit, since you've been doing this for a long time, what is it like to go to a hospital and try to explain, okay, I want to set up a federated data network. Do you see them open to participate? And what kind of is your typical process like when you try to engage with them and try to collaborate with them?
Yes, I think they are open, and it's because there is a need to collaborate, right, and to join forces. Obviously, this doesn't happen just overnight and by accident. So there's a lot of work that needs to be happen to understand each other's interests. Build a common ground. Have a common goal also that you can work towards, and saying that's a reason, that's a good reason. Why we want to come together and connect and bridge expertises, data sets together. So I think the underlying motivation to advance scientific understanding and generate new insights that improve patient outcomes, that's a good motivation, right? And if you start with on that level talking about these things, then you kind of have an open door, have open ears, right? To then go more practically, more on the details, on the tactical things, how to do it. But I think it's you need to have this vision, right, that can unite the people and the teams that have, of course, all their own settings, all their own agendas, objectives, priorities, and it's it's a hard way to actually break out of this and say we need to partner together. We want to do science in collaboration, and this is a way how we think we can achieve this.
When you go to a hospital and you're trying to set up these collaborations, what kind of how do you know this is going to work, in the sense what sort of indicators are you looking for? I'm quite curious about that, in the sense, are you looking for somebody that has a strong interest inside, that is doing a research role, that is willing to push through the administrative burden internally of getting this through, or installing a node inside their infrastructure and so on? What are kind of the key factors that you're looking for, like an internal champion? Or are you looking perhaps of participating in projects where there is a more research grants or support and so on, where there is already kind of a shared project from the get-go? How do you see this?
Yeah, so for us, it mainly starts with the key opinion leaders in the field, principal and the investigators, right? So the top scientific brains that are out there that are either already working with us in clinical trials or through other collaborative projects. Right, so there you have already a relationship, ideally a trusted relationship, and this is where you can we try to tap into. Of course, if you have to come up with a new relationship to build new relationships, then it's about what is the scientific profile of that investigator, of that research team, of the institution? What is the what type of research they're doing? Does it fit our strategic needs, our priorities, our evidence needs? So it's kind of there's a catalog of things that need to come together to say that works for both parties. It has to be a win-win situation, and yeah. So there are criteria questions where how we assess sites, but also through the scientific network that our medical directors or our research teams have. By default, actually, this is how we kind of, connect and try to find and engage with the right partners who then also, are open-minded about this, right? I mean, the scientific world is, also, has very strong egos. I have to say this. So, you can have a good idea, but then, suddenly this idea stops because, no, I don't like to work with Pedro because of ABC reasons, right? I mean, these things happens, this is every day what we face, and I don't want to blame anyone, but this is reality, right? So, you need to find the people out there that are open-minded to try also out new things, but also, willing, to put their egos aside and say, okay, yes, we can do that, because it requires collaboration, and collaboration is difficult. And if you, don't have people with you and a common ground, a joint objective, collaboration is becoming nearly impossible, right? So you want to find the people that you can connect with, that think along with you, and go on this journey with you together, rather than you imposing something on someone. It's a collaboration on a eye level, I would say.
Excellent.
That makes a difference.
Great. I hope nobody has an issue working with me. I promise I'm a nice person. I want to switch up a bit. So I think you have a very tough job because you are not only doing the job of actually going to the hospitals and finding the right APIs. And by the way, I find this quite interesting how it depends on human connection. So it's not such a transactional thing as one would believe, like, okay, we need this amount of data and we just go there. You're really looking for the people that have a vested interest in actually doing this because that's the way they're pushing basically science and healthcare forward, right? And I find that like a very nice approach, and no wonder why you had so much success doing this since the beginning. Now, the question is, we've been also building a lot of tools to make it easier for people to use the users, right? Now we are talking about the people inside Roche that are actually doing the data science, that are preparing the studies, that are supporting the whole product life cycle, right? We invested a lot of time in creating a lot of ways to make it easier. David just today announced how Flower is compatible with DataSHIELD, and there is a package that you can run. And we know that there is a huge community already out there using DataSHIELD and these sort of tools, and we want to make it as easy as possible for them to use it. But still, I would love to hear from you. What's your experience talking with those internal people, the data scientists that are used to work with centralized data? And what sort of things that you found that make it easier for them to adopt federated data as a technology or as an alternative to get their jobs done faster?
Yeah. No, I mean, clearly, the data scientists are the end user. They are, really the ones that are experiencing, the beauty of federation, but also all the disadvantages. Not the medical director or, the data steward or me, right? Or the solution architect. It's the data scientist, absolutely, right? So I guess apart from, that there is a steep learning curve for them, they need to understand and accept that in such a setting, they are constrained compared to how they used to work with data, how they are trained by education to work with healthcare data, right? And it's a trade-off between security, privacy, data utility, user experience. And the earlier, they, accept this new reality and start to think differently, the faster they will get through this, and they will appreciate it, actually, right? So now the few data scientists that have been involved on our side, getting into this federated world, actually, they confirmed that it works. They can generate meaningful results in a federated manner. And we're not talking about simulations or Hello World examples. No, this is, they have carried out serious medical analysis in real world data studies on, real patient data, right? So that's important. It required for them dedication, curiosity, iterations, going a lot of back and forth to trying out, how things work and, am I confident on how this is going to work? Now, usually the breakpoint that they were facing were about the ability to explain what's happening or what is not happening, right? So workflow observability is super crucial for them at any, stage of their execution of their, computations, as well as then the ability to explain the results that they're getting back from the individual data sets or in an aggregated way, because they don't know. They don't see the data, right? So, and usually in the past, they faced, that certain statistical distributions or patterns, they were not able to nail down and explain and set the context. Why is, hospital A, showing this results, whereby, hospital B is showing, completely something different. And this is the moment where typically, you go deep into the data, right, itself. Now, in the federated setting, this is difficult. And so this is where the data scientists suddenly, heavily rely on local data expertise and where collaboration is happening, right? I mean, data scientists are also kind of, I close my room, you can talk to me tomorrow, and I give you the results. But here it's actually, you need to start, be open, communicate, and seek for the collaboration. And I think this is where, data scientists need to also, unlearn certain behaviors and definitely improve their collaborative and communication skills in such a complicated setting.
Excellent. Yeah, I hope they also get to see what some of the Flower users have built, because I think what was shown today is really amazing, and it's a great proof of how you can build a lot of value using federated learning. We had cases like Dogport today, and we have a lot of platforms also that are present here. And actually, I want to talk about platforms a little bit. So I know that you're active in a lot of different platforms and consortia and projects, right, that are creating data sets and that are making them available in a federated way. And I want to talk a little bit about the future and where do you see this going? Do you believe that there's going to be a future where there is going to be one huge, basically, platform in which you can access any sort of data, or do you see perhaps a more federated approach where there are different pockets, different levels of expertise, or areas of expertise, and basically they create these curated data sets for those specific purposes? I wonder also, since you have a lot of experience, kind of like, where do you see this evolving naturally?
Mm-hmm. I guess probably both. I mean, you will see new ones coming up with a clear focus, with a clear purpose. Others will go on standby, or even completely wrap up and conclude. I think this master federated network or umbrella I don't see happening. So because the complexity and the effort for coordination of all the participants goes also up, and it becomes perhaps unmanageable, right? So as well as medical research requires deep domain-specific data, and that itself kind of justifies that you have again a specialized network being popping up. Now, what I think is important for these new networks that will come, to not reinvent the wheel and duplicate technology and platforms, but rather leverage what is already existing, what is proven maybe in other networks, and adopted. And I think this will give an advantage actually to speed up their kind of launch and setup. But these solutions they require interoperability and this plug and play approach. Also, if you think from a hospital perspective, Pedro, right, from a data holder perspective, I think a unique differentiator going forward will be if the hospitals have the ability to stay slim and light in these networks, right? Because they might participate in many. They might participate, being reached out by different pharma companies at the same time in parallel, maybe exclusive networks. And the expectation that each time they have to build up a whole federated stack to actually participate is like this is not going to work, right? So they need to have a way that they can easily connect, right, without kind of increasing their technical depth, and that's important. And otherwise, I think also for the future of data networks is besides the networks itself, that there's a better way how to find and discover fit for purpose data sets, right? So kind of, think about an yellow pages, universal yellow pages for healthcare data sets, right? That you can kind of, check, maybe even go one step further, check feasibility against your research questions. And if yes, then you go into and tap into the network for doing the actual analysis or your machine ML training, validation, whatever is needed. That's what how I see the future for data networks.
Excellent. I find that actually super cool. Just one last question. There is a lot going on in also at the government level, or I would say there are a lot of Horizon projects, European projects, UK projects there, UK, and a lot of different entities that are really pushing forward a lot of federated data networks, federated learning, and so on. And they're building platforms, and we are supporting a lot of them. And I'm super happy to see them kind of like coming to life. But what would you like to see at a government level, right? We have the European Health Data Space coming up. It's a big thing. We have these sort of initiatives. Do you think there could be something that could make it easier to actually get this off the ground, in line also with this idea of like not reinventing the wheel and finding a standard? Like nobody's going to win in federated data if everybody comes with a new standard, right? So what would you like to see to make things easier for these sort of efforts?
I think, there needs to be, of course, somehow regulatory support or acknowledgement, guidance that this is a valid approach, right? So, I mean, this is something that we are still lacking, and it's kind of, is it or is it not, and also in GDPR, or how it will work in the European health data space that is coming into force, in the near future. So there are still, many question marks, and the more clarity, obviously, you get from that level, the more confident, organizations and teams feel to, go that route with federation, because it's still, an emerging thing, right? So that's something that I think is needed, right? Some statement, but this statement also comes, I think, kind of the demand for this is if there are more successful use cases, right, that deliver and showcase tangible value, that making a difference, right? So, and this is, I think, where we still have not enough, right? So the ones that are there, great. We need to multiply them, and as a community, we also need to work louder, all together to kind of really, make federation or federated networks maybe, a default path for AI model validation, right? Because you can't do this in a centralized manner anymore, because, too many AI models, they will never impact patients because their predictions don't work in the real world, right? So you need to find a path. And I think federation networks, with the support and acknowledgement of the regulators, that for medical AI validation, I think that's a good thing.
Excellent. Yeah, I certainly see that coming. There are people that are building models in a federated way that are getting them certified under MDR and stuff like that. So I'm really, I think there's a bright future ahead of us in this space. I don't want to be selfish, and I want to allow somebody else, if you have any questions. I think we are a bit over time, but I guess we can do one or two if anybody wants. Anybody? A bit shy, the audience here. The lady there. Yeah.
Thank you for. Oh. Thank you. Can you hear me? No? Yep. Okay. So I'm definitely up for the future, and I think it's fantastic that companies can opt in and out of these systems and come and go. I'm curious though about the regulation part of things, though. Who should monitor like the different companies' participation in different systems, and were there, for example, if there's the risk of collusion between different companies participating and or things that might stand from a regulatory practice, who should enforce that? Should it be government? Should it be another body? How should that be legislated? Thank you.
Good question. I don't have an opinion about this, right? Probably, in the health space, you have the health agencies, like in Europe, EMA, right? So I think there should be, definitely the governance coming from, and not just like to restrict and but rather guide and help the teams, the companies, to go a safe route, right? In these networks and systems. So I think it's the health agencies in the countries, as well as on the regional or Europe or in the US, the FDA. So these kind of bodies, I think, are the driving forces. Hope that addresses your question.
Any other questions? Yes. Do we have one? Okay. I guess that's one more because we're over time.
Thank you very much. Very interesting discussion. I'm just wondering, you mentioned European health data spaces, and actually data space principles, are very related to federated learning. So I'm just wondering, kind of technologically, what is being done, maybe with Flower specifically, to integrate within data spaces and data space protocols, etc. And is that something you're already working on, or?
You mean we Roche, or in general in the context of European health data spaces considerations?
I think in general within that context, but actually I'm also interested if Roche is doing it. So yeah.
Yeah. So I guess Flower can speak better in terms of if they, what are the use cases and networks that they enable and empower. I don't have the overview there. Probably there are already a few. From a Roche side, I think we are, let's say, technology framework agnostic, right? I mean, you need to start somewhere with, picking one. And it's actually, great to see that, Flower, NVIDIA Flare, these kind of leading frameworks are, friends in a certain way. And it doesn't, it's a hard choice for companies to go one or over the other. So I think that's how we see it, right? So we don't have a specific, preference or fixed technological stack in order to enable these federated networks, right? So quite tech agnostic. We try to be open source because that's also another benefit and advantage in actually setting these networks up, so they're also self-sustainable in the situation also where maybe a pharma company would go out, right? So the network can maybe also still continue even without industry money. So open source is definitely crucial for these kind of networks. Hope that addresses it.
Yeah, thank you.
Yeah, I think with European health data space, there's still a lot to be defined in terms of how this is going to be implemented, and whether each country is going to have their own data repository and so on. But what I see exciting is that this opens the door to actually define standards. And as Eric was saying, like, we don't want the industry to reinvent the wheel. Is a complete waste of effort if everybody's defining a new data model, if everybody's defining a new protocol to connect the data, to store it and whatnot. And I think it would be great if we can see something that actually works all across Europe. Yeah. I have to wrap up 5 minutes ago, but thanks everybody for the questions, and thanks Eric for joining us and making the time.
Thank you for having me.
Okay, everyone. So, yeah. Okay, everyone. We have our next talk here. It's going to be a talk by Nisal Hemadasa. He is a PhD student at the Technical University of Hamburg. And he's a bit of a breakout viral star because we invited actually many of our speakers to submit a 30-second clip advertising their talk. And he produced an incredibly polished 30-second clip that I saw got hundreds of comments and likes. And so many of you have already seen the talk that many of you have seen the outline of the talk he produced. And so you're probably waiting in anticipation of the talk itself. So I'll pass over to Nisal. Can't wait to see it.
So hi, everybody. Pleasure to present some of the work that we at the Christian Doppler's laboratory at the Hamburg University Technology has been doing. So we've been actually working quite a bit some time around hammering the problem of concept drift, which I think has been an area that's been overlooked in federated learning. And this time around, it's not so theoretical. One of the corner cases that was actually introduced a couple of years ago was, it's called group-specific distributed concept drift. We'll get to that. But before that, there's somebody to greet you, somebody that we all know, Siri. The story behind Siri, among the others, behind the background, behind the curtains, what the rumor says, how it started from here, and it ended up being one of the most, not the most, but then let's say partly unpopular services was the data. So it started from a curated high quality set of data, which later on kept on expanding without control. And then that actually led to a degraded performance. More or less a classical example of how concept drift, if not adapted properly, would actually degrade your performances or the models. So a little bit of theory, but let's not go too much deep into that. So From the book definitions, concept drift means the evolution of the data distributions, either input, output, or the mapping between it with respect to time. But we, as the federated learning engineers, researchers, would like to see how that actually applies in the real world in a distributed scenario. So think about it. Concept drift applied to a distributed set of clients. What could happen? Some of the clients might actually behave in a drift in a similar way, some in a much more expandable, different way. But all in all, that would actually naturally create some groups. And depending on the sizes of the groups, let's say there's one group which is much more huge and the other groups are smaller. This creates unfairness. And imagine that the sizes are also equal. This will also be a problem, because if you use one single global model to aggregate everything, that means the global model will not actually converge to none of these optimality. So this is a problem what Salsa and the team, this was not me, a couple of years ago, Salsa and the team, great problem definition, used to define as group-specific distributed concept drift. An area that has been overlooked so far, applies really perfect for the distributed scenarios in federated learning. And then the work that has been done, which, by the way, is like brilliant work, has been very less, but then the underlying concept, what they are using. So naturally, the clients are forming groups. So what if each group was assigned one particular global model? That's kind of like the cluster heads. Sounds great. But there's a small caveat. This, in science, we all researchers do, depend a lot on the assumptions. So the work is actually assumed that the amount of clients or the amount of the heterogeneity, amount of the different types of drifts, amount of the groups are bounded. But this really hardly happens in the real world. That's a guarantee that you can't actually expect to happen. Assume that the number of clients actually keeps on increasing, the heterogeneity increases, the drift increases. The number of global models for each clusters will have to be kept on increasing. That means the problem itself theoretically explodes. And at the same time, imagine somebody, FederateFlower or Scale Out, whatever, a service, federated learning service provider, providing this scaling up of these services will have to incur more and more costs. In the long run, that means dollars. So you are burning dollars. What are we going to suggest for that? So we are actually extracting and borrowing some of the knowledge from the fundamentals of personalizations in federated learning. We are looking into a particular problem, let's say image classification, and then trying to look detailed into a neural network and the layers that each of these neural networks is actually doing. So let's take the same example of image classification. The layers towards the input side might actually be processing more or less generic patterns, lines, edges, much more generic. And the more that it gets towards the output side, output layers, the image, the data that is processed would be much more abstract, kind of like more or less the boundaries of the classes. We also found out, given a specific type of concept drift, it's actually stimulating some layers than the others. So in the aggregation scheme that we are proposing in this work, what we have been working in the last winter behind the closed doors in the Christmas vacation, was that we are sharing with the global model only the layers that are less stimulated towards a given specific drift, concept drift, and keeping the rest personalized in the model. That means there's no grouping, there's no clustering. Each and every client does the same. What does that happen? So now we have eradicated the multi-expanding amount of global models that happens, but instead we focus on one global model back again. So shrinking the expandable global model problem back into one. So the scaling factor, we are actually trying to reduce, wrap it up. More or less in the real world, you don't need this horizontal expansion anymore. You can actually try to shrink that expansion a little bit lesser, saves cost. Because the time is about to end, and also my speech or the talk, we, like all the researchers do, actually try to prove our hypothesis through empirical and theoretical proofs. So based on 3 different scenarios, each covering different corner cases, we have actually tried to run different experiments. The results in a nutshell was that compared to the existing solutions, the fairness was much more comparable. But hey, on the other side, the recovery of the concept drift, remember Siri, was much more robust, and as well as the computational complexity, stability and scalability, as I told, we were gaining. So that's just the beginning. We are continuing along the same path, which seems to be a nice ROI compared to the leap of faith that we took. Yeah, happy to answer the questions and talk the whole 24 pages in details with you later on. Over to you, Nick.
Thanks so much, and great. Thank you for inviting people to dive in deep to the 24 pages. Quick questions, if there is one. We're running a bit behind. Yeah, there's a person just here. You want to?
Hello. Thanks for your lecture. In the slides, I found you can. Right. Can you explain the difference of the generic patterns and abstract patterns?
Yeah.
Yeah. Thank you.
Yeah. So in generic patterns, if you think, let's say, take an image, right? Cat and a dog. Towards the, let's say, so in literature, you kind of like call or name whatever the layers, not on the out, let's say towards the output, but the input side, called an extractor. So that's where you're kind of like, you try to figure out how to differentiate the lines, the edges, and stuff like that. But whenever you get closer to the output, you try to differentiate these boundaries between the cat and the dog, the exact abstract patterns, like where logits are. So how I could also go a little bit detailed into a step and try to kind of like match that, how that actually matches with the concept drift. So assume that you use some label swapping, right? You swap the labels. That's kind of like the drift. Let's say kind of like an attack, right? The part of the initial, let's say the extractor might be more or less the same in any of the swapped and non-swapped cases. But in the swapped cases, it's the last label that actually flips. So it actually identifies the cat as a cat, but because it's called a dog, it's the last layer that a model that's trained with swapped data actually changes from the model with non-swapped data. Does that answer your question?
Yeah. Okay.
Very good.
Thank you. Thank you.
Yeah, thanks so much. Let's thank Nisal again. So our next speaker is Dr. Iman Greta Ben-Yaha. She is a principal AI scientist at AWS. And we've been talking to AWS about a lot of different things we can do together. You would recall yesterday we had a talk from AWS, but this time based in Taiwan. Today we have Iman. She is coming from Philadelphia, I think currently. And she's going to talk to us about a couple of things, mainly about how you can do federated fine-tuning in AI native networks. And the use case that we see to be sort of exploding in this sort of technical direction is for telcos, but I think that the application is much wider than that. So thank you for joining us, Iman. We're really excited to hear your talk.
Thank you so much. And everyone, thank you for having me.
So the talk today is about, as Nick was mentioning, is why we need federated fine-tuning for the AI native networks. My name is Imenkida Benyaya. I'm principal scientist at AWS, working mainly on the telecommunication industry. And today I want to start by sharing what is the status of the telecommunication industry with respect to agentic AI, the AI native pipelines, and how we are leveraging the network data to transform the network in general. So if you're not familiar with the telecommunication industry, this slide will help you set the stage of where we are. So basically, today we are moving from manual network management. So when I say manual, it means it is managed by definition of threshold, definition of rules and constraint, and those are varying over time. So when I say network, for example, if I take mobile network, is anything related to 2G, 3G, 4G, 5G, and even now 6G network. So this is what I meant by network, but also the fixed network and the fiber. So these network, previously they were managed with static configuration, as I said, threshold that needs to be defined across different network segments and across different protocol stacks. So it's a very complex environment and very dynamic. It change based on the mobility of the users, it changed based on the, for example, the connectivity, it changed based on the regional infrastructure. So there are many factors that make this network very dynamic and, of course, suitable to deliver the service to the end users like you and myself. So the current status is what we call AI as overlay. So what's happening now is that different customers across the globe, and I'm working with different customers to transform, first of all, the network operation. This, as example, it can be the root cause analysis, it can be the service impact assessment, it can be just the observability to understand the health check and the status of how the network is doing and the services that are offered if they are meeting the, for example, the quality of service expected or not. So this mainly means we are collecting the data, then the customers are collecting their network data, and from there they are building agentic pipeline. This agent can be prompted to understand, for example, the alarm sequences, understand the configuration of the network, understand the deviation of the KPIs, and then consolidate the information to bring root cause isolation or service impact assessment, or, for example, identifying or predicting what's going to be in the network in terms of telemetry values or KPIs, etc. Of course, all of this is a combination of the generative AI, but also the classic machine learning and deep learning in order to understand end-to-end what's happening in the network. What we've been seeing, of course, here, it's not POC, it's not MVP, so our customers are already in production. I can cite Docomo, for example, for their full mobile territory networks through the radio access network, transport, and core. If you're not familiar, these are just segment of the network where the traffic is of the traffic of the network is ongoing. And then we built, for example, root cause analysis with agentic, and all of this is in production. When you go at the scale, you will see that the LLMs are not enough to handle the network data. This specialization, it's because simply the network data, it's not open source data. You cannot find it in the internet. It is sensitive data. It is locally and managed by every CSP, and it's not something that you can find on the internet. So that's why the LLMs need to have extensive prompting to be able to work properly on network data. So today we are building those agentic and, of course, configuring and prompting the agent to make sure that they are delivering the expected values for the transformation. At the same time, we are preparing the next step, which is the AI native networks. And this is how I started to work with Flower team here. And thank you so much for the collaboration. It's how to go to have the intelligence at every layer. And I was mentioning that the telco networks is horizontally and vertically across different layers and different segments. And the idea that we are building at AWS is what we call the network language model. So it's specialization of model for the network use cases and for the network tasks. And this needs to be in a hybrid, this needs to be taking into account the hybrid data residency of the different CSPs today across the world. And this is mainly for reglementation, for sovereignty, for the sensitivity of the data. The data, it's not in a central place. It can be, on premises, at the edge, on the region AWS. So we need a solution to help the customer to still be able to customize their model for the network use cases. So that's where we are going to show you here the proof of validation. If you need more information, please feel free to go to the Amazon Science blog here, and you will understand more the steps and where we are going. The target is toward this called Intelligence Fabric, and there it's more distributed intelligence. Of course, it will be built through federated fine-tuning, through distributed intelligence and inference, and as well as logically distributed data that it's maintaining the sovereignty of every CSP at the international level, because this is different from a customer to another. So this slide is to give you the status and what we are doing in this domain. This slide is just to share to you what we mean by network language model at the high level. So it's not just fine tuning on, for example, with SFT or FT or even like retraining. It's really the logic and the data preparation that matters here. So the network, it's not about remembering, for example, fine-tuning on an example of event or example of incident and expect the model to generalize. We are working on having the model understanding the reasoning, working like a network engineer, understanding the runbooks, the failure pattern, and reason based on feature engineering that are related to the network itself. So we are trying to go beyond the classic fine-tuning in terms of data preparation, but this is another topic. But here I wanted really to highlight that it's not simply taking Q&A and then expect the magic to happen. The network is very complex to get generalized with these such approaches. Now back to the federated fine-tuning part, and here I want to share what we are doing. What we presented at Mobile World Congress this year, and it was a collaboration AWS and Telefonica in the context of Data and AI TIP project. And this is where I leveraged the Flower open source framework, and I had all the support from the team. So here you can see that the use case and the data itself. So this is one type of use case. I'm talking about the configuration part, but it can be, as I said, root cause analysis. It can be service impact assessment. It can be troubleshooting. For the configuration here, we are manipulating data that it's coming in, for example, JSON format or YAML format, and it is coming with a specific grammar. So it's not a grammar that you can find in the internet. It is specific to every operator. This information is, of course, specific to every operator, but also internal to every operator. And configuration file can be for example, if you take network function for a network function or for a service, it can be with different, I would say, number of lines of code. So it can be very verbose files for just one type of configuration. And you need many of them in a coherent way so that you can configure the network, augment the capacity, or execute any correction when there are some failures on the network. So these are very complex files with policies, security constraint, and also topology information, and many other grammar that are embedded in those type of files. So here we've used Telefonica routing policies, BGP peering, hardware inventory, whatever data related to the configuration from the network domain. And this is a proof of validation. So it was a small subset of data to first exemplify what we mean by federated fine-tuning, how it works if you have different sources of data that are coming from the network domain, and also explain that the shared information across the cloud server where you will be having the Flower server node, it's only the mathematical weight. So there is respect of the zero data movement and also application of the privacy algorithm to make sure that there is no data leakage, and making sure that the data it's not moving to the cloud as per the constraint of the different customers we're working with. So how it looks like, this is just like a high-level design of what was implemented for the Mobile World Congress. So to highlight, here we have two sources of data. So they are similar in terms of information, but different in terms of configuration types and also configuration information, but the same format of the data there. We've used Mistral 7 billion as starting implementation here for the proof of validation, and we showed that in the form of 3 VPCs, so 2 VPC where we are simulating 2 different opcosts. And here you have completely isolated VPC, so there is no communication between those VPCs. This is to respect the privacy and reglementation part. And both nodes are communicating to the server that it's here in the region on AWS. And there we will be, of course, through the different round, training the model until having the global model that it's federated training based on those sources as if these sources are together. And this is what is new in the telecommunication industry, that this is possible. And this is respecting the zero data movement that they are expecting to have. So, of course, here it can be, I'm citing two sources, but in general, it's not two, it's many sources of data, and this can be a regional aspect, it can be international, so it depends on the CSP infrastructure and wide, let's say, scale of how they want to handle their data and how they want to build their network language model. So what is very important for the customers I'm working with, it's really the privacy part, which is one of the next steps that we're working with Flower team as well with Telefonica, is what are the different requirements from a privacy perspective, and what are the existing available algorithms that can match those requirements for different use cases. Here is configuration, but it can be also other type of use case where you have sensitive data and you want to make sure that this will not be leaked through the trained model. So how it looks like for this use case, for this proof of validation. So here we've used, I said, Mistral 7 billion. So the first one, of course, is the base model, and both of them were prompted with the same prompt, acting as a configuration manager to read the different ranges of IPs and grammar, and then come with a configuration generation. So the base model, without indication that it has to be JSON, that it has to be this range or these kind of specific configuration requirement, it was just prompting, it was just outputting different information relevant to configuration, but out of the scope of being a configuration file that you can take and execute. While the federated fine-tuned model one, it was directly generating a JSON file, leveraging the grammar that it's needed by the Telefonica team. Of course, this is, I will not say that it was all 100% correct. It was a very small subset of data, but we had very good generation and promising result to build on top of it. So this proved that you can fine-tune a model or specialize a model without bringing the data together, which is one of the major goal here. And secondly is to make sure that we can, as I said, secure the privacy. So we've tested the differential privacy, but not relevant to that case where we have, as I said, two sources of data, but we are working on testing and experimenting for further configuration and use case. So as key takeaways here, again, this is very new and early stage work that we are sharing in the telecommunication industry, taking into account one of the most important requirements that it's coming back, it's hybrid data residency. For customers where the regulation cannot enable them to have, let's say, the data moved to the cloud, then they can do this in a hybrid way with a federated customization. It can be fine-tuning, it can be further type of training there. And the idea is to make sure that zero data movement for the data that they want to preserve on the cloud, on-prem, and especially making sure of the privacy part that we are going to handle as next step. So for the next step, so we are going to experiment, as I said, more with algorithm and understand the different results, but also define training strategies and best practices for our customers, because this is again new, and we need to understand if this is matching the requirement from the telco industry. For sharing to the industry, telco industry and wider, we are working on in a blog together with Flower team with open source data to exemplify all the steps, but also to show the needed requirement for the telco data, so that we can see if we have more, let's say, requirement or new innovation in the algorithmic side, especially for, again, the privacy part, which is very, very important. We will also experiment with other open source model. Here we just selected Mistral 7 billion as a starting point, but the idea is also to experiment with other model and check the result. With that, I'm done. So if you have any questions and follow-ups, just know.
Thank you very much. Thank you. We have time for some questions if folks want to ask anything. Looking across the audience here, there's a question down there. Sure, I'll run across here.
Thank you for the talk. You mentioned hybrid environments, so you had some AWS VPCs and also some potential on-prem systems. Any challenges that you encounter with either of those, specifically from potentially a security perspective or connectivity and including the systems in the overall federated model? Thank you.
Yeah, that's an excellent question. So Basically, regardless of the federated fine-tuning part, we already have distributed system where we have the connection across different, for example, the local zone, and then the edge, and then the on-prem, and then the cloud. We have things like, the direct link, and we have also security embedded in all these communications. So the security part, it's not a problem. So what we need to understand more, and this is why we need to experiment, is how big is the needed throughput and bandwidth where we are communicating through the different sources and the server node. And this will depend on how big is the data and the weights that will be communicated and the model itself, et cetera, et cetera. So from a security perspective, we already have these systems communicating together for other type of use cases. Now for the federated fine-tuning, we need to see how this is going to be, depending, as I said, from the models, the communication, how many sources of data we have, and how distributed these are. One of the kind of requirement is to understand also the different infrastructure at every CSP, because all of this, as you can see, the bottom part can be part of the infrastructure of a given CSP. So they need to have a compute enough to run these kind of round of trainings. And of course, they can leverage AWS infrastructure at the edge to extend their current infrastructure. But this is part of the next step for the experimentation also.
Great. Then I don't see any other questions. So thank you, Iman. Thank you so much for joining us today. We really appreciate it. Thank you.
Thank you. Thank you very much.
Okay, so our next talk is from an incredibly important organization in the larger, wider ecosystem of AI, and in particular, federated systems. We are, of course, getting a talk here from ML Commons. And so we have two really leaders at ML Commons here to talk to us about the work that we've been doing and where we see things going in the future. We have Alex Karakiadis here. He's a very well-known person from ML Commons doing things in the MedPerf working group for quite a while, as well as Hassan Kasim joining him to give us a talk. So over to Alex. Thank you for joining us.
Thank you so much for having us, Nick. And it's wonderful to see the community grow so much over the years, and fantastic to see collaborative communities building fantastic things. My name is Alex Karagiris. I'm the chair for the medical working group at ML Commons, and here with Hassan Kassem, the technical lead, we can present some integration we've done with MedPerf, our benchmarking framework, and Flower. I just want to give you a little bit overview of ML Commons. For those who don't know, it's a global ML community. Since 2018, 100 plus members now. It was established to build benchmarks for speed. So that's why you see a lot of the compute companies as founding members of the organization. But naturally, the organization have grown and included academic institutions as well, nonprofits, and all these basically organizations function around working groups. One of them is the medical working group that I co-founded back when I was at IBM. And it's like grassroots from the industry, researchers and academics that drive to build basically best practices around ML and drive benchmarks, develop benchmarks for AI, tools, as well as data sets that are all open sourced, paths to license. And the idea is that, with all these best practices, we can drive, AI innovation. I just want to, pick, a few of these, working groups. MLPerf is the founding working group around benchmarking. It's the industries, the hardware industries, basically de facto standard for benchmarking speed for training and inference. The AI risk and responsibility working group is also a big one that drives basically safety benchmarks for LLMs. The medical, I'm going to be talking about later. The Croissant working group is a metadata standard format for ML, which has been adopted by Google, Hugging Face, and others. So you can see, how the collaborative community can drive innovation and build, basically impactful outcomes. So when it comes to medical working group, we had contributors over the past 5 years from different companies around the world, academic institutions. Flower was also a contributor, and spoiler alert, Micah Scheller, who is with Flower, He's a vice chair for security when it comes to the medical working group. And he's going to present, some interesting stuff we're going to be doing with the community in his talk later. So in the working group, one of, the efforts that we're leading is MedPerf, which is, our benchmarking platform for medical AI. And this project, started with, participation from, our companies like Intel, NVIDIA, and Google. And the idea is to how can we capture the real value of AI in the world. And we've seen, stories like this, that, there's, a model that was developed, in the lab with a limited basic validation sets. And we need to take, these models out in the, a real world and evaluate them and see how they perform and how well they generalize, right? So that was, our motivation in the working group. And based on federated learning principles, we build, MedPerf or maintain MedPerf, which basically allows evaluation of machine learning models in medical space in real world settings where, the data doesn't leave the premises. And intentionally, we have a human in the loop always for all the acceptance, rejections of, the workloads, because we're touching, sensitive data, right? So some of, the use case I've been working on is one of the largest federation for neuro-oncology, 50 plus, institutions around the world that is led by the Response of Assessment in Neuro-Oncology Working Group. I didn't know about this working group because I'm not a clinical person, but they are considered, the de facto working group, clinical working group when it comes to neuro-oncology treatment. And with them, we've been, supporting various studies, one led by the Duke University and Indiana University for segmentation of treated glioblastoma patients. And recently, we are, partnered with an academic institution to validate their proprietary model for 8-month prognosis. And now you can see, in the map, the breadth of, the institutions participating in the federation. But before I switch to Hassan about, the technical components, I just want to, give a little bit of, I would say lessons we learned during over the past years with these federations. And I think, it's a common, theme that I've seen also in these past 2 days. Trust and scalability in federated AI is still, open. There is a need for best practices around that to enable trust in federations. And we need governance enforcement for, ML assets. And by that, I mean data sets, models, workloads, you name it, right? And then we need to scale, federations. And thanks to, supergrid and supernodes, like efforts like this, can make scalability of, the federations and, like the previous, speaker said, discoverability of, the assets, right? So we can be able to access and be able to run operations on the analytics on, these assets. And what we've been also noticing on our federation, when it comes to big federations, we need the persistence, right? We need to be able to sustain making, the assets accessible and not, one-off operations and then just die, right? And again, thanks to, I would say efforts like supergrid and supernodes, that is the path forward as we're moving forward. And with that, I'm going to switch to Hassan. He's going to give you a deeper dive into the technical aspects, and he's going to talk about also the integration with Flower. The floor is open.
Right, hi everybody. Yeah, I'm Hassan. I'm the lead engineer on MedPerf. And I'm gonna start with presenting some high-level details about the MedPerf platform. All right, yep. Thanks. All right. So MedPerf, as a refresher, it's an orchestrator, okay, for federated workloads. The main two components are the MedPerf server, which is basically a registry. Okay, so for example, registered models or data sets, registered models, code and weights are hosted by the user, okay, in a, for example, on cloud or on Docker Hub, but only metadata about the model is being registered on the MedPerf server. All right, so it's just a registry, and there is a client the client is used by the users to through the web UI to, for example, prepare their data, run inference, run training, etc. And there are three types of users that actually use MedPerf. There is the benchmark committee. The benchmark committee basically defines the benchmark, defines data preparation logic, evaluation metrics. They can also manage participation by accepting model owners, accepting data owners, etc. Model owners, they basically register their model to be benchmarked and participate. And data owners register their data, prepare it, pre-process it, and then finally they run the benchmark. And also MedPerf provides some tools, okay, for data processing mainly. So for example, we have a tool for helping data owners to pre-process and annotate their brain tumor datasets. There is also another tool for benchmark owners to monitor the data preparation process of their data providers. All right. And today we are also announcing an integration between Flower and MedPerf. So currently, MedPerf was mainly for evaluation, but also can orchestrate training experiments. So we find that users would like to use MedPerf to pre-process their data, and also after that, they can participate in training federations through Flower, basically by spawning supernodes. So I'm gonna talk about details of the integration, all right? So first of all, on the left, you can see that how MedPerf has a certain abstract design of orchestrating training experiments, all right? There is an FL container, which is mainly will contain the framework code installation and the apps. There is the FL plan, mainly the configuration of training. And through this, the container can be used as aggregators and client nodes. And this is basically the Flower So the FL container in MedPerf will contain Flower framework installation and the Flower apps, right? The FL plan will be used to generate a TOML configuration for Flower, and this will be used to spawn superlinks and supernodes. And the user journey in a federation is basically like this. So there are two players for training federations. Model owners, they define the training experiment, configure it by, for example, defining the runtime configuration and the aggregator address, and then starts the aggregator. And data owners will register the data, prepare it, register a public key to authenticate their supernodes with a superlink, and start the training. And we usually do a live demo showing how this works. But now for time limits, we are going to show some screenshots of how this works in MedPerf. So this is how the experiment dashboard will look like. So the model owner will register an experiment dashboard. This is some metadata. And mainly in this dashboard, what they can do is, for example, they can set the training configuration, like the runtime variables, and also the runtime variables. And they can also start an event, so signal for the other users that a training event has happened, and they can now join the superlink. The aggregator dashboard. So also the aggregator on MedPerf is basically a record of an address and some ports. And this dashboard of the aggregator can be used to get a TLS certificate and also to start the aggregator. And here I want to say something about certificates. So MedPerf provides also a template deployment of StepCA certificate authority, so that for a federation, a certain trusted authority can basically deploy a certificate authority, and then aggregator servers can communicate to get a server certificate by solving an ACME challenge. And also supernodes users can communicate to get a client certificate by authenticating through Auth0 ID tokens. And this is how the superlink will be run. So after clicking this Start Aggregator button, you will see the logs, basically. The superlink will start, and you can see the Flower logs here. And this will also, and what happens behind the scenes is that this is the FL container that we run. The FL plan is mounted, used to generate the project TOML file. The initial weights of the federation is also mounted, the TLS certificate, and also the list of collaborators' public keys. So then this container will spawn the superlink, register the supernodes through their public keys, and submits the Flower app. So the training can start. Now, for the data owner side, this is how the dataset dashboard will look like, some metadata. And through this dashboard, they can prepare their data. And finally, they can associate themselves with a training experiment. And also they can go to their settings, get a client certificate. And finally, they run the supernode. And before they run it, they will be asked to confirm if they are okay with the configurations that the superlink will be using. And what happens behind the scenes is similar to superlinks. The container will be mounted, there is an FL plan mounted, and there is the data and labels, of course, the TLS root certificate to authenticate, verify the server basically, and the signing key of the data user so that they can authenticate as supernodes. And this concludes the demo. This is a link you can visit and you can basically try this tutorial. It's on CodeSpaces, so you don't have to do any setup. You just click the button and you can run all of the tutorial. Thank you so much. Please ask your questions.
Any questions? We have time for about one quick question. In fact, running a little bit late. A question in the back. We're going to take this very quickly. Charles is going to run back there. And okay.
Wait, can you? Thank you very much for the presentation. I enjoyed it, especially from the technical aspect. So in regards to that, my question is about the user journey for both the model owner and as well as the data owner. So in regards to that, the data owner, why in the second step do you use a public key registration and how is that done? How does that safeguard the public owner?
Okay, so you want to know details about the public key registration, right? Yeah, so basically the model owner or some trusted party will host a certificate authority, right, through step CA template. Now the user, okay, the data owner basically will authenticate with auth0, present an ID token to this certificate authority and get back a certificate, all right? Now, we have this if the underlying federated framework wants to use MTLS. Now, for Flower open source, it uses just the registration of public keys. So what we do is we extract the public key from the certificate and pass it to the supernode, basically. Pass it to the register it on the server, MetPerf server, and use the key for the supernode deployment and use the public key to be registered by the superlink. So this is how, basically, it's a Flower workflow. Yeah.
Thank you for that. And just a last follow-up question. Can you talk in terms of expansion, what is going to be the next step, especially in regards with Flower? I'm just curious to know where you're trying to take that.
Yeah, so actually, currently we will we'll discuss and see what could be next steps. One of the things could be to add more features for the some admin commands, to see how we can do some runtime edits on the federation, to see how we can allow for multiple. So currently the aggregator, the superlink, will be spawned one time, but it would be great also if we can do an integration where the user can run the aggregator and then submit multiple Flower apps, for example. Yeah, so this is basically a first draft integration. Yeah.
Thank you.
Sure.
Okay, so the final talk of this session is going to be given by Micah Scheller. I've actually known Micah for a number of years, but just recently, in the last 3 months or so, he joined Flower. And so He is helping us tackle a lot of weighty issues that are essential in order for us to sort of arrive at this vision of collaborative AI. One of those issues is governance. And so he is going to tell you all about how we see governance unrolling in the sort of the preceding months and years, and in how we're going to overcome some of those challenges that presents. He also has a special guest joining him, but I will let him introduce her at the right time. So over to Micah.
All right, thanks, Nick. Hello, everyone. We're here to talk about how to party responsibly, because that's a lot more fun than governing cross-platform collaborative AI. So I'm Micah Scheller. I'm a new principal engineer with Flower Labs, and I am a large and silly man. And I also am vice chair to this working group over here. Hassan and Alex are great friends. I'm here with my friend Anne. Do we have Anne visible? Hey.
I imagine I'm on a big screen. Yes, I'm Ann Nowakowski. I'm a product strategist at Sage Bionetworks. We're a nonprofit organization and a data steward for health and biodata. It's great to be here.
All right. Do we have the slides back, maybe? I'm not sure how this is working. All right. Okay, yes. All right, there we go. So what we are doing here with scaling data is very important and very powerful. International collaborations matter, and they matter a lot. So to get serious for a bit, and then we'll get happy again, imagine that you learn that your nephew has a form of cancer so rare, there are probably less than 10 cases in the UK right now. And imagine he has 2 months to live. And then you learn that an international effort has recently gotten approved a method that's going to turn that 2 months into years and possibly a cure. And you just learned it this month. Imagine how thrilling that would be, how important that would be, and how much it would impact your life. Having this happen requires international collaboration. These kinds of rare diseases, many of them, there are tens of cases in any given country in a year. This is nothing close to enough data to train collaborative AI, or AI models in general. So with that somber but serious and actually hopeful message out of the way, I'll get back to being a bit more silly. I wanted to set the stage of how important this is to some people. So we have this great power. With it comes great responsibility. Often, federated and centralized AI are positioned as in opposition. But actually, data repositories would love to offer federated AI and connecting to federated platforms as a service to their customers. The problem is, these repositories also need to shepherd and steward this data, which means they need to have robust, often complex, governance processes put in place. And if you have those processes, they need to be honored across an entire federated workflow if you want to participate. This is not easy. It's not easy for quite a few reasons, but I'll list a few here. Kind of put simply, these processes and the policies and rules attached to them are often expressed in what is essentially legal language, and it bears a lot of the same challenges that legal language brings. First off, it often doesn't translate. Second, the enforcement of it can be inconsistent. And third, the evidence standards often aren't there, or it isn't clear what will qualify as evidence. You can imagine in our setting, this becomes pretty intractable at scale. What we really need are clean policy expressions with well-defined standards that can be quickly checked and reconciled. Okay, so we're engineers, we're scientists, we see a tough problem, and what we like to do is tackle it and have a whiteboard party. And what do you need for a party? The elements here, an awesome venue. I think we know about Supergrid, we've been talking about it for a while. You need a great host. You've met ML Commons. They have a proven track record of bringing industry players together to work on pre-competitive problems. And you need a popular guest to let everyone know how cool the party's going to be. And in that case, this is Sage Bionetworks Synapse platform that Anna is representing. Sage, the Synapse platform specifically, is a governed data repository that is tailored for biomedical research, that has over 15 years of operational experience and understands real complicated governance. They're the perfect person to tell us if we're doing anything that matters. All right, so it's party time. and we're getting going. This has begun. Alex, Hassan, they alluded to this. We are building this. Imagine you're a Synapse customer and you're a SuperGrid customer, and you have data hosted on Synapse. And you've set up a bunch of policies through Synapse. And now you want to connect it to SuperGrid. Okay, that might take a lot of work. You might have to do a lot of configuration on SuperGrid. Or maybe you click a button and you're done. Sounds pretty awesome. This is what ML Commons is enabling. Okay, I've been silly. I've given you kind of the big picture view, why I'm passionate about it. And now to put some actual, meat on the bones of this silly talk, I turn it over to Anne.
Great. So I just have to say, no one would ever say that data governance is sexy. So I really appreciate the fun that Micah brings to this topic. The party metaphor is great. So our mission at Sage is open science, and our goal is to get more eyes on data. So if you want to show up to the party, there are a few house rules that you'll need to be aware of. These are informed by a number of sources, such as legal guidance, obligations to stakeholders, community norms. In the Synapse case, data users must be vetted against data-specific requirements. So I've heard a lot of questions and conversations in the room today about data owners, for instance. As stewards, we need to be able to convey to data owners what the intended use of data is. So if data is consented, for instance, for healthy aging research, and you want to model cancer gene knockouts, those aren't the same thing, and the policy catches that. For human subjects research, we may also need to confirm that you've run your research project through appropriate ethic committees prior to accessing the data. We also need to know who you will be working with the data, a named list of collaborators, a named institutional representative. This is where we bake in accountability if things were to go sideways. And then where does the data and the analysis, where does the data go? Where does the analysis actually run? Not on someone's personal laptop or any cloud instance. We need to be able to verify where that compute happens. And then lastly, access isn't permanent. So when the research purpose is complete, we don't want the data to linger on external systems. And when the party ends, the lights come on. So all of this is encoded into a policy object that persists across the ecosystem and that gives folks access to really rich biomedical data, but in a compliant manner. So as data stewards, we don't set the rules once and then walk away. Governance is a living contract between ourselves and the people whose data makes this possible. And that next slide, Micah. So how do you get your invite to the party? The first is evidence collection. Before anything gets evaluated, you need to share evidence of your claims in the form of signatures, approvals, attestations, and receipts. Synapse acts as the credential provider, so where your documentation lives and gets verified. Then we move to policy evaluation. The ML Commons policy framework takes your evidence, checks it against the governance requirements that the data owner has specified, and if everything clears, it issues your capability package. So it's machine readable, it's signed, it's portable. And then thirdly is the guarded execution. And this is where the Flower supernode receives your capability token, checks it before computation begins. And for us as data stewards, we can feel rest assured that any policy requirements or updates on our end persist across all connected systems.
Awesome. And I want to point out another piece of this puzzle that I think is really amazing. You see the line, update the policy without having to update the supernode. What ML Commons, what Hassan and Mick Bowman in particular have been building has this incredible property where the specifics of the policy logic are not comprehended or need to be comprehended within the supernode. And what this means is if you want to update your policy, you don't have to touch the supernodes at all, because that would honestly be quite a deployment nightmare. It would also bind our services together in very awkward ways for ops teams. This framework actually allows us to collaborate in a decoupled fashion where we don't actually entangle one another, and you can update the policies on Synapse. You can update the kinds of policies. You can turn them into smart contracts, whatever you want, and the supernode stays untouched. And I personally think that's awesome, so I'm going to call it out. All right. white paper at the bottom around the framework. Hassan's awesome. I'm gonna have to, plug his stuff. Okay. All right, so come join the party. Don't worry, the dragon's tame. And I'll let you decide which one of those characters I am. We've got ML Commons, we've got Sage, we've got Flower, we've got a lot more. Talk to Alex, he can tell you all the other amazing names of the people that are joining this effort. And let's all party together.
That's right. Micah Scheller has made governance fun. Round of applause.
Thanks.
So, any quick question? No? One question there, and then we'll take a break. We've been going quite a while here.
Do we still have Anne?
Yeah, I believe so.
If the policy for a certain data set were to change and become more restrictive, would it just automatically disappear from the network? How would that sort of manifest?
For the supernode?
Yeah.
At that point, you'd essentially you'd have to revoke the capability token, which would shut down the supernode, but then you wouldn't have to update it. You'd simply have to restart it, and it would no longer contain the necessary capability token. And in order to obtain it again, it would need to pass the new policy check.
Okay.
So the token it receives is actually code. Without it, it cannot run. So it's this really cool mechanism by which the policy is evaluated, and when passed, it gives this essential signed piece of material to the supernode, which allows it to run. So as soon as you've shut it down and restarted, it can't start up again.
Cool. Thank you.
Oh, sorry, without passing policy again. I'm not saying it's dead. I'm saying you can revoke it.
Yeah, I think we're going to cut things off there and go to break. But thank you, Micah. Thank you, Anne. And yeah. So we'll be back in 10 minutes after a quick coffee break for a fantastic panel that you don't want to miss.
Welcome back, everyone. We're taking a quick break from the main Flower AI Summit 2026 Day 2. You have just seen Micah and Anne talk about governance and federated learning. We have another session coming up, and it will start with, let's see where we are. It's a panel talk. Yes. Yeah. So we will start with a panel, and then we will move straight on to the two remaining talks that are about scaling Flower for enterprise through open cluster management through Red Hat. And then we also have Flora Lab. So that will be the last presentation of today. But as always, we do guest interviews. And if people are stopping by, we'll see who is currently right outside. Feel free to step in. Let's check. Come. And we do. We still have some presentations going on, but here, welcome in. Here is your microphone, and then let's see. You can take a step forward. That's fine. Hi, nice to meet you.
Nice to meet you.
Please tell everyone what you do and who you are.
Okay. Yeah, my name is Igor. I'm originally from Brazil. I'm currently studying master's research at Imperial College, and I recently came across federated learning, and that's why I decided to join the conference, and it has been really productive.
So nice. What drew you to the conference?
So currently I'm working with long tail predictions. So how can we improve deep learning when we have very few data samples? And then my application is medical AI. And then I know federated learning has been used, has been a large application of it has been to medical AI. We just saw some presentations about it. So that's why.
Right. I mean, medical AI is a broad topic. Are there any specific use cases that you're looking into? You said long tail.
Yeah. So currently what I'm studying is how can we predict there is a disease called pressure ulcer. so which affects around 1% to 5% of the patients in a hospital. And then the idea is how can we improve models to better predict this kind of diseases.
Right. And is this at this point coursework, or what is it that you're working on? Is it open source? Are you planning to? How are you executing on it?
Okay.
Basically?
Yeah. So like right now we're targeting some conferences,
right?
And then the idea would be at some point. I've been exploring, and one big problem in medical AI, like at least in this disease, is that the data sets, they're usually private and very sensible. So we're exploring all the alternatives, and that's how I came through federated learning.
And are you working currently with labs that can provide you with this sort of data, or where do you get your hands on them?
Yeah, so there is a very famous public data set called Mimic, which is from US. So I'm using it. And also we have a partnership with the Imperial Hospital, but then it's highly sensible. And then Mimic usually is more productive because we can download it and then run experiments through it. And I don't know if Mimic uses federated learning because it's from a hospital from, I think it's Jewish Bath Hospital. I don't remember the name right now. So I don't know how it exactly works. But then once you submit the form, you can download the data set as long as you keep with the compliances.
Okay, and how much data are we talking about, and what type is it images? How does it work?
So for me, I'm working with lab values, vital signs. If I remember correctly, we have 70,000 patients. So it's, I think, and like open data sets, if I'm not mistaken, is the biggest one. They also have images and x-rays, but mainly I'm using the notes. So notes, discharge notes once the patient is discharged, and lab values, vital signs, and medications the patient has.
Okay. And if people want to catch up with what you're working on, you said a paper might be coming out. Where should they, if they want to follow what you do? Do you have a GitHub repository, or how do you?
Yeah, currently the Git is private because we want to publish first. But I have a website. It's igor.azevedo.com.
Okay. Yeah, you can send it to me and we'll link it.
All right. Yeah.
Okay. Well, thanks very much for stopping by, Igor. And as said, that you should check out your repository, and we're looking forward to the paper coming out.
All right. Yeah. Thank you so much for. Yeah. Have a lovely day.
Yeah, you too. Thank you. So you see, we still have a couple of people. I know that there's a line outside already, so we will welcome the next guest in. Hi, how are you?
Hi there. Very good, thank you.
Hi,
Thanks
William.
for having me. Alex, nice to meet you.
Please tell the live audience who you are, what you do, and they've seen, the people who have been around today probably have seen your face before, but...
Brilliant, yeah. My name's Alex. I work at the London AI Centre for Value-Based Healthcare. It's a fairly recent organization. We're focusing on building AI models for clinical use. And as part of that, we also build platforms that allow you to train those models. And we also build the data pipelines that allow us to get the data to the compute and train those models as well. So yeah, if you've seen my talk earlier, I presented that we've open sourced Flip, which is the platform we've been developing for the last year. And Flower have helped us a lot get to that stage. And so we've open sourced it. We're looking for community contributions. So yeah, please get in touch.
Yeah, people should go to, is it Flip on GitHub, or is it?
Yeah, it's London AI Centre, Flip. Very easy to find. Otherwise, you can get a link on the talk or message me directly. I'll be happy to.
Yeah, that's great. If you could just take a step forward, just so, when you talk about medical AI and AI in healthcare, what are some of the exciting things that you see from the past couple of months that you are, excited to share? I know that you had a big announcement recently, but is there anything else?
Yeah, so we announced the Radiology AI Summit. We have since launched our first two clinician-led projects. So this is where clinicians have come to us with a project, with a research question in mind, and we've managed to prototype AI training code, and we've managed to find the data that will help those projects. So we've launched those clinician-led projects, and then we have a few lower hanging fruits for how are we going to create apps, or how are we going to make it easier for also researchers who want to train models on Flip to get started.
Okay, so more like a, one-click solution or like an easy package, something that people can use.
Exactly. I mean, I'm very excited to see the Flower App Hub being released, because I think our idea is to leverage that, and the idea that you could use potentially Flower verified apps on Flip is very, very exciting.
And in your experience, when you work, you said that there were some inbound clinicians that came to you and wanted to work with you. How does that, what are some of the aspects that they are looking for? Like what do they maybe not want to work in the terminal, or are there other things that they are asking for?
For sure. I think having an interface, a UI that's easy to use is definitely one aspect of it. I think that sometimes they are more out, they're asking for feasibility, so they don't know what data they actually have available, and we do that initial feasibility assessment with them. So if you have an idea that's part formed, you can also come to us. We'll do feasibility assessment, we'll see what's there, what we can do, and then take it from there.
You go out to on-site then and do some, you help them out then, or how does it work?
We also, because we've got those sites connected, we can do feasibility assessment from the platform itself. We can query the data that's available in the OMOP common data model, and we can see what kind of information is there for them.
Okay, and for the open source community, you said you have an open source repository now. Are there specific contributions that you're really interested in, and that people, if someone wants to start out and say like, this is something that we're really looking for, what should they look into? I mean, everything is helpful, I suppose.
Absolutely, yeah. So we've intentionally made Flip build on open source components. So we're using Flower, obviously, which is open source, but we're also using a lot of open source medical imaging libraries and medical imaging informatics components. We're using Docker, we're using Terraform, we're using Fast API. All of these are very well-used open source components. And we've got opportunities for contribution in all of those domains. So if you're more interested in coding apps that you can use on Flip, you're welcome to do that. If you're interested in enhancing what the DICOM staging environment can do, you're welcome to do that. So yeah, have a look at the repo. If there's an issue you think you could be a good fit for, please comment on that. If not, we can also help you find what's ready for you.
Brilliant. And if people want to follow what news about Flip and or where can they go to find that? Is GitHub the best, or?
I guess GitHub. We have we're very active there. We also have the London AI Center website where we post announcements related to Flip, and the London AI Center LinkedIn. You can follow us, the developers, as well. We've got Rafa also in the audience, who's a big lead contributor to the platform as well. So yeah, just keep an eye out, London AI Center.
So we're going to the main stage, but it was a pleasure to having you here.
Likewise.
Thank you very much.
Likewise.
And have a good rest of the day.
Thank you for organizing. It's been a great event.
Yeah, thank you.
Thank you.
We have Xuchen Wang, professor of AI at the University of Exeter. Formerly at IBM, where he served as a staff research scientist looking at applied distributed ML, LLMs, and other important areas that surround the FL space. We have Sajjad Khan, current NHS vice chair, and also consultant over at Swift and other financial services projects. Min Nguyen, technical lead for privacy enhancing technologies and leading the Cancer AI Alliance delivery team. And then Micah Scheller as well, who you just heard from, ex-Intel Lab security and privacy research scientist and current Flower principal engineer. Let's give a short round of applause for our panelists here. All right, so just starting things off, I think we have a variety of different experience here across the research side as well as the deployment side. So in short, where do you see the state of federated learning today, and how did you get into this in the first place? Why don't we start with you, Sajjad?
Good afternoon, everyone. So we're in the post-party session, right? Is that why we have a reduced audience? Everyone's overrunning from the party. So how did I get into federated learning? So As a consultant working with Swift in the banks, the use case was fraud. So the question of fraud impacts every single person in this room, whether it's your grandma, someone that's been caught in elder fraud, or it's someone you know that's been caught in a romantic issue, investment scams. The payment fraud numbers are staggering. Last year, payment fraud alone was 600 billion a year. That number is growing every year, and the banks and the whole ecosystem is throwing technology and people at this, and they can't seem to make any single dent in this number. And that number, I think, is soft for a number of reasons, because not all fraud gets reported. And secondly, if you look at all the indirect costs of fraud, the legal, the remediation, the fines, the work that you have to do to kind of fix it afterwards, you're probably looking at trillions of dollars. Now, every organization, no matter how big you are, realized at some point they don't have enough data to solve this problem on their own. You can be the largest bank in the world, have trillions on your balance sheet, huge numbers of customers, but you still do not have visibility. You probably have 10% of the transactions that your customers look at, because most customers, even in this room, have more than one bank account. You have multi-banked. You might be banked in multiple jurisdictions. You might have a bank account in Mumbai. You might have a bank account in Rome. You might have a bank account in Johannesburg. For one bank to be able to see your entire history is really, really challenging. So to solve cross-border fraud, you have to have some kind of data sharing. So that's really the project that Swift and others are looking at, is how do you bring cross-border data sharing? And obviously you come across the immediate challenges. Well, legally, can you share data even within a jurisdiction because of GDPR? Because this is really, really private data. And we talked a lot about healthcare, which I can talk about as well with my other hat. But you're talking about private financial data, very sensitive things that are on your bank statement that you don't want people to look at, what you've been spending money on, for instance. So this is really sensitive, and you do not want to flag someone as a fraudster, because if you flag someone as a fraudster prematurely, they get debanked from the whole system. So if you imagine every one of us today, I doubt many of you even carry credit cards. So I presume this audience doesn't carry debit cards or credit cards anymore. Everything's on your phone. So if you can't use your phone because your phone is connected to the financial system, you're shut out of anything. You can't buy anything. You can't do anything. So getting this right is really, really important. Getting the legal and the governance right, but the value is really, really important.
Thank you very much. Min, your perspective.
Yeah, so from our perspective, the current state of federated learning is, at least it's like an essential need for how fast AI is growing. And I think the issue is that we put so much effort in growing our model, but we don't put enough effort in growing our privacy and protecting our privacy. So from a perspective, so obviously I'm from the US. So from the perspective of US, a lot of time that a lot of models that have been launching out there isn't really a strong protection of like, well, are we protecting the data that we're using to, from like a row level or patient level, or are we protecting pixel imagery, every like perspective of like an actual model that's being launched, right? Because a lot of time you only think in terms of, well, hey, this model is great. It does what it needs to do. We have some encryption on it, and I think we call it a day. But the reality is, like, even in a federated learning system, there is also things such as gradient, attack, right? So the biggest concern in federated learning really is, to me, it's almost like your server, but your orchestrator, because that's where your gradients from individual edge node are being sent to. So I think the current state right now, it's a good start, and I do believe that a lot of technology and investment and a lot of smart people are putting efforts in protecting these things that we're overlooking, right? Because we assume that we have a federated learning system. We assume that's all we need to do, right? We call it a day. But there are also other pets tools out there, such as like differential privacy, encryption, and actually yesterday a bunch of the talks were gave me a lot of hope that we actually have a really good solution coming soon. So yeah.
Thank you. And Chen.
Yeah, I think the scope of federated learning has really grown over the last couple of years. We started with training models in a decentralized setting. But these days, if you look at the way AI is being used, I think really what means by a model, what it means by knowledge, I think has really shifted or evolved into things like in-context learning, for example. In those cases, it's like the context sometimes becomes an important piece of knowledge. And in that case, we have to rethink how we want to define federated learning. I think to me, at least these days, federated learning is no longer like training a model from private data sets in a decentralized way, but it's more like how to actually really federate every aspect of the AI toolchain that you can see these days, right? Where that would include things like data pipelines. It would, of course, still include the model. It would also include things like when you use a model to generate new piece of information or maybe new code or even research papers. So those things probably should be federated as well at some point because they are all meaningful knowledge that can be used to further improve the whole scope of AI and software development. So I think really what's interesting to see that's coming and what I personally felt quite interesting from all the talks at Flower and by everyone else as well, of course, is that so I think really we are getting to a point where federated AI can be used to facilitate interactions between the different parts of an AI pipeline. So in the past, like you have data scientists, they may be doing data curation, and then there's probably a separate team that is doing model-related work, and they will be training the models. But like with this whole kind of a super grid and also a lot of these merging of pipelines. So I think what we are going to see going forward in the federated setting is where all these different kinds of components can organically work together. So I think that's probably where the federated AI scope would go forward, I would say.
Thank you. And Micah.
Okay, so I will try very hard not to ask these guys questions, and I'll answer yours. So I got into it in April when McMahon's paper came out. I was in this research lab at Intel, and we had been doing confidential compute, and then we moved into machine learning as a really cool use case for it, and then we moved into adversarial machine learning because it's fascinating and we're nerds. And basically, when that paper came out, my manager came to me and said, "Check this out, read this, and let's talk about it this afternoon. I know you can break the crap out of that, but can you protect it? Can you protect it with SGX?" And I was like, "Oh, let me check it out." And the answer is, "Oh yeah, there's lots of cool things we can do with confidential compute if we build this right." So we set about, breaking and fixing and having fun. And it became really, really obvious though that the entirety of the analysis was dependent heavily on the data distribution, heterogeneity of the data, all of the issues that you really can't do or address with synthetic data or arbitrary divisions of some known data set. So I really needed a real world case, and a lot of people say they have data ready to federate and then they show up and they have nothing until I met the wonderful Spiridon Bacchus from now, who's at Indiana University at the time, University of Pennsylvania. And he said, "I want to do something where I train a model across all the hospitals, but the data stays in place." And we had a mutual friend who said, "I know this research scientist, he has this platform he builds for his own research that does exactly that." 2018, I'm deploying my research platform across 70 hospitals, and pretty quickly went from the attack defense scientist into the just generally, how do you make this work? Because I lost a considerable hairline during that time trying to track all of the governance issues across all these hospitals. So it's really kind of been this fascinating journey going from the attacker to the defender and then basically the guy who's trying to make the platform work to then the guy who's trying to figure out how to get everyone to play together. And in terms of where we're at, I would say I agree with a lot of what you said, but for specifically federated learning, we're still in that how do we get everyone organized stage. And there's still a lot of cheese down that hole. So while I'm all for exploring all the awesome new agentic, mixed workflow stuff that we're absolutely going to be doing because it's going to be awesome, I still think that we need to go ahead and go back and productize that stuff we were building in 2017 and 2018, because there are a lot of really good models to be built with just the good old stuff, federated learning on a CNN with the right protections in place and enough data. We'll start doing new cool things. So anyway, I think we're kind of still where we always were, still facing the problem of organization, and that's still worth chasing.
Some really great perspectives here to see the conversation. On that point around having a strong principal investigator who you can form these federations around, for others who have been part of, say, the Cancer AI Alliance in Min's case and some of the SWIFT problems that exist for federated learning, does it have to start that way with a single institution that's starting these things, or can a group organically come together to form these federations?
Well, I think it's the group, because if you want to go fast, go alone, but if you want to be successful, go together, right? Federated learning by definition, if I just give you a case study, in the NHS in the UK, 4 hospitals, I think in 2024, came together to share some patient data around COVID triaging. So this was like, you go into a hospital, they don't know whether you've got COVID or not because the symptoms are all the same. And they need to triage you quickly, because if you do have COVID, you need to kind of be in a separate part of the hospital. So obviously one hospital with its patient profile doesn't give you the diversity to be able to kind of give you that triage value. So this, just using 4 hospitals, and these were like hospitals in different geographical parts of the country with different community mix, I think the results were like 28% better using just 4 hospitals. Now, the NHS is obviously hundreds of providers. So if you could get even the NHS in the UK to do that. Micah, I think you mentioned rare child pediatric cancer. You're right. You're looking at handfuls of cases in each country. And there's just not enough data in one country to be able to do that kind of successful value. Whereas if you could share those small numbers of cases across the world, you are literally saving lives here. It's not about some abstract technical paper that you submit at a Flower AI conference. This actually can help save people's lives, or in the case of fraud, save people's money, but it also protects people, because a lot of people who are victims of fraud end up committing suicide and whatever. So these are real world problems that organizations have to come together. I suppose there might be a question further down the line, what is stopping? So I don't want to front run this, but what I've seen both in the private sector and the NHS is organically you have to bring an initial group together, because otherwise it just doesn't kind of scale. And if we want to move from kind of experiments and proof of concepts to real world value, then I think you need to start, even if it's with a small frontier group. I think that then allows kind of the economies of scale to work and more people will join.
And Min, what have you seen in your experience?
Yeah, so I agree with the scalability part of it. I think before we even get to a small cohort of organization to join an effort, I think the bigger part of it is actually really governance and policy. A lot of time having organization, from either even within domestically or across, internationally, the biggest challenge is that, right? The technology exists, right? Like you have Flower, you have NVFlare, you have all these great framework, and even in the world of confidential computing, and actually I'm glad you brought the whole CC in the conversation, right? Because I think that's actually another component of federated learning that we're not heavily looking at, right? We're assuming that aggregator is safe, that everything is good, right? But I think really once you get the cohort, you really have to get them all to agree on the policy, right? What is it that we can do with it? What can we, what can't we do? But also another big piece of it is enforcement. How do you enforce these things, right, between organizations? Because at the end of it, sure, there is, I forgot someone mentioned yesterday, but of course there could be a contract, but if you can't enforce it, then I think it kind of missed the point, right? So once you get everyone to play nice together and willing to, hey, I'll join this cohort as a proof of concept or a test, right, to kind of start out. Then once it works, then you kind of start to invite other people to the party, right? The party then start growing, right, and then become a real party. So maybe like an actual festival of sorts. but yeah, so I think the first part is really just to get everyone to join together, agree on a common data standards, like OMA, for example, right? And like, governance and things like that. The things that aren't as sexy, like, what you mentioned earlier. So
I'm glad you brought up data formats because that's always a challenge from my experience with federated learning. For healthcare, I think that OMOP is certainly one of those. I mean, how do we figure out and how do we communicate across others in different domains what they need to be mapping to?
So before I actually answer anything, I do want to kind of throw out, I don't want to get myself in trouble. So officially, I'm here on holiday, right? So I don't want to be a representative of like the Cancer Alliance or even where I work, right? So anyway, back to the question. How do you get everyone to like agree in a standard? To be honest, from what I've seen in like various deployment of federated learning, I think the easiest path is really to kind of look at individual organization data schema, right, and database, right? What can you offer? What can you offer? And you have to be realistic with what you have, right? I think the challenge is that a lot of time our organizations tend to come in and like we're probably just overly optimistic, and we believe that hey, you need this data schema, data structure. I can probably get it working, but then really the reality is that behind the scene, sometimes we don't have enough resources in terms of like data engineer or like not just compute resource, right? Resource of like the manpower to actually do it, right? And maybe in the future you have agentic workflow coming in, solving all of these problems, which can solve some of these problems, but regular data set, right? But you're talking about like healthcare data and like especially when you get into like ecologies and all these complexity of it, is not that direct where you can just go, hey, my agent can map this out for you, right? It's something that you need, SME, right? Special or like researcher that's been in the field for a while. So I think it really starts with, can my organization do it? Do I have the resources to do it from both perspective of knowledge and compute, right? So I think that's where it probably starts.
Okay, yeah.
Yeah, absolutely. So the FETS initiative, which was these 70 hospitals that were not in the same network and scattered across the world. I'm going to probably get this wrong. I want to say 7 months to get all the data lined up, to get all the cases counted, to get everything ready to go. 2 weeks to train, right? Who cares about train time? It's irrelevant in that scenario, right? I am going to make a liar of myself and turn my statement into a question, which is, so you talked about like, do you need a charismatic PI or what's the way this can happen, move forward? The thing that I've run into over and over and over since the beginning in everything outside of medicine, and it's in medicine too, but not just much less so, is the first mover problem, where basically the banks all want to do it, but they all want everyone else to take the risky first step. And what I've been hoping is that medical research, which has a mandate to not do that and to get things done, can be the first mover for the healthcare networks and payers. Is there any hope that if those people find success, they can be the first movers for the banks, for energy, for industry and oil, so on? Or am I just crazy? Is that never going to work?
Can I address the banks issue, or do you want to come in?
You can go first.
Yeah. So this is the number one problem I'm having. It's yes, governance, data, legal, culture, technology. I'm going out on a limb, all surmountable problems. The biggest challenge is incentives. How do you get people to come into this? Because it isn't just, no regulator is going to force people to come in. There is some, in Europe, for example, there is in the payment space a piece of legislation that's passing through the EU ecosystem, which may mandate some data sharing for fraud, but it's only going to be in the European Union. It's not going to be global, so you still have the problem globally. I think you have to really focus on what's the incentives, because a lot of the banks think there's a competitive advantage in not sharing. I never understood the argument, but it is an argument, and you have to kind of deal with it. But from my perspective, I think you have to kind of appeal, certainly in the private sector, because in the healthcare sector, there's a bit more of a purpose, and I'm here to do the good for mankind and all of that. In the private sector, it's very ROI specific. So banks are looking at their cost of dealing with it today, their ROI. So if you can say, look, this will reduce the numbers of false alerts, this will reduce the numbers of operational costs that you have, this will increase your detection rates. If you can prove to them that there is value in this data, then I think you have at least a chance. And I think it's up to whoever's kind of pitching this to get that kind of pitch right.
Yeah, I think something that's also worth thinking about is this the problem for federated AI itself, or is it just a generic AI adoption problem, right? Because if you ask organizations whether they want to use AI in their processes, then many organizations would hesitate about that as well, just because of all the risks involved, and maybe you do something wrong, then that could be a big news or whatever. But then what we are also seeing is that the employees of those organizations, they might be actually the ones who want to start using AI because it improves their own productivity. And I mean, I think that's something also quite interesting to think about. And if you, if you talk about federating things, then I think we could also ask ourselves, like, whether this should be something that's driven by organizational needs, or is that just driven by personal productivity needs, right? Because if I can automate my work, maybe using 50% of AI, and then I can do more things, or I can enjoy life, whatever, then that might be also a good incentive. So how to empower the people to actually embrace new AI technologies, and with their organization's support. So the organization should not say that you cannot do that, but the organization should say what you can do with AI and what you cannot do with AI. So in some sense, some kind of governance of AI usage within the organization, I think that could be also something useful. And I think another point is, so thinking about data curation, I think in many, like, people who have experience with training large AI models these days, I think they would know that, as what you are saying, so data itself is something that's very labor intensive. Like, how do you make sure that all the data, they are following some kind of standardized schema that can be understood by the model. And if you have data from different years, like from different legacy systems and so on, so that makes the situation very complicated. But I think in that case, it's like, I think federation is one part of the problem, but the other part of the problem is how can we develop automated pipelines to make data processing much more efficient compared to what we are doing today. Because it's a very messy domain, depending on what data you're looking at, you could be relying on very different kinds of domain expertise. I think that would be difficult. But I think if there could be some common principles or maybe some shared protocols, like if you look at communication networks, we have protocols in many different kinds of layers, and for different services, you have different protocols as well, right? So now, can we have a common protocol for connecting your data to some federated platform, let's say, or maybe just generic data processing itself? If everyone tries to do things in a similar way, then it could be easier for people to work together.
I just want to add one thing in like the incentive. Incentive do exist in like healthcare as well. Is I think the only difference is that you think in terms of like, well, does it help improve our reputation, right, of my cancer center or my my hospital and so on, right? But does it also help potentially bring some eminence to me? Like, are we publishing a paper from this? Like, what are we getting from this, right? So I think when you look at incentive, I think it exists really in both like financial and healthcare. It's just different form, right?
Yeah. So that's a great point. I mean, at root, it was Spiros has a million friends, but all of them got to be on a slew of papers. Yep. By just attaching their data, they got a pile of publications.
Just another incentive for healthcare systems. So across the globe, we know there's a demographics problem in healthcare, right? So people are getting older, they're getting sicker, chronic diseases going up, and at some point, you just don't have enough workers coming up, especially as most countries are now closing and tightening immigration. You're going to have a healthcare funding. Was that a translation of my talk? That you're kind of simultaneously translating it? So at some point, the economics just don't work in terms of taxpayer funded. I'm not talking about the US, obviously a different system. Most countries in Europe are running some kind of taxpayer funded, insurance funded systems, right? So the only way you're going to make the economics work is prevention, right? Preventing people from getting sicker, therefore less reliance on. How do you actually change the curve on prevention? Are there any doctors, medical doctors in the room? Anyone? No? Are they all techies here? Okay. So if you look at, for example, just take something like frailty or chronic kidney disease, there are different stages of those disease in terms of progression. If you can build the AI models to kind of learn from previous patients about when to intervene, when to kind of diagnose, when to kind of alter the medication mix, when to bring people in because they see these symptoms, you can fundamentally bend the curve around prevention. That's not the kind of silver bullet because we know there's a lot of diet and other lifestyle stuff, but that's a classic example of how you could kind of get the incentives to save money for governments if they spend more in kind of AI models around prevention. And those AI models are only going to work if you kind of share data across the different networks and
So going from there on the incentives front, I think that there's both monetary as well as non-monetary incentives that can be applied for how you get participation in these federations in the first place. I think that the matchmaking between these different groups has always been a bit of a question. What is the best way to go about that?
Matchmaking between
between the people who benefit from training of federated models.
I can't tell you the best. I can tell you what I wish I could do. Maybe
we'll start with that.
Okay.
With that.
So to your point, I mean, the silver bullet in the U.S. where we are barbarians and it's all the private payers that decide what gets done and not gets done. What you want to do, if you could, is you take the actual payer metrics and you couch everything you're offering in those metrics that those payers analyze before they shell out money. It's also, there is some the government too, right, with like Medicare. If you can actually hit those metrics in your analysis, that's gold. That gap between whatever we can measure and show on our AI algorithms and then the actual metrics that are applied to determine what money goes where, if I could somehow bridge that, I feel like I could make the incentive point so much clearer and stronger. But I don't have any real idea how to do that.
Any other thoughts?
One of the biggest problems is actually a very, very technical issue, but it's really important, is just the way that financial business cases are presented in organizations. So if you take something like prevention, that might have a 10-year payback, whereas you only have 1 year of funding in the NHS, for instance. So, and if you go into private sector, the CFO is sitting there looking at his 3-year view because by definition, he might not be there or she might not be there for 3 years later. So they're not interested in a long payback. And a lot of these things end up creating the benefits over the medium and long term. So part of the challenge is the way we measure and the way we kind of do financial business cases and financial mechanics. So that's another problem that we've got to kind of have some cultural change around, is how do we kind of measure the long term. So in your case, in terms of the cancer, yeah, there might be the return there might be soft benefits in terms of reputational, thought leadership, being seen to be kind of a good community citizen. But if you're looking at hard financials, it's really difficult to kind of deliver the returns in the kind of short time periods that, someone is looking at when they're launching a new factory or a new product or whatever. Those things tend to kind of be much harder, whereas this tends to be much softer.
Yeah, I think I agree with what was all said. I think we need to have some use cases where we can see short-term return. And that could be something, maybe something like, I think this medical example that we saw in the talk earlier today, I think that was good, like having a dashboard where you can immediately show that you can have better statistics covering more cases and so on. I think those are good examples. And maybe, let's say, if people collaborate in coding or maybe some specific tasks in a federated way, then they immediately see the benefit. I think training models, again, that's something that would require some longer term to see the effect. But probably thinking about what kind of use cases are there, maybe multi-agent collaboration to solve some specific task that's hard enough that requires having multiple agents instead of one single agent, right? So once people see the benefit of participating in some federated cohort, then they will probably think about longer term effects as well. So maybe that would gradually encourage people to participate more. But I would say start with something that for which the short term effect can be seen pretty quickly.
Yeah, the one thing I was gonna add in is in terms of like short-term benefit, at least the way I've been looking at it is if you think in terms of like training, the cost of training a model for an organization become much less, right, for their project, because then that is now dispersed between all the edge nodes that are in your federation. So that's one way to look at it. Like, hey, there is a true metric that you get per project or per impact that you're trying to deliver. In training that model, right? Because you no longer require, let's say, 50,000 GPU hours, right? Whatever that cost might be, right? Your project now requires maybe only 10,000 hours of your GPU versus 50,000 hours of your GPU, right? Because other organizations will kind of support that. But in return, the other organization get the data that you offer, and also per project will be less, per training session and so on. So there are some, I think, return in federated learning if you're looking from like, I guess, a computational perspective of it. Sometimes it's human being in general, we like to kind of recognize the short term as like, something like quick money or, something a little bit more tangible, but I think there are a little bit more, other short term benefit as well. So.
Great insights here. I'm curious if there might be some questions from around the room of people that would like to ask. The gentleman here.
We can pass it out.
Hi, so my name is Michael. And one of the common thread that came out is that there's a problem really in regulatory clarity. That's one of the main hindrance in adoption. And is there an effort or an organized effort from the open source community to tackle this?
Yeah, I mean, I can talk in the financial sector. So there was recently a UN held, for example, a fraud summit. So in the context of fraud, there is an organization in the UK called CIFAS. Some of you might have heard about it. It's a global database of financial. They are looking for an international fraud data standard sharing. So they want to create a global standard, whether that's run by the United Nations, the OECD, the Financial Action Task Force, whatever. But they want to kind of create legal certainty, because what we can't do is every organization has to create a bilateral data sharing standard with another organization. That literally takes weeks, months, and lawyers, as you know, in the data privacy space, they charge by the 6-minute increment. So every time you do this, you kind of end up reinventing the wheel. If you can create, in this case, it would be fraud, but you can replicate this for other sectors and other use cases. So having some kind of global, now, how easy is it to get the global standard? I mean, that's another argument. But the problem is every part of the world is operating at a different speed. So in the US, you're kind of actually deregulating at the moment. You're going the other way. Even in AI, the US administration is creating principles and doesn't want the states to get involved. You got Europe with its EU AI Act. You got the UK with its principles-based approach. You got Singapore, China. everyone's kind of got a different flavor of it. So if you're a global institution, you want to do federated learning cross-border, it becomes an absolute nightmare to kind of navigate that. So, if we can get some kind of international standard, that would be great.
Yeah, just briefly, in terms of open source communities, this is absolutely in the crossroad. That's a horrible way to put it. This is being looked at by people at ML Commons. It's something we talk about a lot. One of the people in the medicine working group is an AI lead at St. Jude Children's Hospital. He's the one who's been talking to me for years about pediatric cancer before it entered my life directly. And essentially, trying to find the right way to capture policy and define those correctly with, say, the FDA, or at least get the FDA to nod their heads like we like this. It's kind of like the direction that we're trying to walk it is, we want to capture something that if you follow this set of guidelines, the FDA is going to be like, right? And that's kind of a baby step toward it. I'd like the government in my country to stay stable enough to do something like this, but we are trying.
Saw a couple other hands go up. Gentleman back here.
Hi, thank you. Let me just grab my notes. So a common theme was all about incentives. And I think this comes up time and time again. All the panelists, everyone, conference you go to talk about incentives. My question goes back to almost the adoption of the internet. So everybody, I say everybody, a lot of people use the internet now across the world. And it seems like the incentives are aligned. Will the same thing happen with AI adoption? Is it natural? Does there have to be some kind of, alliance, or are we going to see the same kind of, it's hard for you to tell, but do you think we're going to see the same kind of path with AI adoption that we saw with the internet, if it is this big thing everyone's saying it is?
Yeah, I think, in my opinion, I think the reason that the AI, that the internet became popular maybe fairly quickly is because people want to connect, right? So that's like a basic human need. And for the same reason, social networks became so popular, maybe within a fairly short of time as well. So I think for AI, at least from maybe a more of a human perspective, it's like we want to find those use cases which align very well with the basic human needs or maybe desire. And I think for that reason, everybody is using chatbots these days, like ChatGPT or whatever, Gemini, whatever, right? So because we want to find information quickly without having to do search ourselves for an extensive period of time. So now for federation, I think probably that's the same question. So what is the basic thing that brings together humans? So if you talk about individual people participating in the federation, so what's the basic desire that brings together people? I don't know what's the answer yet, but I think that's probably one direction to think about. And I mean, the same for organizations. I think for organizations, the path might be clearer. Like if you're hospitals, you want to find better ways to treat diseases and so on. But of course, there are other regulations and some of those things to be very careful about. Yeah, but I think speaking about incentive is probably all like what do you need and what are the risks? So if you can balance those in a nice way, then you would be participating in the federation.
I think with AI adoption, to me, it's kind of equivalent to what was said right throughout the theme, right? AI is like electricity, right? So to me, in a way, it is, right? I can see AI adoption being equivalent to the internet. I can see it be equivalent to social media. The biggest gap really is, it could be, but it's not quite there, right? Because you get a lot more skepticism from folks that are like, well, I don't want to send my data. I don't want to send my personal information to these bots. So then that's where like the whole wave of, well, now you can localize your model, right? You can host your model. You can use things such as like the Sparks, your Jetson, and like there are various ways, right? And you can also actually it's so easy now to actually host your own model on Azure, Bedrock, Gemini, et cetera, right? So I think eventually it will become like the internet, and if it's not already, right, I wouldn't be surprised, just because of the rate and how fast it's going, right? And I think I see people using it for basic search, right? Like instead of Googling, I've heard my nephews going, I just chat GPT it, or I open AI, and I'm like, I didn't even know that was a verb, right? I mean, so I think yes, I do see AI adoption being a thing. It's just a matter of like that one little maybe like privacy component, something is missing to really like catapult it to that internet comparison, right? So.
All right, I think we might have time for one more long question or two short questions. Gentleman up front here.
Thank you so much for the great debate. It's a statement maybe followed by a question. So I believe that federated learning make a lot of breakthroughs that it become a paradigm by itself. We're talking about an ecosystem now. We have techniques and approaches to deal with the data at the client selection and participation, the aggregation algorithms in the server, the communication efficiency, security tailored for federated learning, blah, blah, blah. So federated learning has become an ecosystem by itself, right? As a practitioner for federated learning and researcher, my question would be to industry. We are in a poker table and you want to say, okay, I'm all in for federated learning. What is the one thing that you'd like to see solved? Is it security? Is it efficiency? Is it optimization? What do you want from us to solve?
I have a couple. Well, I mean, I probably have a laundry. I have a wish list, right? But I would say probably making things more scalable is probably the biggest concern. What I've seen in in like production or in deployment wise, when I say scalable, you can look at it both ways. You can look at it scalable of the individual edge node, right? Because you can't expect individual organization to have their edge node up 24/7, compute, cost, and etc. Right? So you can look at it scalability from the edge node, but also scalability in terms of like the aggregator and like as you scale it, like how do you secure it, right? Like if you start running, like say homomorphic encryption. Sure, it's been proven that it's getting faster and faster, but to me, that's not really practical, right? Because like you have researcher in medical or different like industry, they will probably constantly, like the question I always get is like, well, how slow would this be if I add this, right? So the utility between benefit, like not the utility, but like the utility and the cost of it, like is it practical, right? Like if we can solve that, the scalability in both of like the actual aggregator part, but also the individual edge node, I think that will help make it like like an actual thing, right? So like that everyone will use. So.
Can I just say one thing? Awareness. I mean, this room doesn't need any introduction to this. You go out into the wider technology rooms, a lot of people still haven't heard of privacy enhancing technologies. They certainly haven't heard of federated learning. You go to legal audiences, which I've sat in, regulatory, maybe you get 10% of the people that are aware of that. So this is a really powerful framework. I'm absolutely convinced it was going to hit prime time at some point. But the problem is we just do not have enough education and literacy around this. And we could talk about all the other things, but we've got to get the awareness up, especially in kind of audiences which are decision makers around this. Because, it solves a lot of problems. Like, for example, if you move the model to the data, you're not having arguments about sending data across organizational boundaries. There is a lot of value in that discussion, but just getting that awareness up.
I think one thing that's probably also important is computational hardware. So, because now if everyone can run their own agent on their phone, for example, right, then there could be much more incentive for people to collaborate. Now, today, because most people use AI through the cloud, then people think, they are already in the cloud. So whatever I contribute, maybe that will be used for training the next model anyway. So why should I create my own kind of way to collaborate with others? Yeah, so I would say hardware maybe.
All right. Well, I think that we're just about out of time. So Micah, Shichen, Min, and Sajad, thank you so much for sharing your insights with the Flower community. Can we get a round of applause for our panelists? And with that, I'll turn it over to my colleague, Sean Shen, who will introduce our next speaker.
All right. Well, the guests are, we're clearing up the stage. So thank you all for staying. The next speaker we have, it's my pleasure to introduce to you Meng Yan. He is a senior software engineer and has been working with the Flower framework, as well as he's also one of the core contributors to the Open Cluster Management software. So for those of you who are not familiar with it, Open Cluster Management is another way of orchestrating your Kubernetes-like deployments. So that means he's worked with a specific add-on for Open Cluster Management that is able to deploy Flower in a much more scalable way. So I'm very excited to hear what he has to say, and I believe he has a short demo to show as well. So with that, I would like you to please welcome Ming as well for his presentation.
Hi everyone, I'm Yan, a software engineer. For past few years, I have been focusing on multi-cluster management. Today, I'll be sharing how we can scale Flower AI for enterprise environments using Open Cluster Management. We will go through 4 parts, starting with the challenges in distributed systems, then how Open Cluster Management tracks them. After that, how Flower and OCM work together. And we will finish with a live demo. Let's start with the challenges. Distributed systems like multi-cluster or federated AI share a common trait. Subsystems are spread across different networks, regions, and organizations. This introduces several fundamental issues. The first is stability. Any node or cluster can go offline at any time. The system needs to tolerate that gracefully. And next is the security. Connection must be secure across network boundaries. So we need automated security connections at scale. And others like how do we deliver workloads to right target nodes, especially when not all nodes are equal. Some have GPUs, some hold specific dataset, so we need intelligent decisions. Those are universal problems. Now let's see how Open Cluster Management addresses them. OCM is a Kubernetes multi-cluster orchestration platform. It uses a hub-spoke architecture with pool-based model. There is a hub cluster as the central control plane, and a managed cluster each running an agent. Those agents pull their all workloads from the hub and report status back. This pool model offloads the hub, and the autonomous agents think independently. So if a cluster goes down, existing workloads on other clusters keep running. That handles the scalability and the stability issue. Besides that, it also provides the work API to distribute workloads across clusters, and the placement API to schedule across them. For flexibility, it provides a pluggable add-on to let you deploy your customer business logic across your cluster fleet. And the add-on is how we integrate Flower with OCM. Let's see why they fit together. That is, OCM natively supports the Flower architecture. Both use hub-spoke pool-based model. The superlink, just like the hub control plane in OCM, acts as the central coordinator. Supernodes play the role of autonomous agents on each cluster. And the Flower's applications maps to the work API instance in OCM. Same architecture and network topology, so no extra changes are needed. This is how to deploy Flower with OCM. We use add-on framework in OCM to deploy supernodes across clusters. and the work API to distribute application to them. Placement handles the scheduling for both, deciding which cluster get supernodes and which get client applications based on the cluster attributes, like GPU availability or dataset readiness. Let me show you how this works in a live demo. Let me walk you through the demo. We will start by setting up an OCM environment, then define the supernode with OCM add-on and schedule them into the right clusters. From there, we will distribute the Flower application and submit the training task across all of them. Okay, let's start with the cluster setup. I'm going to create 3 clusters. The one on the top is the hub cluster, which manages the 2 below it. Once they are up, I will initialize the hub cluster. Then let cluster 1 request join into the hub, and also the cluster 2. Then let the hub accept the joining request from cluster 1 and cluster 2. We can see the hub control plan is running, and the 2 managed cluster, cluster 1 and cluster 2, are also available. And we can also see the agent control plan running on each cluster. Next, let's define the supernode with OCM add-on. Here we use Helm-chart to enable Flower add-on. Once you run it, it spins up the superlink on the hub. The chart uses the template to define the Flower add-on. In this template, you can see the supernode container includes the superlink address, a customer cluster name, and an internal service exposed for client application to connect. In OCM, we use a cluster management add-on resource to register this Flower add-on into hub cluster. You can see it has a placement. So we have the add-on template to define the Flower add-on and use cluster management add-on to register it into the hub cluster with a placement install strategy. Now let's see how placement controls where supernodes get installed. Here is the placement for Flower add-on we just registered. It selects only cluster with the GPU label, and right now the cluster count is 0, so no supernode is installed yet. Let's monitor supernode containers on those clusters. Then enable GPU resources on cluster 2. You can see it immediately picks up the change and starts installing the supernode on that cluster. On the hub side, a management cluster add-on has been created in cluster 2 namespace, define configuration and collects status from that clusters. Let's do the same thing for the cluster 1. Now both add-on instances are enabled on cluster 1 and cluster 2. Let's check the logs to confirm everything is working. We can see supernodes on cluster 1 and cluster 2 are up and running. They each exposed an endpoint for client application to connect. The superlink said both supernodes are showing as active. So with placement, we can dynamically scan and provision supernodes across clusters based on cluster attributes. Now let's distribute the Flower application. First, we install the server application on the hub. Then we use OCM's work API to distribute the client. Here we can see the requirement for the clients. The Flower add-on must be available and the CIFAR10 dataset must be ready on the same cluster. Let's monitor the client containers on cluster 1 and cluster 2. Both supernodes are already available. Now we need to prepare the dataset. I add a label on cluster 1 to indicate the dataset is ready, and the client gets created on cluster 1 right away. We do the same thing on cluster 2. Then let's check the work API status. It shows 2 clients applied and 2 are available that matches those 2 clusters. Let's submit the training task to the super link on the hub cluster. That wraps up the demo. We have successfully submitted a federated AI training task across multiple clusters. That's everything I wanted to share today. On the left, you will find the detailed resources for Flower and OCM integration, and on the right, that is my QR code. Feel free to scan it if you have any questions. Thank you, everyone.
Yeah, so I appreciate that that might seem like a lot, but what he actually has demonstrated is actually end-to-end deployment in Kubernetes and also executing a workload. So I think it's pretty cool. If you have any questions, feel free to reach out to Meng. I think he has a QR code. You can also check the recordings later on once all of the recordings are up online live. In the interest of time, we're going to move on to the next session. I'll hand over to Nick to land the plane with the next and final talk.
Okay. Hi, everyone. What we've done is we've saved the best for last. And so we have one more talk to go in Flower AI Summit 2026. And it's an honor to have Quan Nyang from Jakarta ISGlobal. He is going to be telling us about a system called FloraLab. And so FloraLab is examining how we can go about removing day zero friction when you're deploying FL on an HPC system. And so I'm really curious to see how this all works and what it can do for everyone who's interested in FL. And so I'll hand over to him. Thank you for joining us.
Thank you, Nick, for the warm welcome. So it is a little bit irony because now is the last session of the last day and we're talking about the 0-day problems. So I hope that everyone is not very hungry for the next 10 minutes so we can continue. So my name is Quan and I'm currently the co-founder of Jakarta ISGlobal, and we are a legal tech company. So I would like to introduce a little bit about Jakarta. So we do is a laws and code engine for immigration law in Germany. And while we are building this, we also ask ourselves, okay, for law, it is very firm, especially in Germany, it is civil law. So you have everything is coded in the law. And what can we do if we want to apply AI? And then we go to a hackathon, and then I met Chin and her professors at TUHH, and we are working together to see how we can use AI, especially federated AI, in laws, and that is how we are coming together to see if we can have researcher to deal with the problem that we facing from day zeros. So you may know the current landscape. We have Kubernetes. Flower can deploy on Kubernetes, on Docker, on OpenShift, and you've seen many demos doing so. But what we want to do is also to put one more technology into the stack is Slum. So why we are doing that? Because when you look into the current status quo, 65% of the HPC in Germany, especially also in Europe, is running Slum. And we have 10% annual growth of academic HPC, especially in Germany university. And 25% of the HPC GPU is currently being underutilizations, meaning that it is being left unused. So we have the compute there, so why not bringing it to everyone, especially researchers? Now, when we look onto that, before we describe the problem we face from day one, we want to see, okay, what is the current Flower deployment models? So everyone working with Flower, so you already know we have SuperLink, SuperNode, SuperSX, and we need to connect all of those pieces together So they need somehow to have a kind of orchestrations. So when you spin up supernode, you need to know where superlink is running. You need to know how it can connect, which port is it. For the standardized environment like Kubernetes, everything can be easily automated. But when you go onto Slum, there is a little bit of a challenge. On Slum, it is a community-based computing platform. So you cannot just execute your compute workload. You create an SBash script and then submit it to a Slum queue. Then you need to wait. And this way is unpredictable. So you don't know when the superlink bash script is gonna be run and then returning back the information you need to spinning up the supernode script. So that is the first problem we are facing. The second problem we are facing is the port, so the conflict of resource. Imagine our current HPC in TOH8, we have 4 GPU nodes. And if we have an increasingly numbers of researchers trying to run Flower AI experiment on the HPC, then they will be fighting with each other on the port of the superlinks. So everyone wants to spin up a superlinks, and everyone wants to bin to ports 9091. So how can they resolve it? One solution is they just submitting the job, waiting it for coming back. If there's an error, they create a new one, trying to find another port. Now we can conclude that running a Flower experiment on Slum is some kind of a repetitive time blocking task, and this is not guaranteed to be finished. So we want to tackle that with Flora Lab. So I just put the diagram here so that it looks a little bit more technical, but basically Flora Lab is helping you to orchestrate all of these things. So it generates the SBash script on premise and then waiting for all of the job to coming back, filling the information and then scheduling another SBash script. Also to allow the researcher to submit the Flower app bundle to Superlink control API, then there's need to be some kind of a reverse proxies, because you know that from your local machine, the only way to get onto the HPC is through the login node, through SSH, and that is the only connectivity that we have. So we also spin up a SSH tunneling. So in general, Flora setup is just a control plan for the HPC. It is running on the login nodes and then trying to orchestrate all of the steps. Now come to a live demo that we currently have. Is the first thing is you adding your cluster into Flora, specifying the connections. I'm sorry. Okay. Yeah, we have a little bit of a problem. Maybe it's this one to go to the party early. Yeah. All right. Thank you very much. So you can see that it's very easy in 3 steps. So the first one is you connecting to your clusters, adding all of the information. And then preparing step is to spinning up the control plans. And then you're adding a stack. So basically a stack is the Flora stack, including the Superlink and Supernodes. You're choosing the partition of the HPC, which is including GPU. and then adding the module. So here adding CUDA and Anaconda because we need Pythons and CUDA for the trainings. And then after that, I start the stack, and it will also edit the Flower config. So now you can just run your Flower applications connecting to that stack. And as you can see now, your Flower application is running on the HPC. So for next step, and also for call to actions, we are currently trying to improving this one, because this is something that we made to use for ourselves, but we also want to share it with everyone, especially researchers in the university. And we want to also invite some more tester and early adopters, because we know that for every HPC, the environment is a little bit different. So not all of the environment is the same. I have the access to 2 HPC, one in TUHH and another in University of Kiel. And at the moment, it's not working with the University of Kiel HPC because they have very much different environment there. Then we want to release a beta, but now we also need more collaborators. And especially because of yesterday, we just note about Supergrid. So there's a little bit overlap between the 2 projects. And that's why I also want to call for collaborations. Maybe we can bring this to Supergrid as well, so we can have more computations from the HPC connecting to Supergrid and then allowing for many people to use. So that's it from my presentations. Thank you very much. If you need to connecting to the project, please scan the QR code. Thank you.
Thanks so much for the talk. Really interesting stuff and important to bring sort of this computational element to things. Do we have any final questions? We do have one. Okay.
Thank you so much. Maybe my information is not so updated, but have you tried containerization technologies for on top of Slurm, like Obtainer, Singularity? It used to be Singularity. It also addresses a lot of such problems. Have you compared it against such platforms?
Yes, there's because why we're doing this, because in our HPC we don't have Singularity, we don't have Kubernetes. So what we only have is only Slurm, and every time we need to do something, then we have to schedule a job, and then we have to wait. So sometimes the waiting is only 1 to 2 minutes, but sometimes we could wait for hours. So yeah. Yeah.
One question here from Chongshen.
Hey, Con. Nice talk. I like the technology. I'm very curious. You showed that you ran it in a deployment runtime, which means you deployed supernodes. But that assumes that the data sets all sits in the same HPC. Have you tried Flora with inter-HPC connectivities? So running supernodes in different HPCs?
Yes. So if we want to do inter HPC, then we will gonna move the superlink to another one level up. So it's not the superlink is not running inside the HPC, but now it's moving outside, and then the supernode from 2 HPC can connecting to that superlink. But yeah, we need to do something more to achieve it. Now the question for that is how we gonna handle the data if we're running on multiple HPC. Yeah, but we can talk about that later.
Okay, thank you so much. Let's thank the speaker again. Okay, so that's it, folks. We're kind of getting to the end of the proceedings. I was just calculating, I think we spent over the last 2 days about 20 hours together. If you count from the fact that we launched from about 10 a.m. on day 1, we went all the way to about, the last people were in the reception venue at about 10 p.m. And so that's a long day. And then today we've done it again. We've gone from the morning all the way to the afternoon, and it's been packed, 20 hours packed of content, of launching, all in service of building what we think is the future of AI, which is collaborative AI, and showing how we can do it more simply, build out the infrastructure piece, build out the agents, build out the models. We've seen so many people actually building
on Flower and building on these collaborative principles today and yesterday. So I just want to say thank you to everyone who has physically come, jumped on a plane, jumped on a train, driven a car, got on the tube, or everyone else who has quite not been able to manage to physically travel but has joined us online. I was talking to William already this morning, and he was saying that there is even more people. This morning we had more people up until that point had viewed our stream than the entire whole thing last year. So thank you to those who've been with us so much online. And stay tuned, and we'll be back next year with something even bigger and better and with more announcements. So thank you, everyone. I'll see you next time. Bye.
And that's it, everyone. That is Flower AI Summit 2026. It's been a massive pleasure having everyone tune in online, as Nick was also saying. It's been great meeting people here on site in London, and we are looking forward to be back again next year. To summarize, we do have we have seen so many presentations in various fields of federated AI. It's been coming in from medical, different infrastructure pieces, talking about examples and how to use the latest technologies coming out of Flower Labs and other partners. So definitely stay tuned for more. We are, as always, very active in Slack. So that's where you can find us 24/7. Go to flower.ai/join Slack, and you'll find us there. Then you can also, we have a discuss forum for longer thread format. This is Flower Discuss. You will find everything you need on our website, and the magic happens, of course, on GitHub. This is where you find the open source framework, the Flower framework, where you can contribute, add ideas, examples, raise things that you think should be in there, and talk to us through this. So we are looking forward to everyone who wants to contribute to this and everyone who is a part of the Flower community. Thank you again. And with that, I would like to conclude this year's iteration of Flower AI Summit 2026. We will be back next year, bigger and better, and looking forward to seeing you all then as well. Thank you.